uh, focuses on studying the vibration behavior of viscoelastic plate whose thickness varies linearly in both directions. Now, now I would you like to start with the introduction, the topic. Plate are widely used structural element in many engineering fields such as aerospace engineering, civil engineering, and mechanical engineering. They are used in many important structures like nuclear reactors, aeronautical structures, naval structures, submarine, and earthquake-resistant structures. In these structures, vibration of plate play an important role because they affect several important factors such as structural stability, system performance, durability of component, fatigue life, and overall structural safety. In material, elastic behavior help in storing mechanical energy, while viscous behavior help in dissipating energy in the form of damping, which reduces vibrations. Therefore, studying the vibration behavior of viscoelastic plates becomes very important in engineering design. Now, I will briefly explain the focus of the present study. In this study, we investigate the dynamic behavior of a clamped viscoelastic rectangle plate whose thickness varies linearly in two directions. The main aim to understand how this thickness variation affects the vibration characteristics of the plate. The results obtained from the study are useful for the design and analysis of lightweight engineering structures, especially in situations where vibration control is very important. Before moving further, let me briefly explain what a plate is. A plate is flat structural element whose thickness is very small compared to its length and width. Because of this geometry, plates can provide a high strength and structural rigidity while supporting loads. Due to these advantages, plates are widely used in many engineering applications such as aerospace engineering, civil engineering, mechanical engineering, and also in marine and nuclear engineering structures. Now, now I will discuss some important applications of plate in engineering structures. Plates are widely used in many types of engineering structures because they provide high strength, rigidity, and good load carrying capacity. For example, in aerospace engineering, plates are used in aircraft wings and fuselage panels. In civil engineering, they are used in bridge decks and building floors. Similarly, in marine engineering, plates are used in sea hulls and submarine structures. They are also used in nuclear reactors, component and earthquake resistant structures. Since plates are used in such important structures, it becomes very important to understand the vibration behavior because excessive vibration can affect the safety, stability, and efficiency of structures. Now, now I will discuss the effect of vibration of plate. Vibration in plates have significant influence on the performance of engineering structures. If vibrations are not properly controlled, they can affect several important factors. First, vibration affects the structural stability of the system. Second, the influence of the overall performance of the structure. They can also reduce the durability component and may decrease the fatigue life of material because repeated variations. Vibration can continuous stress in these structures. All the factors ultimately affect the structural safety. Therefore, the excessive vibration may lead structural damage or even structural failure.
Excuse me, Parveen, you have 5 minutes left. Thank you.
Thank you, sir.
Please unmute yourself.
मिस्टर परवीन, आप प्लीज कंटिन्यू करिए अपना प्रेजेंटेशन और कंक्लूड करिए जल्दी से. मिस्टर परवीन,
Yes, sir.
प्लीज आपका स्क्रीन अभी दिखाई नहीं दे रही है हमें. शेयर.
Yes, sir. Yes, sir. This is problem. Uh, Effects of the. Now I will be discuss the effect of vibration of plates. As we discuss, they can also reduce the durability of component and may decrease the fatigue life of material because repeated vibration cause continuous stress in the structure. All these factors ultimately affect the structural safety. Therefore, excessive vibration may lead to structural damage or even structural failure. For the reason, studying the vibration behavior of plate is very important in engineering design. A role of viscoelastic material. Viscoelastic materials show both elastic and viscous behavior. The elastic behavior allows the material to store mechanical energy when it is deformed, and the energy can be recovered when the load is removed. On the other hand, the viscous behavior help in dissipating energy in the form of damping. Because of damping property, viscoelastic material are very useful to reducing the unwanted vibration in structures. Due to this advantage, viscoelastic material are widely used in several engineering applications such as vibration isolation system, aerospace structures, automotive components, and structural vibration control devices. Therefore, they study the vibration behavior of viscoelastic plate because very important for improving the performance and safety engineering structures. Now I will be explain the importance of the thickness in plate. It many practical engineering structure plate do not always have uniform thickness. Instead, the thickness may vary depending on the design requirement and load conditions. Using plate with variable thickness providing several advantages. First, I helps to reduce the overall structure weight, which is very important in applications such as aerospace and mechanical structures. Second, it helps in improving the stiffness distribution of the plate. Third, it can enhance the vibration performance of the structure. In particular, plate with linearly varying thickness in two directions allow the better control over the structure's behavior and vibration characteristics. Therefore, the studying such a plates is important for the designing efficient and optimizing energy structures. Or overview of the my literature view, overview of previous research. Several researchers have studied the vibration behavior of rectangular square plate because plate are widely used in aerospace, civil, and mechanical structures. Now, I will briefly discuss the overview of the paper. Many researchers have studied the vibration behavior of rectangular and square plate because these plates are widely used in many engineering fields, such as aerospace, civil, and mechanical structures. Earlier study have shown that several factors affect the vibration characteristic of a plate. These factors include material non-homogeneity, variable thickness, and thermal effects, and elastic foundation. Researchers have also used a different analytical technique and study to plate vibration, among them the Rayleigh-Ridge method, among them the Rayleigh-Ridge method and the Ridge methods. are commonly used to determining the natural frequency and vibration of plate. Motivation of for study. The previous research focused on the most previous data considering the plate and uniform thickness. Uh, Limited work has been reported on the viscoelastic plate with thickness two directions. Therefore, the present study focus on the dynamic behavior of the viscoelastic rectangular plate with the variable thickness. Many research also consider the simple boundary conditions in the variable of the variable thickness in the plate. Viscoelastic materials are important in engineering because they are the
Hello, Praveen. Can you hear me?
Mr. Parveen.
He has logged out. Okay, so next presenter.
Kajal Patel.
Next presenter, please.
Kajal Patel, can you please start? Anshu Gupta. Kajal Patel, Anshu Gupta.
Yes, sir.
Kajal Patel.
Ajal Patel, please start the presentation.
Yes, sir. Good morning, respected chairperson, honorable professors, and dear participants. Myself, Kajal Patel from the Department of Mathematical Sciences, APS University, Riba. Today, I am going to present my work on the topic geometric structures arising from curvature condition in semi-Riemannian manifolds. This work studies how different curvature conditions influence geometric structure of semi-Riemannian manifolds. These are outlines. Before going into the details, let me first present the outline of my presentation. First, I will briefly discuss the abstract and introduction of the work. Then I will explain some basic preliminaries and definitions.
Kajal,
After,
please share the screen. We cannot see your screen.
yes, sir.
Kajal Patel.
Yes, sir. Can I visual, sir?
There will be a button, share screen, at the bottom of your phone or laptop, whatever you're using. Just next to the camera icon.
Yes. Yes.
There should be a share screen option at the bottom. Please share the screen. Are you on cell phone or laptop?
Laptop, sir. Can I visual, sir?
Yes, we can see you.
Can I start presentation, sir? Can I audible, sir?
You are audible and we can see the screen. Please start the presentation.
Okay, sir. Good morning, respected chairperson, honorable professors, and dear participants. Myself, Kajal Patel from the Department of Mathematical Sciences, APS University, Riba. Today, I am going to present my work on the topic geometric structures arising from curvature condition in semi-Riemannian manifolds. This work studies how different curvature conditions influence geometric structure of semi-Riemannian manifolds. These are outlines. First, I will briefly discuss the abstract and introduction of the work. Then I will explain some basic primaries and definitions. After that, I will present main result and theorems. Finally, I will conclude the presentation with some concluding remarks. Now let me begin with the abstract of this work. Curvature conditions play a fundamental role in determining the geometric structure of semi-Riemannian manifolds. In this work, we investigate geometric structures that arise naturally from prescribed curvature identities and tensorial constraints. Emphasis is placed on the analyzing of soliton configuration, generalized Einstein structure, and curvature symmetries under both Levi-Civita and special connection. We examine how curvature conditions influence rigidity classification and structural decomposition of semi-Riemannian manifold. Particular attention is devoted to warped construction and their interaction with curvature constant, leading to characterization result in both Riemannian and Lorentzian settings. Several examples are provided to illustrate the emergence of geometric structure governing by curvature properties. The result contribute to a unified understanding of curvature-dependent geometric in the semi-Riemannian framework. Now I move to the introduction part. Curvature plays a central role in understanding the geometry of manifolds. Semi-Riemannian manifolds provide a natural framework to study both Riemannian and Lorentzian geometries, which are important in differential geometry and general relativity. Different curvature conditions and symmetries help in describing special geometries structures such as Einstein manifold and Ricci soliton. These conditions influence the classification and geometric behavior of manifolds. In this work, we study geometric structure that arise from certain curvature condition in semi-Riemannian manifolds, analyzing their geometric consequence.
Excuse
These
me,
are preliminaries.
we have 5 minutes to complete, okay?
Okay. These are definitions. A semi-Riemannian manifold M-G is said to be generalized Einstein manifold if the Ricci tensor satisfies. Definition 2. A Ricci soliton on M-G is defined by Levi-Civita connection with respect to V plus 2 as plus 2 lambda G equal to 0, where V is a vector field and lambda is a constant. This is a conclusion. Curvature restriction plays a central role in determining geometric structure of semi-Riemannian manifolds. Such conditions lead to rigidity, results classification of manifolds, and the emergence of special geometric structures such as generalized Einstein manifolds, Ricci soliton, and worked product geometries. These are some references. Thank you, sir.
Thank you so much, Kajal, for the wonderful presentation. Anybody got questions? Okay, so can you please tell me what is the basic difference between a manifold and an Einstein manifold? Central manifold and Einstein manifold.
Yes, sir.
आइंस्टाइन मैनिफोल्ड और जनरल मैनिफोल्ड के बीच क्या अंतर है, आप बता सकती हैं? मैनीफोल्ड क्या होता है? Can you hear me? काजल? आवाज आ रही है मेरी, काजल?
Yes, sir. Yes, sir. Manifold is a mathematical spaces that looks like ordinary, like a flat space when we observe it locally, but its overall shape can be curved or more complicated.
तो इसका कोई एग्जांपल आप दे सकती हैं? इसका एग्जांपल जैसे होगा अर्थ, राइट?
Yes, sir. The Earth is Earth is a round globally, but if we look at a special small region, it appears flat like a plane.
Thank you so much, Kajal. Thank you.
Yes, sir.
Next is Rahul Ravi Kumar K. Ravi Kumar.
Yes, sir. Just give me 1 second. I will share the screen. Am I audible, sir?
Yes, we can hear you.
Just So, good morning, chair members, respected fellow researchers and organizers. My name is Ravi Kumar K, research scholar, Department of Studies in Computer Science, Vijayanagara Sri Krishna Deva Raya University, Ballari. And today I am going to discuss about the research entitled Bridging Molecular Topology and Artificial Intelligence for Robust QSPR Modeling. So in this research, firstly, we are going to discuss about we are going to start with the introduction, then what motivated to do this work, then going on with the further process, that is framework, proposed framework, then integration, then ML integration, that is machine learning integration, then results and discussions, then proceeding with the conclusion and key takeaways with the future work directions. So coming to the abstract, so this research presents a unified quantitative structure property relationship framework that converts molecular structures into graph-based topological descriptors to train efficient machine learning models. By integrating these mathematically defined features with advanced AI techniques, the approach achieves highly accurate, scalable, and interpretable predictions of molecular properties with very low computational overhead. Starting with the introduction, so first we are going to see about the molecular property. Understanding molecular properties is very essential in drug discovery, material science, and chemical engineering, because in experimental evaluation of molecular properties, it is often we are going to see it is very time consuming, expensive, resource intensive. Instead of going with these things, what we are going to do is we will go for the second way, that is quantitative structure property relationship. So in this, QSPR establishes a mathematical relationship between molecular structure to the molecular property. Examples of predicted properties are boiling point, solubility, toxicity, and stability. Coming to the topological indices, so these are the terms which are going to be seen in the mathematical topology. Topological indices are the numerical descriptors derived from molecular graphs. They capture structural characteristics such as molecular size, connectivity, branching patterns, structural complexity. Examples are Wiener index, Jagreb index, Randic index, and there are many degree-based indices. These indices serve as the features for machine learning models. Molecular graph representations. So coming to the moleculars, here we are going to see molecules as the graphs. So in molecular topology, often we are going to call atoms as the vertices and chemical bonds as the edges. If you are going to see the diagram, it consists of C and O, the vertices and edges. So here we are going to represent it with the atoms and chemical bonds. What motivated to do this work is why we are going to combine a normal topology, mathematical indices topology with respect to the AI. Graph theory provides powerful mathematical descriptors for the molecules, whereas machine learning provides an advanced prediction capability. Combining these two things, which enables us to efficient feature representation, reduced computational complexity, improved prediction accuracy, and better interpretability. Now we have proposed a framework which is unified QSPR modeling framework, in which first we are going to get the molecular data set. Let's assume a chemical molecular structure From that molecular structure, we are going to see the graph representation. We are going to take it as a graph. Then from the graph, which consists of edges and vertices, so we are going to calculate the topological index calculation. Then we are going to put it in the feature matrix. From the feature matrix, we are going to put it the data sets into the machine learning models. So from the different machine learning models, we will be able to predict the properties. Model evaluation metrics, which are the standard statistical indicators which are going to be used, are R square, which measures goodness of fit, RMSE, that is root mean square error, which measures prediction error magnitude, and mean absolute error, that is MAE, measures average prediction deviation. So coming to the modeling, we have taken a case study of monocarboxylic acids. So these are the fundamental compounds in both organic chemistry and biochemistry, which is very essential for cellular metabolism, industry, and daily life. If you are going to see the diagram, that is a molecular structure, and we have taken the different chains of the monocarboxylic acids, totally acetic acid to eosinoic acids. So these are the different chains. Nearly we have taken 19 different kinds of monocarboxylic acids, starting from C2 to C20. Topological indices which we have used for our study for monocarboxylic acid is totally we have taken 7 topological indices: first Jagreb index, hyper Jagreb index, forgotten index, harmonic index, inverse sum index, first Gaurav index, and first K Banati index. So where each topological indexes are going to be have the special structural constraints, where G is a graph which consists of V and E, that is molecular graphs, which consists of set of vertices and set of edges, whereas du and dv are the degrees of vertices u and v. For the topological descriptors from the previous slide formulas, we have calculated the all the topological indices values, and we have mentioned it in the tabular format. And coming to the physiochemical properties of monocarboxylic acids, all the values which are there, we have taken it from the PubChem, which is a chemical database. Directly we have retrieved from the PubChem. So now we have the feature variables, that is topological descriptors, and we have the target variables, that is physiochemical properties. Now we are going to see the correlation analysis. If you are going to see the diagram here, so most of the molecular weight, heavy atomic count, and complexity are going to see in the red. That is, it is almost all 0.9 to 1. So which are the predominant controlled by molecular size and connectivity. Whereas density and refractive index, that is D and Ri, so these are bad predictors. Machine learning algorithms which are used in our studies are the different machine learning models: linear ridge regression, lasso, random forest, decision trees, SVR, linear, as well as RBF, gradient boosting, AdaBoost, and KNN, K is equal to 3 and 5. So when we have performed the different machine learning models, initially we have got, if you are going to see the diagram here versus actual and versus the predicted values. So here we have demonstrated the top 3 models. So for the density, we have achieved the R square value 0.56, SVR linear. So compared to these 3, that is SVR linear, ridge regression, SVR RBF. So SVR linear performed better. So we have listed here best performing machine learning models. So for density, we have obtained SVR linear with the R square value of 0.5616. For molecular weight, HAC, and complexity, almost we have achieved 0.99, whereas for density and Ri, so we have not achieved handsome values, so that we can say these are the predicted values. If you are going to see the refractive index in the graph shown below, the predicted values are going to get into the negative side. So after tuning the algorithms, that is after hyperparameter tuning, we have improved the R square values, we have improved the performance, and we have improved the accuracy. And if you are going, we have compared to the old values to the original values. The problem was with the density and refractive index. If you are going to see the diagram here, for density, the previous R square value is 0.56, and it has been drastically improved to 0.98. 9864. Along with that, refractive index, that is Ri, which was in the negative values, that is minus 0.0897, has been converted into 0.9994. So which is very huge conversion. So which is very drastic improvement by performing the algorithmic tuning. Now result shows that we have predicted the actual versus the predicted values for the HAC and Ri here. So almost all the values which are going to be same. The actual values are nearly equal to the predicted values. And also we have shown the here residual plots. If you are going to see the density here, For density, we are having the minor residual errors. Yes, sir.
Please conclude in 2 minutes.
Yeah, sure, sir. I'm about to conclude. So here we are going to see the less errors. So we have shown the all the machine learning algorithms comparison chart here. So which gives us here, if you are going to see this diagram, the errors are very minor. It is in between minus 0.0022 plus 0.003. So advantage of this proposed approach is this framework approaches reduced computational complexity, scalable molecular descriptors extraction, improved prediction accuracy, and better interpretation of structural property relationships. Applications which is going to be used for this unified QSPR approaches: drug discovery, material design, chemical informatics, toxicity prediction, and environmental chemistry. The future work which can be integrated with graphical neural networks, large-scale chemical data sets, then deep learning, then real-time property predictions can be achieved. The conclusion of this work demonstrates that integrating molecular topology with AI provides a powerful approach for QSPR modeling. Key outcomes of this research is graph-based descriptors effectively represent molecular structure, machine learning models accurately capture structure-property relationships, the framework supports scalable and interpretable molecular property prediction. So these are the references which I have referred. So thank you.
Thank you very much for the presentation. Can you please let me know what was the best machine learning model did you find?
Sir, after hyperparameter tuning, sir, we have found decision trees as the best performing machine learning model, sir. So if you are going to see this tabular column, sir, here we are going to see decision tree has performed for complexity, molecular weight, and refractive index. We have predicted 3 physiochemical properties, one for ADA boost and one for linear regression.
Okay, thank you very much.
Thank you, sir. Thank you. Thank you for giving this opportunity. Thank you, sir. Thank you, one and all.
Thanks. Okay, Rahul Makwana, are you there?
Yes, sir. Am I audible?
Yes, you are audible. Please share the screen.
Sir, is it visible, sir?
Yes. You have 10 minutes for presentation.
Okay, sir. So, first of all, namaste and good morning to Chairperson, and thank you very much for giving me an opportunity to present my presentation. I, Rahul M. Makwana, under the guidance of Sagar Khirsaria, presenting my research entitled with an efficient semi-analytical approach to nonlinear fractional Kubi-Buznik equation under homotopy perturbation Young transformation method with Caputo fractional derivatives. So this is the outline of my presentation, followed by introduction and preliminaries. There is a method, that is homotopy perturbation Young transformation method with its application. At the end, conclusion and result with references. So Buznik equation was first introduced by Joseph Buznik in early 1870s. It is commonly used in coastal and ocean engineering to study water flow through lacky ground layers, and many researchers have studied on Buznik equations. This is the real-life application of Buznik equation, in which shallowing process where a long wave moving from deep to shallow water shown the down shorten in wavelength. So this is real life application of Buznik equation. This is the basic introduction of fractional partial differential equation. So we inspired to fabricate a hybrid technique called by HPYTM, that is homotopy Young transform method, which is a combination of homotopy perturbation and Young transformation. Young transformation was first introduced by Young in 2016. So equation number 1 representing the Riemann-Liouville definition, whereas equation number 2 is in Caputo sense. Equation 3 representing Young transformation. This is the theorem. This is convergence theorem, and its proof is available in our submitted paper. This is the methodology named by homotopy perturbation Young transformation method. In equation number 5, we have non-linear partial differential equation, whereas equation 6 representing initial condition. where L is a linear and N is a non-linear component. Applying Young and inverse Young transformation to previous equation number 5 to the non-linear equation, we have equation number 7, on which if we apply homotopy perturbation Young transformation method, we will get equation number 8 and equation number 9, where equation number 10 representing homotopy polynomials, and equation number 11 is the Taylor's expansion or the series or the solution obtained by homotopy perturbation Young transformation method. This is the convergence method theorem, whose proof is available in our submitted paper. This is an application of cubic Buzenick equation. Equation number 12 is cubic Buzenick nonlinear fractional differential equation with equation number 13 as an initial condition. 14 is the exact solution of equation number 12 or a Buzenick equation. This is the solution obtained by homotopy perturbation Young transformation method. This is 2D representation for different values of fractional gamma at t is equals to 0.01, where if you can see that black and red color are respectively exact by homotopy perturbation Young transformation method. Other colors representing different values of fractional gamma, say for 1.6, 1.5, 1. This is a 3D representation for different fractional values, gamma, say for 1.456. Here we have gamma is equals to 2 and the graph of exact solution in a 3D plot at t is equals to 0.01. This is tabular representation or the comparison of HPYTM homotopy method with Young transformation. We compare that method with other two methods, respectively MRPSM and MTIM, that is Mohammed residual power series method and Mohammed transform iterative methods. We can see that the solution obtained by HPYTM is very much effective than the other two methods, respectively last 3 columns. Third column representing exact solution. So we can say that HPYTM is compared with other two methods, Mohan the residual power series method and Mohan the transform iterative method. The comparison include error analysis, graphs, tabular representation, 2D and 3D representation. When fractional order gamma gets closer and closer to 2, the approximate solution obtained by HPYTM becomes similar to the exact solution, precise solution, and result also shows that the lower value of fractional gamma, say up to 1, the solution moves very slowly. In conclusion, we can say that HPYTM is very much effective method for nonlinear fractional differential equations. We plan to apply HPYTM by testing quickly convergent series and applying them to the more real-world fractional differential equations. And it may utilize for both linear and nonlinear problems commonly found in applied science and engineering. These are my references. Thank you very much.
Thank you for the very nice presentation. I have a question. Have you published these results somewhere?
No, sir. No, sir.
Okay. So thanks a lot for sparing your valuable time for the presentation.
Thank you very much for giving me an opportunity. Thank you, sir.
Thanks. Okay. Who's going to present next?
Hello.
Okay.
Hello, am I audible?
I can hear you.
Hello, am I audible?
audible? Hello, hello.
Yes, sir, you are audible. Yes, sir.
Good morning, respected chairperson, honorable judge, and fellow participants. Myself, Divyanshu Singh, research scholar from the Department of Biochemistry and Biochemical Engineering, Suez, Prayagraj. Today, I will be presenting my research work entitled "Effect of Banana Pseudostem Polyphenolic Stress on Ripening Behavior and Sugar Metabolism of Papayas during Storage." So, my video is visible. Let me, uh, Let me begin with my brief background of the study. Papaya is an important tropical climatic fruit widely cultivated for the nutritional and medicinal value. It contains important nutritional such as vitamin C, carotenoid, and several bioactive compounds, and it's also contains this digestive enzyme, pepin. However, papaya is a climatic fruit which means that often harvest it undergoes a rapid rise in respiration and ethylene production. As a result, the fruit
Divyanshu,
wrapping will
here this cannot see your.
listen. Hello.
We are able to see your mailbox. Not,
What's that?
we can see your mailbox, but we like to see your question. Your slide.
सर आपकी आवाज कट रही है
आपको आ रही है आवाज मेरी?
जी सर
Slides बिल्कुल नहीं हो रही।
सर आपकी आवाज सही से नहीं आ पा रही कट
We
रही
cannot see your slides. Can you hear me?
आपकी स्लाइड
यस सर सर स्लाइड शो हो रही है
स्लाइड्स नहीं दिख पा रहे हैं।
Cannot see the slides. Please share the screen. Please open your PPT. Please start your presentation.
Divyanshu Singh, please,
सर आप दिख रहे हैं आपको
नहीं अभी भी देख नहीं पा रहे हैं स्लाइड्स आपकी। मेल बॉक्स है उसको मिनिमाइज करिए और वहाँ पर शेयर स्क्रीन का ऑप्शन होगा उसको यूज करिए। पीपीटी खोल लेंगे आप तो दिखाई देगा।
Please open your PPT. Open कर पा रहे हैं आप PPT?
यस सर
हाँ तो
सर नेटवर्क प्रॉब्लम है बस
हाँ तो इसको क्लोज करिए आप अपने ये Gmail को। हाँ yes. Please start.
Sorry, sir. Let me begin with the brief background of the study. Papaya is an important tropical climatic fruit widely cultivated for its nutritional and medicinal value. It contains important nutrients such as vitamin C, carotenoid, and several bioactive compounds, and it's also contains the digestive enzyme, papain. However, papaya is the climatic fruits which means that often harvest is undergo a rapid rise in respiration and ethylene production. As a result, the fruit ripens very quickly during this process. Starches are converted into soluble sugars, leading to fruit softening and quality deterioration. Because of this rapid ripening, papayas generally has a very short shelf life under ambient condition 3 to 5 days. This rapid ripening cause significant post-harvest losses, especially during storage and transportation. To delay ripening, some chemical inhibitors such as silver nitrate or potassium permanganate are commonly used. Although these chemicals can slow down ethylene action, their use raises concern regenerating toxicity and environmental safety. These four Therefore, the research are increasing looking for natural and eco-friendly alternatives that can regulate fruit ripening. One such performing source in banana pseudostem, which is usually considered an agricultural waste materials. In testing, banana pseudostems contain a wide range of polyphenolic compounds. These compounds are known for their antioxidant and antimicrobial properties. Polyphenol can also influence various biochemical processes in fruit, inducing those related to oxidative stress and ripening metabolism. Therefore, a banana pseudostem extract may have the potential to regulate the ripening behavior of the fruits such as papayas. Based on this background, the objective of the present study was to evaluate the effect of banana pseudostem polyphenolic extract on carbohydrate metabolism, sugar transformation, and ripening behavior of the papayas fruit during storage. In addition, the performance of the extract was also compared with silver nitrate treatment. To achieve this objective, the experiment was conducted in the research laboratory of the Department of Biochemistry and Biochemical Engineering at Suez Prayagraj. Papaya fruit of the variety Red Lady were harvested at the physiological maturity. Only healthy fruit with uniform size, shape, and non-visible damage were selected for the study. For preparation of the extract, fresh banana pseudostem was collected and inner core was separated. The materials was cut into small pieces, stem blank, and then dried at the controlled temperature. After during the materials was ground into the fine powder. Polyphenolic compounds were then extracted using 60% methane. And the extract was concerned during rotatory evaluator. Finally, the extract was freeze dried and stored for the further analysis. LCMS analysis was performed to identify the major phenolic compounds present in the extract. In their experiment, a total of 84 papayas fruit were used. The fruit were divided into 7 treatment groups, including 1 control, 3 silver nitrate treatment, and 3 polyphenolic extract treatment. These fruit were there shared with the respective solutions allowed to air dry and then stored under ambient room conditions. Observations were recorded at 0 to 7, 14, and 20 days of the storage. After applying the treatment, several biochemical parameters were analyzed to evaluate changes in carbohydrate metabolism during storage, like total carbohydrate, reducing sugar, non-reducing sugar, glucose content, fructose, and starch content. These biochemical parameters were estimated using standard colorimetric method reported in calories studies, real studies. After analyzing these parameters, these results obtained are presented in the following slide. After evaluating the fruit responses, it was important to characteristic the polyphenolic compound present in the extract. Therefore, LCMS analysis was performed to identify the major bioactive compounds present in the banana pseudostem extract. The analysis
Hello, Divya.
evaluated the.
Please
Yes, sir.
conclude in 5 minutes.
Okay, sir. In conclusion, banana pseudostem polyphenolic extract effectively regulated carbohydrate metabolism and sugar accumulation in papayas fruit during storage. Among all treatment, the 5 gram per liter extract treatment show the best performance. Therefore, banana pseudostem extract may serve as a natural and eco-friendly alternative to synthetic rapine inhibitor for post-harvest management. Thank you for your kind attention. I will be happy to answer any questions. Thank you, sir.
Yeah, Divanshu, can you please let us know which method you use to extract polyphenols from banana? Divanshu,
Yes, sir.
polyphenols कैसे extract किया आपने banana से? Can you hear me?
हेलो सर, आपकी आवाज़ नहीं आ रही है।
Okay, अभी आ रही है आपको आवाज?
हेलो हेलो।
I asked, how did you extract the polyphenols from banana? Okay, so we'll pause and go on to the.
हेलो सर, ऑडिबल? सर, बनाना के स्टेम को काट के उसको सुखा के फिर 60% इथेनॉल से किया है।
Okay, thank you very much.
थैंक यू सर।
Maurya, are you ready? Maurya? Thank Kirti Maurya, Ajit Singh, Utkarsh Pandey.
Good morning, sir.
Yes, Kirti Maurya, please start.
Yes, sir.
Kirti Maurya, please share your screen and start your presentation.
Kirti Maurya. Kirti Maurya, please start करिए presentation. कीर्ति मौर्य, आपके स्क्रीन के बॉटम पे शेयर स्क्रीन का ऑप्शन है, उसको क्लिक करिए तो आप स्टार्ट कर सकती हैं.
Can you hear me, Kirti Maurya? Okay, I think we'll go to the next presenter.
Vani Krishna, please start.
Vani Krishna?
Yes, sir. Yes, sir.
Yeah, please start your presentation.
Okay. Is it visible, sir?
Yes.
My screen is visible, sir?
Yes, your screen is visible.
Okay. Good morning, everyone. Today I am here to present my topic is numerical method for solution of nonlinear ordinary differential equations. Myself, Vani Patil from Department of Mathematics, Karnataka University, Dharwad. Two minutes, sir. Is it visible, sir?
No, we cannot see your slides.
Okay. Is it visible now?
No, still not visible.
Sir, I will try again. Hello, sir.
Yes.
Sir,
No,
I
sir.
am.
Sir, is it visible now?
Yes. कीर्ति आप वेट करिए, वाणी कृष्णा के बाद आप प्रेजेंट कर सकती हैं.
Okay, sir. Thank you, sir.
Good morning, everyone. Myself, Vani Patil from Department of Mathematics, Karnataka University, Dharwad. Today, I am here to present my work on numerical technique for solving a system of ordinary differential equations. Here are the contents of my paper: abstract introduction, mathematical analysis, method of solution, method of implementation, conclusion, and the references. In the abstract part, we have in this paper a numerical technique is presented to obtain the numerical solutions of nonlinear system of ordinary differential equations. The numerical solutions is presented in the form of tables and the figures. In the meantime, the accurate numerical solution is obtained by increasing the step size, and it is proved to converge to the analytical solution. Some system of ordinary differential equations is studied to demonstrate the accuracy of the present method. Result obtained by the method indicate the proposed method numerical technique is simple and effective. These are the keywords we have used. And the introduction part, we have taken here the nonlinear system of second order boundary value problem. They frequently arise in engineering and applied sciences. Most nonlinear systems do not have closed form of analytical solutions. Therefore, numerical techniques are required. Numerical approaches such as a finite difference, homotopy analysis, and the sinc collocation methods have been proposed. In this work, we have used quaternarization, finite difference, and the Thomas algorithm. The method provides accurate and efficient numerical solutions. The proposed method approaches a fast convergence property of a quaternarization, a simplicity and the reliability of a finite difference method, and the computational efficiency of a Thomas algorithm. In the definition part, we have taken the what is second order boundary value problem, and then definition 2.2, we have discussed about what is the quaternarization. It is a iterative technique that linearize the nonlinear differential equation using first order Taylor series expansion. And in next definition, we have defined what is the finite difference method, and next what is the Thomas algorithm. And next step, we have I am explaining here what is the method of solution we have used here to solve the problems. We consider the nonlinear system of second order boundary value problems and apply the quaternarization technique to transform the nonlinear system into a sequence of linear boundary value problems. In the next step, we use first order Taylor series expansion around the current approximation to linearize the nonlinear terms. In the next step, we discretize the linearized equation using the finite difference method by using the central difference formulas. In the fifth step, we do discretization produces the block tridiagonal system of algebraic equations. We solve that algebraic equations using the Thomas algorithm. Here we used MATLAB to solve that using the Thomas algorithm. In the next step, I have taken two examples. In first example, I have explained how the steps are involved here. We have taken one example here, which is
u1 dash u1 double dash plus x u1 dash plus cos of pi of x of u2 dash is equals to f1 of x with some boundary conditions. And the second equation is u2 double dash plus x u1 dash plus ux u1 whole square is u1 square is equals to f2 of x. These are the exact solutions. In the solution part, in equation, here in equation 3, it is already linearized equation. In equation 4, we have to linearize that non-linear term. In that equation, x u1 square is a non-linear term. So we have to linearize this using the Taylor expansion. Here we have used Taylor expansion, and we substituted that ninth equation in the equation 4 here. And similarly, equation 3 has written here with the same unchanged boundary conditions. Now we apply the finite difference method to linearize the equations. Here we have used central difference formulas and substituted in the equation. And we solved those equations. We get A1, AI, BI, CI, and DI. And similarly, we applied for the second equation also in the question. We get same A2, B2 here, A2, B2, C2, D2 here, and we get one block diagonal system here. We get of the algebraic equation. We solve that diagonal system using the Thomas algorithm, and we use the we used MATLAB for solving that equations. Here are the comparison between the numerical solution and the exact solution for n is equals to 10. And we got these two diagrams, figures here. And similarly, the same type of solution is applied for these two equation, another problem. And we got the answer here, numerical solution with the exact solution for same n is equals to 10. And these are the figures. And then we conclude this as the numerical result obtained for the test problems demonstrate excellent agreement with the exact solutions. The error values presented in the table confirm that the method provides the accurate approximation even for the relatively small number of grid points. The graphical comparison further valid for the convergence and stability of the method. Therefore, the proposed numerical technique is simple, systematic, and computationally efficient and highly accurate for solving the nonlinear system of ordinary differential equations. The method can be extended to more complex nonlinear systems arising in the applied mathematics, physics, and the engineering problems. These are the references I have used, and thank you.
Thank you, Vani, for the insightful presentation.
Thank you, sir.
Audience got questions? Okay, so Vani, can you please go to the slide that has the error analysis?
Okay, sir. Yes, sir.
Yes, as I can see, the error is like up to the 4 decimal points, right?
Yes, sir.
So, like, from where did you obtain this?
When we apply this in a MATLAB, we get this results, sir.
Okay, so that is like the deviation from the standard value?
Yes, sir. Applying the Thomas algorithm, we get, if we solve it theoretically, we will get it. We have done for one or two iterations, sir. But it converges for 4 iterations. So we use the Thomas algorithm in MATLAB, sir.
Okay, so if it converges for like to like 4 impressive. So have you published anything based on this?
No, sir, not yet. Now we are a freshers, so we have to publish now, sir.
Yeah, so because basically what you are doing is that you are comparing the theoretical value with
Yes,
the
sir.
MATLAB value, correct?
Yes, sir.
Which you get from the theorem with your software technique.
What, sir?
So you are comparing the theoretical value with your methodology, right?
Yes, sir.
Okay. Okay. Thank you.
Okay.
Any
Thank
other questions from the audience? Okay, so I think that's gonna be it. Thank you, Vani. And now I move forward to the next presenter. Kirti Maurya, please share your screen and start your presentation.
Yes, sir.
Kirti, please start your presentation. Can you please make it portrait mode? Are you on cell phone?
Sir, it is visible?
Yes, but make it portrait mode, okay?
Yes, sir.
Make it horizontal.
लैंडस्केप में कर लीजिए उसको तो दिखेगा.
Horizontal कर दीजिए उसको, okay?
Horizontal. सर कहाँ से करेंगे?
You are using a phone, right? So make it horizontal.
Yes, sir. देख try.
दीजिए तो हॉरिजॉन्टल हो जाएगा.
Sir, I will try again.
ओके, आप थोड़ा जूम करके भी स्टार्ट कर सकती हैं.
ओके सर, तो सर स्क्रीन नहीं दिख रहा है हमारे में.
नहीं, हम स्क्रीन देख पा रहे हैं आपका.
ओके सर. Sir, I myself Kirti Maurya. Good morning, all of you. Geomagnetic sending is efficiency during extreme space weather events. Research is abstract. Abstract Earth's geomagnetic field forms a protective barrier that limits the penetration of high energy charged particles into near Earth space and the atmosphere. During extreme space weather events, including intense geomagnetic storms and large solar energetic particles, um, observation from satellite missions are combined with ground-based magnetometer and neutron monitor data to assess storm time particle exist at different latitude. Particular emphasis is placed on weak field regions such as the South Atlantic anomaly and their role in enhancing radiation exposure risk. And results is allowing deeper penetration of energetic particle and increasing hazard for satellites, aviation systems, and communication infrastructure. The finding demonstrate the importance of integrating real-time geomagnetic field variability into space weather prediction model to improve risk mitigation strategies and better understand magnetospheric protection process during extreme solar events. Introduction. The primary defense of Earth against the continuous flow of charged particles from the Sun, known as the solar, wind, and from extreme events such as coronal CME and solar energetic particles events is the planet's intrinsic magnetic field. The magnetic field generates a complex plasma environment called the magnetosphere, which acts as a large-scale magnetic barrier capable of deflecting and trapping high-energy particles before they reach the atmosphere. The efficiency of this geomagnetic shielding plays a critical role in regulating the radiation
Excuse
environment.
me, Kirti, you got 5
Yes, sir.
minutes. You got 5
Yes,
minutes.
sir. Yes, sir. Yes, sir. During strong storms, several important structural changes occur: compression of the day-side magnetosphere, expansion of magnetic intensification of ring current, enhancement of magnetospheric convection, historical comparison of extreme space weather events. March 1989 event solar cycle is 22, minimum DST disturbance storm times minus 589 and peak 9 peak Matthew Raji, two quantity variation in geomagnetic shielding efficiency. This study integrates observation from multiple space-based and ground-based measurement systems, satellite observations and ground-based observation. Satellite observation particle flux measurements from geostationary satellites. The Swarm constellation and the Von Allen probes are used to track energetic particle population in magnetospheres. This observation allow mapping of solar energetic particles penetration depth and radiation belt variability during storm conditions. Results and discussion degradation of geomagnetic shielding, cut off suppression and echo to forward expansion. Loss of belt stability, regional vulnerabilities, the South Atlantic anomaly conclusion. This study provides a comprehensive assessment of variation in geomagnetic shielding efficiency during extreme space weather events, analysis of satellite particle observation, ground-based magnetometer data, and neutron monitor measurements demonstrate that intense magnetic storms substantially weaken Earth's magnetic shielding capability. Storm time, magnetospheric compression, ring current intensifications, and field line reconfiguration collectively reduce geomagnetic cutoff rigidity and allow energetic particle to penetrate to lower latitude. These findings highlights the needs for space weather forecasting models and incorporate real-time geomagnetic field dynamics and regional magnetic field variation. Improve predictive capabilities will be essential for mitigating radiation hazard to satellites, aviation systems, and future human space exploration missions. Some responses, sir. Thank you, sir.
Thank you, Kirti, for the wonderful presentation. Okay, so I had like a question. So for how many years you have collected the data?
What, sir?
For how many years you have collected the data?
Sir,
Which years? किस साल का डेटा कलेक्ट किया है आपने? कितने सालों का?
sir, 10 year का.
Starting?
Starting to, sir, sir 20 years है, 1989 है.
So 1989 to 2009?
हाँ.
इतना ही होता है ना 20 years, 1989 to 2009, right?
नहीं सर 40 ईयर है, मतलब 26 में चल रहा है ना. 40 ईयर 14 है 40.
40 years. So from which year do you start?
मेरा रिसर्च स्कॉलर.
आपने कब से डेटा का कलेक्शन करना स्टार्ट किया? कौन से ईयर से? 1989 से?
नहीं सर, ये तो मतलब रिसर्च से पीडीएफ से उठाए हैं गूगल से.
So you don't know about your data?
Sir, 22 Sir, nahi.
Okay, so the prediction. Okay, so like what parameters you have used in predicting the geomagnetic storms?
Sir, यही methodology था, satellite observation and ground-based observation.
Okay, so satellite observation and ground-based observation. So, कौन से parameters you are using in predicting the geomagnetic storms, and what's the accuracy of the model?
Ground-based observation.
Yes. So, what's the accuracy of the model, and what parameters are you using? That's what my question is. Like parameters you are using, right? In your model, and what's the accuracy? Like you are using space monitoring and geo monitoring, right?
Yes, sir.
So what parameters? Matlab, how do you predict that a geomagnetic storm can come, like suppose on 15th September? Or what's the accuracy? क्या accuracy है आपके model की? What's the accuracy of the model? Okay, thank you so much. Next presenter, please.
Sir.
So may I present?
Okay, Shresh Kataria, please start.
Yes, sir. Kirti Monica, can you stop sharing the screen?
Okay, sir.
So is my PowerPoint presentation visible? Yes, it is visible. Okay. Good morning, respected chairperson, reviewers, and fellow researchers. My name is Shresh Kataria, and I am currently pursuing my BTech degree in Computer Science Engineering, specialization in Artificial Intelligence, Machine Learning from Dronacharya College of Engineering, Gurgaon. Today I am here with my associate professor, Professor Dr. Vishali Dikshit, and today we'll be presenting our work title on an AI integrated based framework for improving industrial coating quality and reliability. So, basically, this research focuses on addressing quality issues in industrial coating using artificial intelligence, digital twin, and computer vision techniques. Now, before diving directly into AI and how it is resolving our issues, let's bring our vision to what industrial coating is and what is the role of industrial coating. So basically, industrial coating plays an protective role, which can be illustrated by some examples. Firstly, talking about in marine industries, we have ships and submarines in which the elements or the components are coated in order to prevent them from the salt water, which would ultimately lead to corrosion. Secondly, talking about in aerospace industries, we have planes which moves from country to country, state to state in varying temperature and environment, which could ultimately damage the components of the aircraft. So coating is done in order to prevent the damage for these elements. Overall, coating protects components from corrosion, wear, chemical attacks, and chemical damage. Now, even with advanced coating technologies, industries still face defects. These defects include pinholes, blistering, cracks, peelings, and overcoating, undercoating. As you can see in the slide, some images have been illustrated, such as this shows an example of pinholes, this shows an example of blistering, and lastly, we have the cracks and peelings. Now, it is very much essential to resolve these defects to ensure coating quality and long-term reliability. Now the next part comes that why these defects occur, the main reason for the occurrence of these defects. This includes four things. Firstly, the bath temperature, bath chemistry, surface roughness, and humidity and ambient temperature. Talking about the bath temperature, so basically in a bath we have a container where we have a solution in which the metal of the component is dipped in order to be coated. So for that, the bath temperature, the bath chemistry, including the pH and the ion concentration, should be perfect according to the metal and the component being coated. Thirdly, we have the surface roughness. Now, due to improper surface on metals, the coating is not done uniformly, which could ultimately lead to defects. Lastly, we have the humidity and ambient temperature. Now, due to variation in temperature and presence of moisture, we could ultimately lead to defects such as blistering and crackings in the components. Now, it is very much important to resolve this issue since the manual inspection is slow and not sufficient. So, in order to solve all this problem, we have made an integrated AI-based framework which includes four components. Firstly, AI defect prediction, digital twin, computer vision inspection, and lastly, the lifespan prediction. Moving ahead, we have the AI-driven defect prediction. So basically, AI model will be trained using historical industrial data. So these data includes the humidity, ambient temperature, then the bath chemistry, bath temperature, and coating thickness records. Now talking about that how AI will work, it will be using machine learning models such as random forest, SVM, DNN. Now, random forest, as the name suggests, forest, it is a collection of trees. So it creates the multiple decision trees during training, then merge them together for the accurate results. SVM, or the support vector machine, helps in detecting the anomalies. Lastly, the DNN, the deep neural network, helps in analyzing the data deeply to give the desirable output. Then lastly, the model gives an output of the output, which ultimately gives the probability of the defect occurrence before the defect occurs. Moving ahead, we have the digital twin, vision, and the lifespan. So basically, digital twin model will work as a virtual simulator in which scientist or a person can do the experiments with the elements in the coating. So now the researcher or the now the scientist doing who is doing an experiment in the virtual lab will either get some hits and will either get some failures. Now AI will detect those hits and failures and the parameter that is being used in that hits and failures and will ultimately help in improving our data set. Secondly, we have the computer vision inspection, which will be using high resolution images of coated surface, and it will be CNN based module. So basically CNN based module will be using high resolution images and will analyze the material from each and every side and from each and every corner and will help in detecting the defects such as cracks, blisters, and pinholes, ultimately removing human subjectivity and will enable 100% inspection. Lastly, we have the lifespan prediction. So AI will also help in detecting the lifespan of the material after coating, that how much, what is the lifespan of that particular component in particular environment or a temperature. Moving ahead, talking about the benefits, firstly we have the less manual inspection. Since manual inspection is slow, so we have used an AI integrated framework which is ultimately efficient and will go with our problem that we are facing. It will also help in improving sustainability, and we will also have the data-driven decision making. So the proposed framework enhances coating quality, reliability, and process efficiency while reducing defects and maintenance costs. Lastly, I would like to conclude, this research demonstrates how historical data, artificial intelligence, and digital twin can collectively transform industrial coating process into intelligent, predictive, and self-correcting system. Thank you. I sincerely thank the organizer and the reviewers for this opportunity to represent my paper in a reputed international conference, and I would be happy to take any questions.
Shesh Kataria, thank you for the presentation. Can you please tell me which semester are you in?
Sir, I'm currently in second semester.
Second semester. So, have you done any experiments in the anti-corrosion coatings?
No, sir, I have not done any experiment. This is a conceptual paper.
Okay, so then how did you get any, do you have any data from computational studies or somewhere else for this,
Sir, yes.
for this proposal?
Yet I don't have still now I don't have any data. However, since AI have been evolving in different industries and have a wide range of scope, so I wanted to know more about AI, that how AI can be used in more industries to resolve issues.
Okay, considering that you are in the second semester, your PPT was quite informative and your way of presentation was also very nice. I would like to congratulate you.
Oh,
Thank
thank
you
you.
very much.
Thank you, sir.
Please request Sheikh Ataria to start the presentation.
Okay, Shri, could you please present your research?
Yes, sir. Am I audible, sir?
Yes, you are audible. Please share the screen.
Yes, sir. Good morning, everyone. My name is Shrey Kataria, and I am a BTech student in Computer Science Engineering with a specialization of Artificial Intelligence and Machine Learning at Dronacharya College of Engineering, Gurgaon. Today, I am here to present my research titled AI-Assisted Sustainable Optical Coating from Food Waste. Currently, the optical coating industry faces three critical challenges. First, resource depletion, a heavy reliance on rare earth elements and non-renewable minerals. Second, toxic byproducts, the widespread use of harmful solvent during processing. Third, ecological damage, significant pollution and waste generation. We realize that to move forward, we need to look at our waste streams as a primary goal. Our research integrates upcycled food waste into high-performance optical coating optimized through artificial intelligence to create truly circular economy model. Our approach centers three key bio-derived materials. Rice husk, a rich source of silica, which is the fundamental building block for optical thin film. Eggshells, these provide abundant calcium carbonate to enhance durability and tune the refractive index. Banana peel ashes, this gives a necessary carbon and potassium compound to modify electrical and optical properties. The process have five steps: collection and cleaning of food waste, extraction of useful compounds, formulation of coating solution, application of thin film coating, and curing to strengthen the coating. This converts food waste into functional optical coatings. The role of AI in my research. So the AI analyzes vast data sets of material properties. It identifies complex relations between composition and performance and predicts optimal synthesis condition with high accuracy, enabling rapid iteration and refinement of coating designs. Now, the machine learning, role of machine learning. Our machine learning model predicts the optical properties of coating. It takes material composition and coating thickness as input. Uses this input, the model predicts important optical characteristics such as refractive index, optical density, transparency, and line transmission, enabling more precise coating designs. The key optical results of my research are enhanced UV protection. Enhanced UV protection effectively blocks harmful UV radiation, safeguarding health and minerals and materials. Improve light transmission. Maximize visible light passage, crucial for displays and application and solar applications. Increased coating efficiency. AI-driven optimization lead to thinner, more effective, and durable films. Some applications beyond the labs are eyeglasses, durable, anti-reflective, and UV protective coating for enhanced vision. Window glass, energy efficient coating for insulation and reduced glare in buildings. Display screen, anti-glare, scratch resistance, and high transparency layer for electronics. Solar panels, coating that improve light absorption and increase energy conservation efficiency. Our sustainable optical coating offers a broad range of application during innovation across various industries. Thank you. I sincerely appreciate the opportunity to present my research. I welcome any question, suggestion, or feedback from the respected judges and the members.
Okay, Shrey Kataria, have you done any experiments on these coatings?
No, sir, I haven't done any experiments till now.
Actually, I just I think a couple slides before you wrote our coatings. So it gives the impression that you prepared those coatings. And also there is another question that I think you are in CSE branch, right? The second semester.
Yes, sir, I'm in CSE
So-
specialization with AIML.
Okay, so how come you chose the topic of coatings?
Sir, I chose the topic of coding like basically we all know that AI mostly uses AI is mostly used in software branches like software projects. So I wanted to think a bit differently to integrate the AI in hardware researches too. That's why I used this topic.
Okay, I would like to suggest you to also go through some of the research papers, direction of sustainable coatings. And do you have any data sets? One of our audience asked you question, Mr. Ravi Kumar K. Do you have any data set on this?
No, sir, I currently don't have any data sets, but I am still working on it. I'm still working on the ML model to create.
Okay, is there any other question from the audience?
Yes. Hello. In,
Which?
in software-based AI system, optical coating, what is the similarities of optical coating of the AI-based and experimental data?
Okay, so the experimental data takes too much man work, and it basically what it does, the experiment one does is it is based on hit and trial method, but the AI examines all the past researches and experiments on that and predicts the most optimal way to predict. Yes.
Predicted data and experimental data. What is the errors of predicted data and experimental data related to the regression value R?
Sir, may I answer this question, sir? I'm Dr. Vaishali Dikshit, sir. I'm the mentor of these students. Am I audible, sir?
Yeah.
Sir, as they are the first year students, and it is they are the project work. That means we are planning on it and we have start working on it. So it is a basic model. That means we will work on it. It's our project for the long term. So that's why definitely in near future we will definitely we will show you some data related to this project. So as of now, it's basic and the primary work. We were just expecting some output on it. Say how we can proceed or how we can do some more efficient of this project to this project. That's why. So,
Thank you, Dr. Vaishali Dikshit. I had a small question. Like, so what I can understand is that you want to use an AI model to develop optical coating, right?
Right, sir.
So, like, it is basically simulation based right now.
Right, sir.
So, have you done any simulations on this?
Not right now, sir. Not as of now. We have not done anything. But just sake of the awareness, just the sake of the experience, the exposure to the students. That's why we have. I came here for the conference, and I just want just they should expose us some how to write how to present the paper at the international level. That's why we came here, just so the exposure sake.
Okay, so what I can understand is that you are in literature review phase right now.
Right, sir.
Okay, so after this, okay, yeah, so definitely like simulations can be done after this, and then
sure,
we
sir.
can like develop a physical optical coating.
Definitely.
That would be, quite an achievement. Thank you.
Thank you, sir.
Okay, Tanisha Grover, are you there?
Yes, sir.
Okay, please present.
Okay, sir.
After this, Palak Singh will be there.
Okay, sir.
Tanisha Grover, you are having 10 minutes. Please share the screen.
Sir, is it visible?
Yes, it is visible.
Okay. Good morning, everyone. My name is Tanisha Grover, and today I will present my project titled Modeling of Compact Stars in Modified Gravity. This project focuses on understanding the internal structure of compact stars, such as neutron stars, using the FQ gravity framework. This work carried out under the supervision of Dr. Sachendra Shukla at Amity University, Noida. The objective of this study is to analyze compact stars using modified gravity theory. In this work, we derive mathematical expressions for energy density, radial pressure, and tangential pressure inside the star. We also apply the vanishing complexity factor condition to simplify the field equations. Finally, we study the physical behavior and stability of the compact star model using graphical analysis. Compact stars such as neutron stars are extremely dense astronomical objects. Their internal structure is studied by analyzing physical quantities such as density, pressure, and gravitational behavior. Einstein's general relativity explains gravity very well, but it cannot fully explain problems like dark energy, dark matter, and the accelerated expansion of the universe. Therefore, scientists developed modified gravity theories to study such phenomena. Some important modified gravity theories include FR, FT, and FQ gravity. In this study, we focus on FQ gravity. This theory describes gravity using non-metricity Q rather than curvature. It provides an alternative framework to study cosmology and compact astrophysical objects. Understanding field equations and their solutions. To describe the geometry inside the star, we use the Schwarzschild line element. This metric contains two functions called metric potentials denoted by mu r and lambda r. These functions describe how space and time behave the gravitational field of the star. They depend on the distance from the center of the star. Next one is energy momentum tensor. Inside the compact stars, matter can behave anisotropically, meaning the pressure may be different in different directions. Therefore, we use an anisotropic energy momentum tensor. This tensor contains three important physical quantities that are energy density rho, radial pressure PR, and tangential pressure PT. These equations describe the state of matter inside the star. Field equations. Using the framework of FQ gravity, we obtain the field equations that describe the star. From these equations, we derive expressions for energy density, radial pressure, and tangential pressure. However, the system contains several unknown functions which make it difficult to solve directly. So we are finding unknowns for these. In this compact star model, we have five unknown quantities: energy density rho, radial pressure PR, tangential pressure PT, and mu r and lambda, which are metric potential. Since we have more unknowns than equations, we need an additional physical conditions to solve the equation, which is complexity factor. To simplify the problem, we use the concept of the complexity factor introduced by Herrera. The complexity factor measures how complicated the matter distribution inside the star is. It mainly depends on two factors: the density gradient and the anisotropy of the pressure. In this work, we assume the vanishing complexity factor conditions, which means the complexity factor is set equals to 0. This assumption simplifies the field equations. It also provides a relation between the metric potential, which helps us to solve the relation. After applying the vanishing complexity condition, we obtain the relation, this one, 1.4. Here A and B are integration constants. This relation allows to determine one metric potential in terms of the other. To make the equation solvable, we assume a specific form of the metric potential, which is given under below the 1.7 equation. This assumption is commonly used in compact star modeling. It ensures that the solution is regular at the center and physically acceptable. After choosing the metric potential, we substitute into the field equations. This allows us to obtain expressions for radial pressure, tangential pressure, and energy density. These equations describe the physical properties of matter inside the star. Next one is anisotropic factor. The difference between the tangential pressure and the radial pressure is called the anisotropic factor. This quantity measures how the pressure varies in different directions inside the star. Boundary conditions. To obtain a realistic star model, we apply boundary conditions. These conditions ensure that the interior spacetime smoothly matches the exterior spacetime at the surface of the star. Without proper boundary conditions, the model would not represent a physical star. For the exterior region of the star, we use the Schwarzschild the Sitter solution. This metric describes the gravitational field outside the star where matter density is zero. It is commonly used for the exterior region of the compact star. At the boundary of the star, certain matching conditions must be satisfied.
Excuse me, Tanisha. Please conclude in 5 minutes.
Okay, sir. Next one is graphical analysis. After obtaining the mathematical expressions, we analyze the results using graphs. Graphs help us understand how pressure and density vary with the radius of the star. This step is important to check whether the model is physically realistic or not. First one is radial pressure. In this graph, the horizontal axis represents the radius of the star. The vertical axis represents the radial pressure. The graph shows the radial pressure is maximum at the center and gradually decreases as the radius increases. This behavior is expected for a stable compact star. Next one is tangential pressure. In this graph, the horizontal axis again represents the radius of the star and the vertical axis represents the tangential pressure. The graph shows the tangential also decreases smoothly from center towards a boundary. This indicates a physical acceptable star model. Concluding, in this study, we modeled compact star using the FQ gravity theory. By applying the vanishing complexity factor, we simplified the field equations and obtained exact solutions. Therefore, FQ gravity provides a useful framework for studying compact astrophysical objects. And my future work is, in future work, we plan to further analyze the compact star model. This includes study additional physical properties and comparing the results with observational data from real compact stars. Such studies will help improve understanding of compact astrophysical objects. Thank you, sir. These are the references.
Hello, Tanisha. Thank you for the presentation. Like, as you mentioned, that pressure is one of the boundary conditions. So
Yes,
what changes did you observe, like moving from center of the star to the boundary of the star?
It is density is maximum at the center and then it decreases when we go towards the outward.
So what is impact it has on the pressure? Because pressure is a boundary condition, right?
Yes, sir.
So what impact it has on the pressure?
Radial pressure and tangential pressure are different inside the star, so they can affect the stability and structure of the star like that.
Yes, they are different, but my question is, how do they change from the center of the star to the corner or the boundary of the star?
So, sir,
Okay, yeah, please study into that, and yeah.
Okay, sir.
Okay, there is one more question from the audience. Decreasing pressure density represents which phase of the universe?
Decreasing pressure represents which phase of the universe?
Yes. Yes.
Expanding phase, I already tell in the introduction, where the density and pressure of the matter gradually decrease with time. When the Einstein can't fully explain why gravity why Earth is expanding.
So it is continuously decreasing. That's what you are telling.
Yes, so
Accelerating universe or accelerating universe or deaccelerating universe?
sorry, sir.
It's like accelerating universe or deaccelerating universe.
So decreasing pressure is usually related to the accelerating phase of the universe.
Okay. Any other questions?
Thank you, sir.
Okay. Thank you, Tanisha. Thank you. Palak Singh Thakur, please start your presentation. If you want, you can share the screen. Please unmute yourself.
Yes, sir.
Yeah, please start your presentation.
Okay, sir. One minute, sir. सर दिख रहा है
Yeah, please, can you do it full screen?
सर फुल स्क्रीन ही है
Okay.
शो हो रहा है
Yes, please present.
ओके सर So my name is Palak Singh Thakur. My topic is the first observation of CME solar wind interaction at L1 from Aditya L1 Papa and Mag payloads. Abstract, sir, I will present my poster because I don't have so many time. Abstract control है मतलब इस पे coronal mass ejections are the major drives of intention space weather disturbance due to their interaction with the solar wind and the interplanetary magnetic field. India's first solar mission, Aditya L1, is stationed at the Sun Earth L1 point, offer a unique platform to investigate the plasma and magnetic signatures of extreme solar CME solar and interactions using coordinate measurements from the plasma analyzer package of Aditya Papa and the abroad magnometer for MAG. Papa provides the detailed measurements of solar wind plasma parameters, includes ion velocity, distribution, density, temperatures, and bulk flow variations associated with CME driven disturbance. Simultaneously, MAG records high resolutions interplanetary magnetic field variations, capturing magnetic field enhancement, rotations, and fluctuations characters of CME drive-in shocks and interplanetary. The combined analysis reveals clear plasma compression regions, abrupt solar wind speed change, and enhanced magnetic field during the passage of extreme transient event at the L1 point. These initial results demonstrate the capability of Aditya L1 to identify CME driven shocks, seed regions, and magnetic cloud structures, offering new insights into CME evolution and solar wind coupling process. The study highlights the strong potential of Aditya L1 observation for advancing heliospheric science and improving space weather forecasting. The introduction is the coronal mass ejections are the primary drivers of intense space weather disturbances. These events internally dynamically with the solar wind and the interplanetary magnetic field, leading to geomagnetic storms. Aditya L1, India's first dedicating solar mission, stationed at the Sun Earth L1 point, provides a unique vantage point for continuous near real-time observation of these phenomena without planetary occultations. This study reports the first observational result of CME solar wind coupling using coordinate high resolution data from Aditya L1, Papa and MAG payloads. Instrumentations and methodology. We utilized coordinate measurements from two key in situ instruments abroad Aditya L1. Papa इसका full form है Plasma Analyzer Package for Aditya. Measures solar wind plasma parameters includes ion velocity, distribution, density, temperature, and bulk flow variations to detect plasma compression and shock arrival. MAG, इसका full form magnetometer, records high resolution interplanetary magnetic field variation intensity and vector components to capture magnetic rotations, characteristics of CME structure, magnetic field intensity. Field vector components Bx, By, and Bz. Observation, the combined analysis of Papa and MAG data during the passage of extreme solar transient event revealed plasma signature, clear reasons of plasma compression, abrupt increases in solar wind speed, indicating shock arrival, thermal variation constant with turbulent state reason. Magnetic signature, significant magnetic field enhancement, smooth rotations of magnetic field vectors, indicative of flux ropes or magnetic clouds, high frequency fluctuations marking the turbulent wake of the interactions. So this is the graph. So the 2020 23 24 25 data here. Results: shock identification successfully identified CME driven shock via simultaneously jump in plasma velocity and magnetic field magnitude. Sheath and cloud structure distinguished the turbulent sheath region, high fluctuation from the magnetic cloud, smooth rotation, low temperature. Coupling dynamics provided evidence of energy transfer mechanism between the CME plasma and the ambient solar wind. Mission capability: these initial results validate Aditya L1 capability to monitor extreme solar transient at L1, which is critically for advancing heliospheric science and improving space weather forecasting. Structure identification distinguishes the turbulent sheath region from the magnetic cloud smooth rotation. The conclusion is that these initial results validate the operational capability of Aditya L1 to monitor extreme solar transient. The Papa and MAG payloads are critical for identifying CME structure shocks, sheaths, MCS in near real time. Continuous monitoring at L1 will significantly advance heliospheric science and improve the accuracy of space weather forecasting models. Thank you, sir.
Thank you, Palak, for the wonderful and insightful presentation. Any questions from the audience? What is L1 point?
Sir, L1 point is that जो मतलब sir, can I speak in Hindi?
Of course, yes.
सर L1 पॉइंट ये है मतलब कि स्टार्टिंग L1 पॉइंट से हुई थी एंड आदित्य L1 पॉइंट फर्स्ट तक आए हैं हम जो
बट व्हाट इज L1 पॉइंट होता क्या है क्वेश्चन ये है
सर आई डोंट हैव मतलब exact answers that.
Okay, how many L points are there? Can you tell me? And what is the advantage of L1? Why not L2 or L3?
सर क्योंकि अभी तक हम L1 पॉइंट पर ही जा पाए हैं.
नहीं तो कितने L पॉइंट्स कितने होते हैं? लैग्रांजे पॉइंट्स कितने हैं?
So 11.
लैग्रांजे पॉइंट होता क्या है? Okay, I got one more question from the audience.
Okay.
हेलो पलक.
Yes.
क्या आप हमें इंटरप्लेनेटरी स्ट्रक्चर्स के बारे में बता सकते हैं? What is interplanetary structures? Or you can name them also.
No.
As you have talked about Papa and MAG payload, so what is the role of Papa in this, in your research, particularly in this poster?
Actually मैं रीड नहीं कर पाई हूँ उतने अच्छे से मुझे टाइम नहीं मिला अभी.
Okay, thank you.
I got one more question from the audience. Oh, any other question from the audience? Okay, thank you so much, Palak.
जी sir.
Can I have the next presenter, please?
Dr. Bhupendra Shukla, sir.
Hello. Thank you, sir. My voice is clear?
Yes, sir.
1 second, sir. I will try to share the screen.
Thank you, sir.
My screen is shared?
Yes, sir.
Could you please confirm if my screen is visible?
Sir, it was
and
visible,
my voice
but,
is clear? One, please repeat, sir. Visual?
Yes, sir. Your screen is visible.
Oh, sir, thank you. Good afternoon, everyone. Respected
Sir, please, can you cancel
chairperson,
this side
guest,
Please close or minimize this side screen.
One second, sir.
सर ये ऊपर से टॉप साइड में एक जो व्यू का बटन है उस पर क्लिक करके फुल स्क्रीन कर दीजिए तो आपका हमें फुल स्क्रीन में दिखाई देगा पीपीटी। नहीं वो लेफ्ट साइड में
अभी
सर
भी ये हट
फाइल एडिट व्यू है ना ऑप्शन वहां पर।
हाँ हाँ फाइल एडिट।
हाँ यहाँ जाइए और यहाँ से फुल स्क्रीन। यहाँ फुल स्क्रीन मोड होगा नीचे देखिए फुल स्क्रीन मोड रीडिंग मोड के नीचे फुल स्क्रीन मोड होगा ऊपर से 6 नंबर पे। यस यस सर दिस
ये साइड का हट नहीं रहा सर मीटिंग का।
इट्स ओके सर इन दैट केस यू कैन स्टार्ट और वो आप जूम कर लीजिएगा जब जरूरत पड़े तो।
ओके ओके सर। Firstly, good morning, everyone, respected chairperson, however guested, and fellow participants. It is my great pleasure to present my research work in this conference. I would like to thank the organization and providing me this opportunity. Today, I am talk to entitled Scalar Field Cosmology with logarithmic form of deceleration parameters. First off, discuss basic concept of my field. General theory of relativity. General theory of relativity describes gravity as the manifestation of space-time curvature produced by mass and energy. Cosmology is a scientific study of the origin, evaluation, and structure of the large-scale dynamics of the universe. सर 1 सेकंड ये कैसे हट जाए सर थोड़ा सा और विजुअल हो जाए अपना साइड में दिक्कत आ रही है
सर ये सर क्लोज कर दीजिए।
ओके ओके सर थैंक यू सर। Again repeat, general relativity, Einstein's theory described gravity as the manifestation of space-time curvature produced by mass and energy. Cosmology is a scientific study of the origin, evaluation, structure, and large-scale dynamics of the universe. These theory are basic theory, universe, general relativity, and new era continued modification of general theory of relativity according to 3 factors: curvature, torsion, and metricity. In this here, some basic modified theories like FRT, FQT is extension of general relativity in which the gravitational excess is generalized using function of curvatures denoted by R and non-metricity Q, coupled with the metatricity to explain cosmic oscillation and large scale observation without involving geodetic dark energy. Three geometric description of gravity, like more present is a more work in non-metricity gravity. First of extension of general relativity in terms of FR gravity. Gravity can be described through different geometric properties of space-time. First geometry is depending on curvature. This quantity is denoted by R. This theory is named as general relativity. Second, this modification using without curvature using torsion. This quantity is denoted by capital T. This theory is named teleparallel gravity. Third, this is a non-metricity. This denoted by Q. Symmetric. This theory is named as symmetric teleparallel gravity. Curvature rotate. This means curvature. Curvature rotate vectors after parallel transfers, and torsion cause failures to parallelogram closures. Non-metricity changes vectors length and angle. These figures show the different types of geometry, like GR gravity. This dependent on curvature. This is a teleparallel gravity. This is a dependent on torsion. This is a symmetric teleparallel gravity. This is a dependent on non-metricity. A curvature measure how space-time diverges from flat geometry, mathematically described by the Riemann tensor, like this notation. This is a 1-3 types tensor, like a 4-order tensor. Physical interpretations, this means parallel transformation around a closed low vector rotated, indicate non-zero curvature. Curvature implies rotation of vectors, like these figures. This geometry are like a closed path. If we parallel transfer a vector along a closed loop on a curved surface, the vector does not return with the same direction. This rotation is directed. Next, we explain the torsion. Torsion is measured the anti-symmetric part of affine connection. This formulate torsion. This is a affine connection, lambda mu rho mu nu minus lambda rho nu mu. Physical interpretation, parallel transportation vector fell to from the closed parallelograms. This theory used like this. This is not a closed path. Non-metricity described by the variation of the metric tensor under the parallel transfer according to Q is equal to this. This is a metric tensor. Here used to like a Christoffel symbols to find out the according to metric find the torsion. This formulates. And non-metricity, this is a metric tensor, and this is a covariant derivative. Find this, find the non-metricity according to, and next step, find the field, modified field equations. Physical interpretations, length of vectors changes, angle between vectors may vary. Like this, from gravity to cosmology. Next, we explain from gravity to cosmology. Gravity can be described geometrically through curvature. This is explained also previous slide, torsion and non-metricity. Basic STD of cosmology tools are curvature, torsion, and non-metricity. However, observations show that the universe is currently undergoing an accelerated expansion. One possible explanation is dark energy. A dynamic scalar field is a simple and widely used candidate of dark energy. In this work, we study scalar field cosmology using a logarithmic parameterization of distillation parameters. Some most important problem of in field of cosmology, name as fine tuning and coincidence problem. Fine tuning problem, the observed value of the cosmological constant is extremely small compared to theoretical prediction. Quantum field theory predict a vacuum energy density that is many orders of magnitude larger than observation. Coincidence problem, why are the energy density of matter and dark energy are the same order today? Next, some basic view of scalar field. Scalar field phi is widely used to cosmology as a candidate of dynamical dark energy. For a homogeneous scalar field, phi of T, the energy density, pressure, and equation of state parameters are given by this and these equations. Phi of V is a scalar field potential. Some cosmographic parameters be explained in mathematical. This is dependent on scale factors. H is denoted by Hubble parameters. This is the first derivative of scale factors. A dot upon A. This is Q is a distillation parameter. This is a second order derivative of scale factor. R is also called a jerk parameters. Are some pairwise STD R and S is known as state finder parameters. Likely most standard cosmological models in name as lambda CDM model in this case are equal to 1 and S is equal to 0. Some physical interpretation of cosmological parameters. This is a basic concept of new researchers. Hubble parameters is a dot upon A, measure the instantaneous expansion rate of universe. Some ideas known as Hubble parameters, not a negative value, always positive and decreasing function of cosmic times. This is a positive and decreasing. This means inverse is a expansion. This value is a negative inverse. This means inverse is a contract. But present ratio is a inverse is a expansion. So this means Hubble parameters value always positive and decreasing function of cosmic time. This is a distillation parameters Q. This is formula minus A double dot upon A into H square indicate whether the cosmic expansion is oscillating. This means Q is a negative value or oscillating Q is a positive value. Present scenario universe is a transition phase. This means Q is always time dependent or Z shift dependent. This means Q is vary from positive to negative in with respect to cosmic time T. So this means present ratio inverse is oscillating inverse. Jerk parameters explain the changing of oscillation. This means always jerk parameter is a constant. This means a constant value of oscillation of the inverse. So present ratio inverse is not a constant. This is a moment continuous oscillation. So this means jerk parameter is not a constant value. But lambda CDM models provide the jerk parameters value is 1. This means constant. This means distillation parameter is a constant value. So this is a more confusing concept of new researchers. This means jerk parameters is also a function of cosmic time t, or takes some other in terms of redshift. Snap parameters, this is a fourth order derivative of scale factors. I think first the make of new researchers find the let the matrix and take the energy momentum tensors, find the Einstein field equations, take the two equations and three unknown to take the more one, take a more one equations, solving the Einstein field equation using two methods. First method is known as a model dependent method. Second method is known as model independent. Model independent method means solve the field equation using by energy conservations equation. How to solve energy conservation equation? Taking the equation of state parameters or the Chaplin gas model. So here first B ideas to solving the energy conservation equation using the Chaplin gas models like equation of state, this form, this relation between two pressure and rho. This is a alpha values like between 2, 0 and 1. Next, Chaplin gas, generalized Chaplin gas equation, this forms. Here equation this form, find the state parameters behavior are greater than 1 and yes less than 0. New concept of other parameters according to cosmological models, Q-sense model. This means equation of state parameters value like between -1 to -1/3. So this means our model is a Q-sense model. In these models, must be jerk parameters less than 1 and snap parameters greater than 0. And first derivative with respect to redshift, this means omega diagnostic less than 0. This next cosmological model name as phantom model. Phantom model means equation of state parameters less than -1. In these models also jerk parameters and snap parameters like this behavior. Our new things like the work FR and FQ and FQT theory in this model does not matter R and S, order pair does not equal 0 and 1. This means only general theory of relativity, not a modified theory of gravity. Next is explain the equation of state parameters from the physical interpretation. Equation of state parameters is a ratio of pressure and energy density. This means the value of equation of state parameters 0 corresponding to pressureless matter like a dust governing the matter dominant era. Next, omega is equal to 1/3. This represents the radiation evaluation in the early inverse. Omega is equal to -1. Describe the cosmological constant, producing the constant of energy, density, and accelerated expansion. This means omega like -1 to -1/3. This model is known as Q-sense models. This is explained also in previous slide. Omega less than -1. This means omega is omega less than -1. This means model is a phantom model. Phantom model and coincidence model, both different model. This model is a super accelerated expansion. Our inverse is a super accelerated expansion and possible future singularities. New some ideas in a FRW model. FRW model, this matrix is a homogeneous and isotropic. matrix. In this field, we use scalar field xn, so in equation number second. The for a homogeneous scalar field phi of t rho of phi denoted by this equation, and phi p of phi denote this equation. Cosmic evaluation for the Friedman equations. This see here, this equation, this is a Friedman equations. This is also called Einstein field equations. Solving this equation, here see the number of unknown 1, 2, and 3, and number of equation is 3. So this is not possible to direct solve this equation. So we take the additional properties, additional equation solving this equation. So this equation solving is two method. I explained to previous model dependent and model independent. So in this paper, we take two model independent techniques. So first we take the new concept. Some authors take the deceleration parameters like a linear form of redshift and Taylor expansion of redshift, but be not many complicated solve to the Hubble parameters value. We have proposed a logarithmic form. Is a very easy to solve, very easy to find the Hubble parameters value. In this form, Qz is equal to Q0 plus Q1 log 1 plus Z. These equations deceleration parameters solving to Hubble parameters like this form, h of Z is equal to h naught exponential of integration 0 to Z 1 plus Q upon 1 plus X dx. Put this value, putting the value of Q in the equation or solving to this integration, find the value of Hubble parameters, like this equation number 4. Here we see the main complicated, find these values. Here h dot is denoted by Hubble constant, the initial value of Hubble parameters. Q naught and Qn is a free parameters. How to find this values of this? How to find this value of free parameters using by many cosmological observations like CC data, supernova data, and BO data. In this paper, we find this value using CC data, standard candle data, take the range of Z is equal to 0.001 to 2.16, and BO data or 90 product data. Find the MCMC techniques. This is a post-test distribution confidence graph like this, and find the best fit values of Hubble current value of Hubble parameters 171.41 plus minus 0.98, and Q naught value is minus 0.55, and Q1 value 0.5. On more important to find the priors, take to find this value. How to take the priors? B takes the priors. This means the current values of Hubble parameters like to Pantheon plus SUS data like 74.03 and CMB and the Planck collaboration data like the current value of Hubble parameters 66 point something, but present not a correct value like the 66 point something, and Pantheon plus source data like this. So this means I have choose the priors, get the above models Hubble parameters like between this values 66 to 74 between. The most current problem in cosmology is a Hubble torsion problem. not justify the current expansion rate of the inverse. जितने भी अभी तक अपने भी रिसर्च हुए हैं, किसी ने भी हब्बल पैरामीटर की एग्जैक्ट वैल्यू किसी भी डेटा से, ना तो डेटा से मिल पा रही हैं ऑब्जर्वेशन से, और ना ही अपने थ्योरेटिकल मॉडल से. ओनली प्लांक कोलैबोरेशन मेंशन द 66.6 and supernova data, Pantheon plus data like these values. This show the graph in figures. This comparing with the standard models with our models. Here the reconstruction of expansion history of physical consistent. The negative value of Q naught confirm the inverse is currently in an accelerated expansion phase. From the condition, this means Q is equal to 0. Find the transition values of Q naught transition value. Transition value is in our model 0.785. In equation 6, this implies a transition from the distillation to accelerated about 6 to 7 million year ago. The scalar field construction is a physically consistent. This graph is also an equation of state parameters. This value is also like between two. The current value of Q naught is minus 0.79. This is like between minus 1 to 3 minus 1 by 3. This means our model like Christensen's models. Their scalar potential phi b and kinetic form phi dot b remaining positives. In this work, we construct the late time cosmic expansion history using a logarithmic parameterization of the distillation parameters like this. This is a new condition, not a published present times. The logarithmic form of this parameter is a very frustrating result comparison between two lambda CDM models like transition values. This last B suggests the future work in this models use the BODC data and sigma 8 data like to construct this model in find the new free parameters value. Also, this work is done in modified theory like EFT, FQT, and FRT, same workers. Thank you for your time, sir.
Any question from the audience? Thank you, sir, for the wonderful presentation. Can you please, like, I had a little question about the energy density of the dark energy. So you mentioned that it remains constant, the density of the dark energy.
Density of dark energy, this is find the magnitude values of cosmological constant like capital lambda denoted by the Einstein.
Yes, sir. So it remains constant. So, like, is there any reason why it remains constant? Because the universe is expanding continuously.
Most problems, sir. First, I will discuss this. This is a main problem in cosmological model, according to your question. Very nice question, sir. Here we see the 1 second. So we see the fine-tuning problems. Order the cosmological constant is extremely small compared with theoretical. This means, and why the energy density matters and dark energy are the small order today. This value is a small order. This is a main problem in cosmology. This means कितनी हो सकती है अपनी जो वैक्यूम एनर्जी डेंसिटी है वो कितनी हो सकती है, वो कितना इफेक्ट डाल सकती है इनवर्स के एक्सपेंशन पे. फर्स्टली इन ईयर 99 तक only discuss the inverse is expansion. not an inverse accelerated expansion. But 1992, 1992 राइज 1 मिनट सर, नेम थोड़ा सा मैं भूल रहा है, उन्होंने ये डार्क एनर्जी से ही एक्सप्लेन किया कि इन्वर्स जो है हमारा वो ओनली एक्सपेंशन ही नहीं दे रहा है, एसिलेटेड एक्सपेंशन है। अब वो एसिलेटेड एक्सपेंशन जो हो रहा है वो किसकी वजह से हो रहा है? डार्क एनर्जी की ही वजह से हो रहा है।
सर आपने अपने मॉडल को और क्लासिकल मॉडल को इवेलुएट किया है कि आपका मॉडल और क्लासिकल मॉडल कितना एक्यूरेट है?
अपना जो क्लासिकल मॉडल है सर वो लेमडा सीडीएम मॉडल है, जिसको हम लोग बोलते हैं स्टैंडर्ड मॉडल। तो स्टैंडर्ड मॉडल से की जो वैल्यू है उससे हम लोग अपने मॉडल को पुटअप करते हैं, जो हम लोग कांस्टेंट वैल्यू लेते हैं। जैसे हमने अपने में जो पैरामीटराइजेशन किया है वो पैरामीटराइजेशन में क्या लिया, Q इक्वल टू Q नॉट प्लस Q1 log 1 प्लस H। तो सबसे मेन जो अपना रोल होता है, तो इसमें जो हमने कांस्टेंट टर्म वैल्यू ली है Q नॉट और Q1, Q नॉट से यहाँ जैसे हमने अगर Z इक्वल टू 0 रख दिया तो log 1 हो गया तो उसकी वैल्यू 0 हो गई, तो Q की जो करंट वैल्यू हो जाएगी वो क्या हो जाएगी, Q नॉट हो जाएगी। तो यहाँ पे हम जो वैल्यू निकालते हैं किसकी, Q नॉट और Q1 की, तो वो हम लोग किससे निकालते हैं, यूजिंग टू MCMC टेक्निक्स यूज टू ऑब्जर्वेशनल डेटा लाइक CC एंड सुपरनोवा डेटा, BO डेटा। तो वहां से हमें ये मिल पाता है कि जो हमारा मॉडल है वो एक्यूरेट कितना स्टैंडर्ड मॉडल से हो रहा है।
सर ये जो आप, हेलो,
हाँ मैडम बोलें।
ये जो आपका मॉडल है एस्ट्रोफिजिक्स एंड स्पेस वेदर के रिसर्च के लिए यूजफुल है, और है तो किस प्रकार से?
सर प्रेजेंट सिनारियो जो है वो उस पे दे रहा है कि करंट रेट ऑफ एक्सपेंशन ऑफ इन्वर्स क्या है। दिस प्रॉब्लम इज कॉल्ड हबल टेंशन प्रॉब्लम। तो आई विल ट्राई टू सॉल्व टू हबल टेंशन प्रॉब्लम कि प्रेजेंट एक्सपेंशन रेट इन्वर्स का कितना है।
Light year are simple.
Light year, so this means called this is a kilometers per second megapascals unit. Like this, this values is give the Pantheon plus source data, measure the current expansion rate of the inverse, like 74.03 plus minus 1.42 kilometer per second megapascal. But other models, we find the value of current rate of expansion of inverse 71.41. This is a value which is slow according to Python source data.
Thank you, sir. Sir, sir, one more questions.
Yes.
Hello.
Hassan.
Sir, here you can use supernova. So it is observatory or about star?
I have no idea about this, sir. Only using the observation data use only, not astrophysics side STDs.
From which observatory or site?
Only find to the observational data points like a Z0 point, this redshift value, how to find the Hubble parameters value takes this type values of our model.
Okay, sir. Thank you.
Okay, sir.
Sir, I have one small question. Like you mentioned that they are in the same order, dark energy density and the matter density, right?
Yes.
But the universe, it is like expanding. So the matter density, it is decreasing. Am I right?
Matter density. The current values matter density, sir, omega m values is a standard model 0.3. This is also decreased.
Oh, yes. So that's why it is expanding. So it should decrease. and the dark energy
Yes, sir.
density, it remains constant. So how
Yes, sir.
can they be of same order? If
One minute, sir. The present values in the standard models, dark energy density values is a 0.7, and matter energy density values is a 0.3, and total values of energy density like 1.
So, but then how can they be of same order? So it's like equals to 1 always?
Total energy values equal to 1.
But that is energy density, right? Not total energy.
Total energy value is 1.
Total energy density.
Yes, sir.
So matter density plus dark energy density equals to total energy density. That's what.
One second, sir.
Because
Some researchers use dark energy and radiation energy use like omega r's and omega lambdas, like the more papers. Three types to many fluid use, but standard model only like two types of fluid: dark matter and dark energy. So here only take two part here: dark energy and dark matter energy density. Are you clear, sir?
Thank you, sir.
Okay, sir.
Dr. Ankit Pal.
Thank you again, sir.
Yes, sir, I'm here.
Ankit Pal, please share the screen.
Wait, sir.
You have 10 minutes, right?
Yeah. Maximum I will take 10 minutes. Is the screen visible to all?
Yes, the screen is visible.
Good morning, everyone. I am Dr. Ankit Pal from VIT Bhopal University. I will be talking about Dirichlet averages of 5-parameter metacollector function. Basically, it is a work of, we can say, analysis, mathematical analysis, or it is pure mathematics work, we can say here. So these are the outlines of my presentations. So here I will use some basic definitions of the some different kinds of special functions. And then particularly I will use here the 5-parameter metacollector functions. And then I will use here also, that is the pathway fractional integral operator. That is basically, you can say, the extension of Riemann-Lovely fractional integral operator. And then finally we come to the main work, that is we have considered here the bivariate Dirichlet averages and the multivariate Dirichlet averages that I will consider. So we can start with here the introduction, basic preliminaries about the metacollector functions here. So if you are familiar with the metacollector functions, so basically we can say here metacollector function, it is simply the extension of the exponential functions. So exponential functions, I hope everyone is familiar with the exponential functions. So in 1903, the Swedish mathematician Gustav Metacollector, they introduced here the metacollector functions, that is E alpha z, that is summation. It is running from m equals to 0 to infinity z to the power m divided by gamma alpha m plus 1. So now this is called here the 1-parameter metacollector function we have here. So now if we take here alpha equals to 1, suppose if I take here the alpha equals to 1, so that is we can this the denominator part, it will be have here that is the gamma n plus 1, you can make here m factorial. So that will be reduces in terms of exponential function, we can say. So that's why it is known as, it's a extension of, or you can say generalization of the exponential function behavior. Later in 1905, the Riemann takes the 2-parameter to generalize the metacollector function, that is called here the E alpha mu z. So that is denoted by the equation 2 here, right? So here we have the alpha mu, these are the complex parameter we have here, where real part of alpha and real part of mu is also greater than 0 behavior. Later, after many years, in 1975-71, Prabhakar introduced the 3-parameter metagalactic function. That is, we have here the E alpha mu and nu of Z, right? That is defined by the equation 3. And here all the parameters belongs to the set of complex numbers, and real part of alpha, real part of mu, and real part of nu is greater than 0. We may have a different kinds of metagalactic functions also, but particularly I have written 3 here. Now, one more thing we can see here, we have the generalized right hypergeometric functions. So right, he gave a generalization of the generalized hypergeometric functions, that is called the Fox-Wright function here. It is defined by the equation 4. And in the numerator, it has the f parameter, and in the denominator, it has the g parameter here, and which satisfies the convergence criteria here, which is defined by the equation 5. So in particular, if all the numerator is the capital parameter, if you see here R1, R2, and so on, Rf, and S1, S2, and so on, Sg, all these, if you take here 1, so this Fox-Wright function that will be reduced in terms of generalized hypergeometric function, we can say. Now we use here the Srivastava-Daus hypergeometric function, that is called here the multivariate hypergeometric function also. That is also very useful in our present study. And one more function we can see here, we have the Laurentius hypergeometric function, that is also very useful in the study here. That is also, we can say, we have the multi-dimensional series we have here. Now come to the pathway fractional integral operator. So Nair invented the pathway fractional integral operator by using the pathway concept of Mathai. Later it was addressed by the Mathai and Habold. Okay, so let f of x, which belongs to the set of Lebesgue measurable functions we have here, and lambda, if you see here, that is belongs to the set of complex numbers, and real part of lambda is greater than 0, and a is the real positive numbers. Then the pathway fractional integral operator, it is defined by the equation 10, where omega is less than 1, which is called the pathway parameter we have here, and L1 AB, that is called the space of Lebesgue measurable functions. So basically, it's a generalization of Riemann-Leibniz integral operator we have here. So for omega equals to 0, if we take here omega equals to 0 and a equals to 1, and if we are replacing lambda by lambda minus 1, so pathway fractional integral operator that will be reduced in the form of the Riemann-Leibniz fractional integral operator here. So that is, we have written here the gamma lambda, that is the I0 plus power lambda function of x we have written here. So that is known as here the left-sided Riemann-Leibniz fractional integral operator we have here. And now we come to our main function. So that is, we have used in our study. So that is, here we have taken here the 5-parameter metagalactic function we have here. So this function was introduced by the Ojarslan and the Fernandez, and he studied the bivariate fractional calculus operator associated with these 5-parameter metagalactic functions we have. So where alpha 1, alpha 2, and beta 1, beta 2, and gamma belongs to the set of complex numbers. And for the convergence criteria, he took the real part of alpha 1 plus alpha 2 greater than 0. So basically, I am going to implement this function here for some representation of the Dirichlet averages of the 5-parameter metagalactic functions. Now we talk about here something about the Dirichlet averages here. So Carlson's created the idea of Dirichlet average in his work here, and he gave a comprehensive in-depth analysis of the various variety of the Dirichlet averages. So basically, the Dirichlet averages, it is the integral mean of a function with respect to the Dirichlet average. So the average, maybe you have seen something. So averages is the sum of the parameter. It is divided by the number of parameters. So here, there we took the sum. So that is for the discrete series. Now here we have to take the integral functions. So that is for the continuous functions we can see here. So that is why it is called the Dirichlet averages. So here we take let S be a convex set.
Conclude in 5 minutes.
Yeah. Let S be a convex set in the set of complex numbers, and suppose f of z is measurable functions here. So the general Dirichlet average of f of z, it was defined by the equation 14 we have here, and here em minus 1, that is called here the Euclidean simplex. Here it is defined for the m minus 1 tuple we have taken here, and the tau object, that is a composite function we have here, which is defined by this 16, and d mu eta of tau, this is called the Dirichlet averages, and which is expressed by the equation 17 and 18. So b of 8 eta, this is called here the beta multivariate beta function we have here. So particularly we take here the case of m equals to 2 we can see here. So here we have taken d mu eta 1 comma eta 2 of 2, that is defined by the equation 19, and The Carlsons investigated the Dirichlet averages of particularly this power function, that is z to the power k, and it is defined by the 20. Similarly, one more case, it was taken 5 for m equals to 2, that is he have taken rk eta 1 comma eta 2, and it is he took two parameters u and v, so it is defined by 21. So basically I am going to use this concept here, which is defined by the equation 21, to define my work here. So see, it is the bivariate Dirichlet averages. So from here I have started my work here. So Dirichlet averages of the 5-parameter meta-clever functions, it is defined by the equation 23 we have here. So within the integrations we have taken here the 5-parameter meta-clever functions, where real part of alpha 1, alpha 2, it is greater than 0 here. So first we have developed here the first theorem, that is called here the Dirichlet averages of the 5-parameter meta-clever functions, which is described by the following expressions here. And see, we have written this following bivariate Dirichlet averages of the 5-parameter meta-clever functions in terms of the pathway fractional integral operator. It can be written also in the form of the any kind of special functions, if you are familiar. So that is just proof I have written here. So that is a little bit variety of the manipulations techniques we have used here to prove this theorem. Similarly, we have taken the corollaries. That means if we take here the argument u is 0, so this Dirichlet averages, it can be reduces in the form of the right hypergeometric function. Similarly, we have taken v equals 0, so that is also reduces in the form of the right hypergeometric functions. Now, if we take the gamma equals 1, so that will be reduces in the terms of the 4-parameter right function, that is we can see here. Now we slightly modified this bivariate Dirichlet averages, which is defined by the equation 28. So here we multiply by these power functions, and again we have developed the same kind of theorems. So that is called the bivariate Dirichlet average of the 5-parameter meta-clever functions, which is defined by the equation 29. Now here also we have taken a similar kind of corollary by taking gamma equals to 1, so that is reduces in the form of the 4-parameter right functions. Now in the next theorems, we have introduced here the representation of the bivariate Dirichlet averages of the 5-parameter meta-clever functions in terms of the multivariate Srivastava-Daus functions we have written here. Now we took here wait, sir. The multivariate Dirichlet averages. See here we have the multivariate variables for these Dirichlet averages. So we have used here the following lemma 1.8, that is also very useful here. So if you see here equation 36, we have taken here the multivariate Dirichlet average of these functions we have here. So for this we have find here the multivariate Dirichlet averages of the 5-parameter meta-clever functions, which is we have written in terms of the Laurent hypergeometric functions. Now we have the corollary also, that means if all the parameters are equal, so that is we have taken z here, so then the multivariate Dirichlet averages of the 5-parameter meta-clever functions, it is reduces in the form of the 5-parameter meta-clever functions. The proof is straightforward, that is we have used here. Similarly, we have taken the modification of these multivariate Dirichlet averages of the 5-parameter meta-clever functions. It is defined by the equation 14, and similar kind of theorem we have again developed here, but the result I have written in terms of the multivariate Srivastava-Daus functions. Yeah. Same thing again, we just same corollary we have taken here by taking all the arguments equals to z, and the results we have written here in terms of the 5-parameter meta-clever functions. So these are the references which I have used here for this work. Thank you, sir.
Thank you, sir. I have a question.
Yeah.
Have you prepared any such kind of physical model according to your theorem?
Not model, we have the applications we can see here, particularly those who are familiar with the Euler-Darboux equations in the Holder spaces. So solution of Euler-Darboux equations, somewhere in the physics, I don't know exactly.
Okay.
Euler-Darboux equations, solutions of Euler-Darboux equations that can be written using this concept of the Dirichlet average also. And particularly in the B-splines and the Dirichlet splines also, we can use this concept here.
So, have you tried to solve boundary wall problems according to this particular equations?
I understand it is related to the physics. I will try. If it is possible, I will try. It is a work of the purely mathematics, development of mathematics. I'm working here.
Okay.
But yeah, I'm interested in the physics also, some kind of applications. I have written some applications in the field of, we can say, the fractional kinetic equations, free electron laser equations, and the variety of applications. I have written some research papers regarding this one.
Okay. One more question from audience.
Yes, sir.
Thank you. So, like, is this an open boundary or a closed boundary?
Where?
Model.
Boundary, it's not model, sir. It's simply we can say because see, some kind of model I have not considered yet. Simply I am introducing my work in the perspective of the five parameter metaglyph function.
Open
Yes,
boundary or closed boundary? If you have not developed the model, your framework, is it open boundary or closed boundary?
particularly I will take the open boundaries. I will take.
Okay, so you work on open boundaries, right?
Yeah.
Any limitations?
Limitations is if I am developing here the theorems, it is subject to the convergence conditions of the gamma functions. It is very essential thing. If I am writing here the theorems, that should be always satisfied and exist also. Otherwise, the validation of the theorem that will not be fulfilled here.
Okay, yeah.
Hmm.
Thank you. Yes,
Okay, sir.
one more question.
Yes, sir.
Hello.
Yes, ma'am. Yes, ma'am.
Use the Mittens-Lever function in your study.
Yes.
5 parameter, but we can we use the some other parameters here?
Yes, ma'am. You may take here the we have the variety of the metaglyph functions that has been studied in the work. Okay, ma'am. You can use any functions and try to implement here. See, I have taken here the 5 simplest functions I have taken here of the single argument I have taken here. But see, the results are straightforward. We have written here in terms of the multivariate or bivariate functions we have written here. But try to take here the bivariate metaglyph functions, because if you're using here the bivariate metaglyph functions, that means we have taken here more than one argument here. So if I'm writing here the result, here we have the results, you can say in terms of the Riemann-Leibniz integral operators. So you may write your result according to the bivariate metaglyph functions in terms of bivariate fractional calculus operators. So that is very interesting work you can use here.
Can we define the range of this Mittens-Lever function?
Range, yes, ma'am. See, we have taken here. Yes, ma'am. See, all these convergence conditions I have taken here. See, these are very important convergence conditions I have taken. These are very important. Here we have taken real part of alpha is greater than 0, so that is, it should be always satisfied here. Here also we have taken a real part of alpha, real part of mu greater than 0, and all these parameters of set of complex numbers. And same thing we have written also.
Have you
Same for the, yes, ma'am.
Have you solved this equation for any particular value?
Yes, we can take here alpha if we take here, so that will be reduced in the form of the exponential functions. Now, if you take here alpha and mu, both if you take here 1, so that is again, you can reduce in the form of the exponential functions, or you can take mu equals to 1, so that is why these are called here the generalization of these metaglyph functions.
Okay, thank you.
Any other things, sir?
No, thank you very much, Dr. Ankit Pal.
Yes, sir.
Aishwarya S.
Yes, sir.
Can I leave, sir?
Yes.
Okay, thank you.
Aishwarya, you have total 10 minutes, 7 minutes for presentation and 3 minutes for question answer, sir. Okay.
Okay.
You may present.
Screen visible, sir? Sir, is my screen visible?
Yes, yes, it is.
Okay. Good afternoon to respected chairperson, distinguished faculty members, and my fellow researchers. Today, I am pleased to present my research work on the topic fixed point theorems on rationalized contraction in perturbed beam metric spaces. And I am S. Aishwarya, a research scholar, Department of Mathematics, Queen Mary's College, under the guidance of Dr. R. Hemavati and Dr. R. Sumitra. Here's my abstract. This paper generalizes fixed point theorems in the setting of perturbed metric spaces and advancement over traditional metric spaces. Utilizing the technique of perturbed metrization, which maintains the completeness property of the space, we establish generalized contraction conditions. Introduction. Metric spaces form the backbone of modern analysis and play a crucial role in topology, function analysis, and fixed point theory. The classical notion of a metric provides a precise way to measure distances between points and has been successfully applied in studying convergence, continuity, and the stability of various mathematical models. However, in many real-world and theoretical situations, the exact measurement of distance may be affected by external disturbances, uncertainties, or control parameters. Such perturbations arise naturally in areas such as numerical analysis, optimization, dynamical systems, and applied sciences, where ideal conditions are often too restrictive. To address these limitations, several generalized distance structures have been introduced in the literature, including partial metric spaces, B metric spaces, control metric spaces, and external metric type spaces. These generalizations relax one or more axioms of classical metric spaces while preserving sufficient structure to develop fixed point results and convergence theory. Motivated by these developments, perturbed metric spaces are introduced as a further extension of the classical metric framework. In this setting, the distance function is modified by a perturbation term that allows control deviation from the standard metric axioms. This perturbation provides additional flexibility while still maintaining essential analytic properties. The notion of a perturbed metric space was introduced by Mohammad Jili and Bessam Samet in 2025. The notion of perturbed B metric space was introduced by Erdal Karapinar in 2025. They proposed a more general form of distance functions to handle situations where measurements are affected by small errors or deviations. In practical measurements, errors may be positive, negative, or zero, and such inaccuracies can significantly influence the computed distance. To overcome this difficulty, the perturbation term is incorporated into the metric so that the structure still retains many properties of classical metric spaces when the errors are small. Perturbed metric spaces are viewed as an improvement or extension of classical metric spaces. They help bridge the gap between the mathematical models and real-world situations where exact distances are often not measurable. Gilly and Samet also use this framework to generalize Banach's fixed point theorem, motivated by the observation that distance measurements are always affected by small errors. Now we have generalized contractions for perturbed metric spaces. In this section, we will discuss some concepts and findings related to the perturbed metric space. The symbols R, R plus, and N represent the set of real numbers, positive real numbers, and natural numbers, respectively. So here are the definitions which are basically used in my study. Perturbed metric space. Let x comma d be a metric space and let p be a function from x cross x to close 0 to open infinity. Be any non-negative symmetric function satisfying p of x comma x is equal to 0. Define d a function from x cross x to close 0 comma open infinity by d of x comma y is defined as small d of x comma y plus capital P of x comma y. Then this capital D is called a perturbed metric on x with respect to P if for all x, y, z in x, these four conditions are satisfied. That is, d of x comma y is greater than or equal to 0, d of x comma y equal to 0 if and only if x is equal to y, and d of x comma y equal to d of y comma x, and d of x comma z is less than or equal to d of x comma y plus d of y comma z. The function p is called the perturbation mapping, and small d is equal to d minus p is called the exact metric, and xtp is called a perturbed metric space. Note, p need not be actually a metric since p of x comma y equal to 0 does not necessarily imply x is equal to y. Hence, p may be a pseudo-metric. So I have given an example for that. When x is equal to real number r, defining p of x comma y equal to absolute function of mod x minus mod y, taking x is equal to 1 and y is equal to minus 1, then my function p of 1 comma minus 1 is 0, but whereas 1 is not equal to minus 1. And defining small d of x comma y, that is the exact metric, is equal to absolute function of x minus y. Then my capital D of x comma y, that is my perturbed metric, is absolute function of x minus y plus absolute function of mod x minus mod y is also a perturbed metric. So in this case, capital P need not be a metric, so it could be a pseudo-metric. Definition of perturbed B metric space. Let x comma d be a metric space, and these are this definition has few changes from the perturbed metric space. I just like to highlight that alone. In perturb metric space, we would have not introduced S element, so that S element has been introduced in this perturb B metric space where S is greater than or equal to 1.
Please conclude in 2 minutes.
Sorry. Yeah, sure, sir. Whereas the definition is the same. And here in the last point, my inequality is defined as d of x comma z is less than or equal to s times d of x comma y plus d of y comma z. So this is called the perturb B metric space. And here I've given a remark, a perturb B metric space on X is not necessarily a B metric or a standard metric on X, and I have given an example for that. Preliminaries are when P and Q are two perturb mappings, then P plus Q by 2 also comprises a perturb B metric space. And if XTP are perturb B metric space, then X comma alpha D comma alpha P is also a perturb B metric space. Here are the definitions for the convergence, Cauchy sequence, complete perturb B metric spaces, and perturb continuous mapping. Here I've given the definition of a comparison function, that is xi be the class of all self-mapping xi from close 0 to infinity that fulfills the condition xi is non-decreasing and the summation of xi power n of t is always finite, and xi power n is the nth iterate of xi. Xi is subadditive. Here comes my main result. Let x comma d comma p be a complete perturb B metric space and t is a function from x to x is a contraction mapping such that for every xy in x satisfies d of tx comma ty less than or equal to xi of maximum of d of x comma y, d of x comma tx, d of y comma ty into d of y comma tx, and a rational contraction that is d of x comma tx into d of y comma tx divided by d of x comma y plus d of y comma tx, where xi belongs to the set of all comparison functions, and d of x comma y plus d of y comma tx not equal to 0, then t has a unique fixed point. This theorem comprises of the proof that I'll be generalizing the iterative sequence, then I'll prove that it is convergent, then it is actually a Cauchy sequence, and since this my metric space is a complete, I can say it converges to a point in the in my set X itself. So then and finally I'll be proving that my fixed point is unique. I have given an example here. When X is equal to close 0 comma infinity, I'm defining exact metric B metric d of x comma y is equal to x minus y the whole square and p of x comma y equal to 1. Then my perturb metric d of x comma y is equal to x minus y the whole square plus 1. So the mapping, contraction mapping p of x is equal to x plus 3 by 2. Then for this case, my fixed point will be 3. Conclusion. This work we investigated the behavior of generalized contraction mappings in the framework of perturb metric spaces. By working in this generalized setting, we are able to extend classical fixed point results beyond the limitations of standard metric spaces. We established the existence and uniqueness of fixed points theorem for generalized contraction under suitable conditions in a complete perturb metric space. The obtained results demonstrate that the presence of a perturbation term does not obstruct convergence. Instead, it allows a wider class of mappings to satisfy contractive conditions that fail in the usual metric sense. Our results unify and generalize several well-known contractions. The use of generalized contractions in perturb metric space enhances the applicability of fixed point techniques to problems involving uncertainty, approximation errors, or control deviations. Here are my references. Any questions?
Hello.
Yes.
Can we construct any physical model from your this conclusion?
Yeah, we can construct any physical model, ma'am. Actually, this the application will be like from finding finding unique solution for integral equations, differential equations, even for fractional differential equations, Fredholm integral equations. All we can find unique unique solutions. So that will be my ultimate study for my application.
Okay. So, which equations, which differential equations can we use in which area? For which
In fundamental,
differential equation from this part?
we can use for integral equations or Fredholm, then partial differential equations and all we can use one. So I'm under that study actually.
Please go to your conclusion part slide.
Yeah, ma'am.
Here you are mentioned the some previous slide flexible of the metric equations. What is the flexible formulation? You have written, framework for the fixed point.
Yeah.
What is this?
Framework. Okay, fine. This actually helps in minus that we can even study non-linear part, ma'am. But I'm not studying that. My ultimate goal is actually to iterative algorithms and for finding solutions in integral equations. So I'm not into the non-linear mappings.
It's okay. Okay, thank you.
Can I have the next presenter, please? Lata T, please start your presentation and you got 10 minutes.
Okay, sir. Thank you.
Lata, you have 7 minutes for presentation and 3 minutes for question answer session. So,
Okay, sir.
to conclude within 7 minutes.
Is my screen is visible, sir?
Your screen is visible.
Okay, thank you, sir. First of all, I would like to thank everyone for giving this opportunity. Myself, Latati, research scholar in the Department of Mathematics, MIT Manipal. I'm working under the guidance of Dr. Vijay Fernandez. The title of my presentation is Investigation of Electrohydrodynamic Flow with Ionic Transport using Homotopy Analysis Method. This is the flow of the presentation. To begin with, I would like to give brief introduction of two main concepts present in my study, microfluidics and electrophoresis. Microfluidics deals with the manipulation and control of fluid at the microscale, typically in channels with a dimension of 10 to 100 micrometers. It enables precise control of fluid flow, making it ideal for application in biomedical diagnostic, chemical analysis, and lab-on-chip devices. In this case, the flow is typically laminar and the surface forces dominate over the inertial forces, whereas electrophoresis is the motion of charged particles under the influence of an external electric field. These are widely used for the separation and analysis of biomolecules like DNA, proteins, and ions. In microfluidic devices, electrophoresis allows high resolution and rapid analysis due to short diffusive paths and low sample volumes. This is the formulation. We consider a steady, incompressible two-dimensional fluid flow in a channel influenced by an external applied electric field, which is given in the equation figure number 1. Here we are applied electrodes in the transverse y direction, and the flow is in x direction. The flow is fully developed, and we consider the height of the channel as 2h, and the potential we are applying upper plate is pi is equals to pi 1 and lower plate is equals to pi 2. Based on this schematic diagram, we consider the governing equation, which are given in the equation number 1 to 6. Equation 1 is the continuity equation. Equation 2 and 3 is the momentum equations in the x and y direction. Equation 4 represents the Poisson equation. Equation 5 and 6 represents the Knell-Planck equation for both positive and negative ions. Here, if momentum equation is considered for the fluid flow, and the Poisson equation is considered for the electric field, and Knell-Planck equation considered for the positive and negative ions. These four equations are coupled equations. And for the simplification, we are considering low Reynolds number condition. In the low Reynolds number condition, inertial effects are negligible. and the electric field is applied transversely and stream variation are ignored, thus the equation number 1 to 6 reduces to following form, which is given in the equation 7 to 12. To convert these partial differential equation into ordinary differential equation, we consider the stream function formulation. Equation 13 represents the stream function we are considering, where u naught is the velocity, and the equation number 14 and 15 represents the velocity components. Substituting these velocity components in the continuity equation satisfies, and the electric potential and the ionic expression are given in the equation number 16, where the Q of eta and H of eta are the dimensionless potential and ionic concentration. Substituting all these velocity components and electric potential and ionic concentration into the PD equation, we will get the ordinary differential equation, which are given in the equation number 17 to 21. dP represents the electric pressure gradient parameter. M is the magnetohydrodynamic parameter, where K is the electrostatic parameter, and the P is the Peclet number. P electrical is the electric Peclet number, and these ordinary differential equations are subject to the boundary condition, which are given in the equation 22 and 23. To solve this equation, we use the homotopy analysis method, which is a series method, which is given by Leon. And the equation 17 through 21 admit analytical series solution, which are expressed at.
Please conclude in 2 minutes.
Sir, 24 to 28. FM, GM, QM, and denotes the mth order deformation. These are the initial guess we are considering. These initial guess satisfies all the boundary condition. These are the results and discussion. Figure 2 represents the velocity variation for the different values of the pressure gradient parameter dP. Velocity increases with the dP, showing the stronger pressure gradient, enhance the fluid flow. And this is the impact factor of the electrostatic parameter K on the velocity gradient profile. Increasing K reduces the magnitude of velocity gradient due to enhanced electrostatic effect. This is the variation of electropotential Q of eta for the different values of electrostatic parameter K. Electrical potential varies smoothly and symmetrically. Higher K reduces the magnitude of the potential. Figure 5 represents the variation of concentration profile for the positive ion. The positive ion concentration decreases from the lower wall to upper wall and thus remains smooth for all the values of K. Figure 6 represents the variation of concentration profile for the negative ions. The negative ion concentration increases from the lower wall to upper wall for all values of K. This is the variation of combined profile for S minus H for the different value of material parameter K. These are the H curves we plotted using Ham method. Conclusion: the homotopy analysis method provides accurate and convergent solution through the appropriate selection of the auxiliary parameter H. The pressure gradient parameter significantly enhance the axial velocity distribution inside the channel. The electrostatic parameter K strongly influence the electrical field, electric potential, and ion concentration distribution, indicating strong electrohydrodynamic coupling. And increasing electrostatic parameter K leads to the increasing in the effective electrical double layer, thereby strengthening electrostatic interaction near the channel walls. The thickening of ETL reduces the velocity gradient near the wall and significantly modify the ionic transport behavior. The results demonstrate a strong coupling between the fluid flow, electric field, and ionic transport. These are my references. Thank you. Any questions, sir?
Use K is equal to 0.5.
Yes, sir. Yes, sir.
Is it applicable for less than 0.5?
It is applicable, sir, but we are consider from 0.5 to 1, like this, sir.
Why?
Because we will not, the graphs we will getting from 0.5 to 1 is clearly visible, sir. So we are taken as.
Okay, thank you.
Thank you, sir.
Can I have the next presenter, Pushpa Dubey? Pushpa, please share your screen. And you
Very
got,
good afternoon to all.
you got 7 minutes to present, and after that 3 minutes for question answers. Thank you.
Thank you very much, sir. Just one moment for my screen share.
Sure.
Is my screen visible? Is my screen visible? Please confirm me if I am audible. Excuse me, please confirm me if I am audible.
You are audible. Please, yes, please start the presentation.
Sir, my slides are visible to you?
Yes, it is visible.
Okay, very good afternoon to the board and everyone. Here I am Pushpa Dubey, research scholar from the Department of Mathematics, AKS Satna University, to having this presentation on non-homogeneous and isotropic cosmological model with varying gravitational and cosmological constant. Also, I tried to connect this study to the theme of this international conference and try to connect it with the UN Sustainable Development Goals. This is under the guidance of Dr. Ekta Srivastav. Starting with the content of the presentation, the very first slide is about the abstract and introduction. We will, as we will move, we will see in the same sequence. Our slides will be in the same sequence. Here is the abstract, which says that we have investigated this non-homogeneous and isotropic cosmological model, especially in the context of FRT theory, and we have taken the help of being the anisotropic cosmological model. We choose Bianchi type 1 space type metric or model to pursue this investigation. The model has taken the form. There can be many forms or many formulation for the FRT, but we opted the form given by the equation 1 and 2. And then the base paper for this is the paper by Banerjee and Das in 2005, which the very first paper after the Hikaru sir on the FRT theorem, FRT gravity theory. So after the abstract, moving toward the a brief introduction of the GR theory and the FR theory, also why we need the FRT gravity theory over the general relativity. As we know that the general relativity use the Einstein-Hilbert equation, which is given by equation 3, and it's depend on the Ricci scalar only. But in FRT, which is also the which is one of the very early modified gravity theorem proposed by T. Harco. This theory depends in this theory, it depends on two factors, that is the Ricci scalar and the trace of the energy momentum tensor and the matter geometric coupling. Like why we are moving toward the modified gravity theory, or more precisely I can say why I am choosing FRT over the GR. So here is the reasons we have that in GR completely depends on R. So as we know that the number of parameters plays important role in the interpretation, while in FRT we have the two parameters as we discussed above. Also, the one of the interesting and very noticeable point that in GR the cosmological constant lambda is considered to be fixed. We tried here to investigate the effect of moving cosmological constant, the varying, that what it affects on the model and how we can how this can be interpreted in terms of in context of acceleration accelerating universe or the present universe. So from this, the one of the measure, we are moving toward the mathematical section here, and the measure, the metric we are using for this anisotropic cosmological is Bianchi type 1. For this, the line element for the Bianchi type 1 is expressed in equation 4. And the very interesting part of this, that as the coefficient A, B and C becomes equal, this models convert into this model represent the similarity with the standard GR model, or we can say the FRW universe homogeneous. Then for this model, we can say that at t is equals to 0, we get a singularity which represent the Big Bang singularity, the similar with the Big Bang theory, and we saw and we find that as the time along with the time, anisotropy decreases and the universe moves towards the isotropy. So this can be one of the things that it always in our mind, that how this changes, how this homogeneous is. Before this homogeneous, there was a phase of chaos or anisotropy. So what we get, that we start from the anisotropic universe, assuming anisotropic universe, but with the observations, with the experiments and mathematical equations, we get that we are moving toward the isotropical condition, isotropy of the universe. Now the field equation with respect to the FRT gravity is given by equation.
Pushpa, please conclude in 2 minutes.
Okay, so moving. Sir, with the gravitational, like the paper is about the varying gravitational constant and cosmological constant, the equation are here. The main thing is that, as I told, we got that the observational evidence says that in spite of the varying cosmological constant, the values is very closer to the fixed lambda, which is the which represent the GR condition. The same, the gravitational constant, the varying gravitational constant depends on the many parameter, and it's actually evolves with the time, cosmic time, and influenced by the anisotropy and the matter geometry coupling. Here we have, what is this? Here we have the solution, the major parameters which are under the solution of the field equation. They are in this tabulated form, and the result and discussion, the parameters, like whenever there is testing about the model, we just validate the model with the comparing the major parameters like the Hubble parameter, the deceleration parameter, the shear and density parameter in context to the standard LCDM model. So here is the graph, and what we are getting that the Hubble parameter decreases with the cosmic time, and it describes the expanding universe, the present scenario of the universe. Then the deceleration parameter, negative values coming from the plus to minus, it shows we are coming from the deceleration to accelerating phase of the universe. And the other result is here. The one of the important impact is, which is the according to the theme, that what this cosmological study, how it can help us to gain the SDGs. So I just tried, and I can correlate my study that during the cosmic study or any of the modified or gravitational theory, we find that they cover the SDG 13, 15, 4, 9 and 17. The measure, we can say that the ISRO, we can say the pride of the nation, ISRO is playing an important part in these SDGs and are doing a lot of things presently, which goes with SDG 13, 15, 4 and 17. Most of the, we can say, and these are the present we can say the programs launched with the on international collaboration, with international collaboration of ISRO, which is working on the Earth, we can say the the climate action and the life of land, that is the SDG 15, and the references for this whole PPT. And thank you so much for the giving me this chance to represent myself. Thank you, the board.
Thank you, Pushpa, for the enlightening presentation. Anybody in the audience got questions? Okay, I got one question.
Pushpa, what is the novelty of your work actually? Each and every one says that the universe expanding anisotropic or and isotropic models. So what is your novelty?
Sir, like the research, the present universe, most of the Hubble telescope, the data from the Hubble and Planck 2018, the most recent data, they are taking us toward the, they are actually verifying that our universe is accelerating. And but as we are continuously in actually we are in the phase of transition. This acceleration is going on, and the what is happening, that there is a we can say the factor, the most unpredictable factor, which is known as the dark energy. Dark energy is playing a very important role in this accelerating universe. So when we study the cosmological, apart from the GR, the standard cosmological model, the new discoveries, the new information will definitely lead us to the better life, the better universe, we can say, one of the better incoming planet, which can fulfill all these goals of humanity. So this is the actually core when I am interested or going through the study of cosmology, or with any of the modified gravity theorems or gravity theory.
I am asking just a simple question. What
Ji.
is the novelty of your model?
Sir, can you please hint me in more that what you are expecting from me? Like novelty mean which I just explained.
Actually, हमारे पास ऐसे सारे मॉडल हैं
जी,
और सारे मॉडल अभी ये हबल की से पहले के भी हैं। मतलब जब वाइजर था ना तो भी यही मॉडल था।
जी,
ठीक है, हबल भी गया तो भी यही मॉडल आया। मेरा ये सवाल है कि आपने कोई चीज वो रिफर्ड की है, किसी ने दे दिया, आपने उसको जस्टिफाई किया, ठीक है, तो इसको कोई रिसर्च तो कहेंगे नहीं।
Yes, sir. Since the things happened, universe जो है हो चुका है accelerate. Yes, sir.
But एक्सप्लेट हो रहा है, ये बहुत सारे रिसर्चर्स ने इसको कोट कर दिया। आपने बस इसको कहा कि हाँ ये हो रहा है, इसको जस्टिफाई किया, ठीक है। तो मेरा ये क्वेश्चन है कि आपका जो मॉडल है वो तो ऑलरेडी जो आपने एक मॉडल दिया उसमें आपकी नोवेल्टी क्या है, क्योंकि ये ऑलरेडी मॉडल अवेलेबल्स हैं प्लेटफॉर्म पे। ये जो ग्राफ्स हैं तो ऑनलाइन प्लेटफॉर्म पे भी बन जाते हैं।
बिल्कुल
बिल्कुल और ये बन जाएगा।
जी सर। Thank you so much, sir, for arising this question. Sir, the answer is here. Actually, sir, जब हम कोई भी जो मॉडल होता है वो अपने पैरामीटर्स पे डिपेंड करता है, राइट? ये जो मॉडल है इसमें स्पेशली जैसे हमने जी को डिफाइन किया है कि हर मॉडल के हिसाब से, फिलहाल इस मॉडल में मैंने जी को डिफाइन किया है, एंड हियर यू कैन सी दैट कि ये जो पैरामीटर्स है ना, जी इसके ऊपर डिपेंड कर रहा है। हर जो अब फॉर डिफरेंट वैल्यूज ऑफ दीज पैरामीटर, जो कि मैं इस छोटे से टाइम पीरियड में नहीं इंक्लूड कर पाई हूँ, डेफिनेटली द पैरामीटर्स आर गोइंग टू प्ले द इंपॉर्टेंट रोल एज द डिफरेंट वैल्यू ऑफ पैरामीटर्स विल गिव द डिफरेंट सोल्यूशन। और जो हर जो सोल्यूशन होता है ना सर, घटना घट चुकी है, लाइक द एक्सेलरेशन हैज टेकन द प्लेस, बट स्टिल वी हैव वेरी this about the universe, there is completely a prediction कि क्या हुआ होगा, क्या हो सकता है। So parameters here now are playing the very important role किसी भी मॉडल के लिए। Like in my एक मॉडल, lots of parameter are used here जो मैंने मेंशन किया है, लाइक अल्फा, बीटा, ओमेगा, एन, एम, K1 एंड K2, और ये पैरामीटर्स एक्चुअली जो है ना, इनकी वैल्यूज हमें डिफाइन करेंगी। जी, इट्स अ कंप्लीटली मैथमेटिकल वर्क नाउ।
One another question is here from you.
जी ma'am.
How we can take input from your this present cosmological model into climate change as you represent in last 4 slides? Please open this last slide.
जी मैम. Like climate change, here it is.
Yes, yes.
जी.
Please explain this.
Like the ISRO is working on many of the things, and we came across that ISRO recently launched a satellite that is the space observation. This is through the astrophysics and cosmological research, and it's helped the climate change, ocean temperature, and atmospheric condition. So the study of cosmology is not about the expanding universe. It's also about the things which is happening in our universe. As we know, the climate change is one of the major problem we are facing. Also, the navigation of Earth observation can tell many things about the climate and its changes which are currently occurring. And we have actually a very interesting fact here that not only the Chandrayaan, there is the we have mega tropicus, the Indo-French satellite mission.
पुष्पा, मेरा देखिए सवाल ये है कि
जी.
वो इसरो का मॉडल है,
जी.
ठीक है.
जी सर.
हमारा सवाल सीधा सीधा, आप इसरो के मॉडल को मत बताएं.
जी
हम
सर.
ये पूछ रहे हैं कि आपने एक मॉडल FRT मॉडल आपने प्रपोज किया.
जी सर.
ठीक है.
जी.
तो आप अपने मॉडल के बारे में बताइए, और मैं आपको जानकारी के लिए एक चीज बता दे रहा हूं कि इसरो ने जितने भी सैटेलाइट लॉन्च किए हैं उसमें कोई भी कॉस्मोलॉजिकल मॉडल की स्टडी नहीं की जाती है.
सर डायरेक्टली कॉस्मोलॉजिकल नहीं है, बट एज द थीम ऑफ दिस दैट दे are not associated directly with the cosmology, but they are, we can say, the side
But your topic, what is your topic? You work on a relativity theory and FRT model. So we want to know ki what are you doing and what is your perspective to say that. अच्छा, आप मुझे ये बताइए कि किस रेट से एक्सीलेट कर रहा है, यूनिट क्या एक्सीलेशन की?
I did sorry sir, I can't tell
How could you
exactly.
say कि एक्सीलेट कर रहा है?
सर देयर आर मेनी थिंग्स, जैसे मेरे इक्वेशन में जो है, जो हम
जस्ट आस्किंग कि आपने मैंने एक सवाल किया कि एक्सीलेट कर रहा है. अगर कोई एक्सीलेशन होगा उसका एक न्यूमेरिक वैल्यू होगा विद अ प्रॉपर यूनिट.
बिल्कुल
तो आपका मॉडल क्या बता रहा है कि एक्सीलेट कर रहा है तो कितना करेगा?
सर
आपका मॉडल क्या कर रहा है, कितना स्टैंडर्ड वैल्यू कितनी होती है एक्सीलेशन की?
सर प्रेजेंटली आई कांट टेल यू द स्टैंडर्ड वैल्यू ऑफ एक्सेलरेशन, लेकिन मेरे मॉडल में जो है, जो हमने इक्वेशन ऑफ हबल पैरामीटर दिया है, फ्रॉम द ग्राफ इट इज क्लियर कि ये डिसेलरेशन फॉर्म में हबल पैरामीटर डिसेलरेट हो रहा है. डिसेलरेशन
हबल पैरामीटर में भी आपने यूनिट लिया होगा ना?
जी सर.
तो यही तो पूछा जा रहा है कि कितना एक्सीलेट हो रहा है. बिना उसके आप कैसे कह सकती हैं कि यूनिवर्स एक्सीलेट हो रहा है?
सर डिक्रीजिंग ऑफ ग्राफिकल, अगर मैं कर्व देख करके बता रही हूँ, जैसे कि मैंने कर्व दिया है, आई एम रियली सॉरी फॉर दिस क्वेश्चन.
What is the fundamental meaning of parameter? What is the definition of parameter?
Any quantity which plays an important role is known as the parameter.
It's not a definition of parameter. Parameter means कि वो किसी पॉइंट पे फिक्स होगा और दूसरे पॉइंट पे वेरी करेगा. तो मेरा ये सवाल है कि कितना वेरी कर रहा है. हम ये इसको कोट कर रहे हैं कि एक्सीलेट हो रहा है, तो ये हमारा कोट नहीं है, ये तो आइंस्टीन ने भी कोट किया है.
जी सर, कैन आई स्टॉप द शेयरिंग एंड देन आई कैन रिप्लाई यू?
Pushpa, like I have a couple of questions. Since can you please go to the graphs?
Sir, just wait, sir. I think.
Okay, yeah. Now, since one of the parameters you are using is cosmic time, okay?
Yes, sir.
So, can you please describe me what is cosmic time?
Sir, generally, cosmic time is defined. Am I audible?
Yes, you are audible. Please.
Defined in terms of redshift and.
Redshift?
Ji. The cosmic time is generally defined. Sir, am I visible?
No, please share the screen. Okay, so it is how far back can you go in cosmic time? Do you know Planck's time?
Sir, just give me a moment.
आपको Planck time पता है?
Yes, sir. Just give me a moment, please. I am.
Planck time.
जी sir, sir, we can say that the time coordinate for measurement of cosmology or the age of universe is known as the cosmic time. Or
Okay.
we
Okay, so इसका red
consider
shift से
the,
क्या लेना देना है? You said it is dependent on red shift, but it has nothing to do with the red shift, right?
no, actually, I can say that I misinterpreted your question. That the red shift is actually comes in the scenario of the accelerating or decelerating universe. So
Yes,
more
yes.
precise, yeah, sir. And I can say that we measure this cosmic time from the Big Bang. Generally, we consider Big Bang as the to the present. Means the
Yes,
as
but
the
what is
origin.
Planck time? Can you predict the Planck time also? Can you go back even in the Planck time?
Sir, sir, no idea about this. Even I didn't got this kind of question that
Planck
I.
time क्या होता है? Simple सा question है.
mm,
अच्छा, आपने कहा कि anisotropic to isotropic universe.
जी.
So how is that possible? मतलब क्या reason हो सकता है इसके पीछे?
Sir, a lot of things is there. Like जब हम evolution of cosmology पढ़ते हैं तो हमारे पास बहुत सारे era आते हैं. अभी जैसे हम dark energy का पढ़ रहे हैं, तो it may be जैसे dark energy का है कि dark energy अभी जो है ज़्यादा that means dominating over the matter and radiation. So it may be one of the reason.
The simple reason is universe is expanding. Simple सा expand कर रहा है, उस वजह से जो है anisotropic से isotropic में जा रहे हैं. Very simple answer.
हाँ, as the time moving we are हाँ, as accelerating हम anisotropic से isotropic की तरफ जा रहे हैं.
सब Planck time आप study करिएगा. Thank you.
Okay, sir. Thank you so much, sir.
Can I have the next presenter, please? Mr. Biplab, please share your screen and start your presentation. You have
Yes, sir,
7 minutes.
May I audible?
Yes, you are audible. You have 7 minutes for the presentation and 3 minutes for the question answers. So 10 minutes total.
Thank
Please start. Thank you.
Sir, is my screen is visible? Hello, sir. Hello.
Yes, it is visible.
Thank you, sir. I am Biplab Chatterjee. Good afternoon, everyone. I am Biplab Chatterjee, a research scholar of Department Mathematics, NIT Jamshedpur, and currently I am pursuing PhD on the topic minimal linear code over rings under the guidance of Dr. Radnesh Kumar Misra. And today I am going to present the paper two-dimensional minimal linear code over the ring Z12 and Z18. And this paper was written by Sneha Gupta along with me and our guide Dr. Radnesh Kumar Misra. This is the outline of our presentation, which contains abstract introduction, a basic of linear algebra, and minimal linear code over Z18 and minimal linear code over Z12, and some references. In abstract, in this work, we explore the structure of minimal linear code over finite rings Z12 and Z18, which are not filled but have a very rich algebraic structure, which valuable in coding theory. And we study in this paper, in this work, we study the condition under which a linear code to be minimal in Z12 and Z18, and also we study we give an upper bound of a two-dimensional minimal linear code, and our construction is based on the generator matrix. Why we study minimal code? Actually, minimal linear codes have significant attention in cryptography due to their essential role in secret sharing scheme and multiplicity computation and secure communication. While earlier studies primarily focused on minimal linear code over finite field, and and extending this code to ring gives the enhanced security, flexibility, and efficiency for various cryptographic applications. And in application in 5, that is in the paper, parameter and bound, we provide a necessary and sufficient condition for a k-dimensional linear code to be minimal over the ring Zn, and by this necessary and sufficient condition, we construct minimal linear code over the ring Z p to the power n and Z p on p2, where p is prime and p on p2 are two different prime. In this work, by using this necessary sufficient condition given in 5, we construct minimal linear code over the ring Z18 and Z12, which are not like Z p to the power n and Z p on p2. To understand our work, we need to understand some basic of linear linear code. So in the first definition, what is the linear code? Actually, a code C is termed as a MKT linear code if it forms a linear subspace of FQ to the power m over the field FQ. FQ is a finite field of order Q, and the element of FQ are called the alphabet. And in reference 10, that is in the paper, one-dimensional minimal linear code over commutative ring, the author actually explore the minimal linear code of a ring. Actually, they study they change the alphabet FQ to the commutative ring R. And that's mean to study minimal linear code of a ring is basically the study of minimal linear code. Study the module of a ring. So of a ring. So a code said to be free code if it is in free module, and otherwise it's said to be non-free. Now, what is support? The support of V, let V be a vector of r to the power n, then support of V is the position set where the component of Vi is non-zero. That is, support of V is I belongs to n such that 1 less equal to I less equal to m and Vi not equal to 0, where V is V1 V2 dot Vm. What is generated matrix? Let C be a linear code, then G said to be a generated matrix of C if all the element of C are linear combination of the row of G, and no row of G can be represented as a linear combination of the other row. And definition 3, cover. What is a code A vector V said to cover another vectors V dash if support of V contains support of V dash, and we write V break V if V dash covered by V, and V break V if support of V dash is proper subset of V, then we like V dash like this. And what is minimal vector? A vector V term is minimal if V dash break V, then V dash is must be equal to AV for some non-zero constant A. Actually, if support of V contains support of V dash, then V dash must be a scalar multiplier of AB. Then we call V is minimal. And in 10, the author give this the author extend this definition to ring, and the extended definition is like that: if a code a vector a code word U in linear code C is said to be minimal if the only code word of C whose support content in support of U are precisely the scalar multiple of AU, where A belongs to R. Equivalently, U cover all of its scalar multiple AU, no other code word of C. And if all the code word of C are minimal, then we call that C is minimal. Now we define what is XY path. Now XY path is the set which are orthogonal to XY. That is, AB belongs to R square such that AX plus BY equal to 0. And the proposition 5 is say that if U into X comma Y path is basically X comma Y tar path, where U is a unit and XY belongs to R square. This proposition is help to find minimal linear code over Z18 and Z12. And here UR is denoted all the set of all units in R, and DR denoted the set of all zero divisor of R. Now we come to our main result. First, we categorize all the vector of Z18 square, Z18 square by like that. B1 is A comma U, where U is unit, and B2 is 1 comma A, where A belongs to the union of divisor of 0 and the 0 set. And B3 is A comma 1, A belongs to divisor of 0 and the union of 0. And B4 is 2, 3, 2, 9, 2, 15, 3, 2, 3, 4, 9, 2. And we take script beta is the union of B1, B2, B3 and B3 and B4. Then we see that every linearly independent vector is the unit multiplier of script beta. And any non-zero element of Z18 square is either of the form UXY or DXY. D is the divisor of 0, is unit, and XY belongs to script beta. And lemma 6 tell us that if XY belongs to beta, then UXY path is a free module of dimension 1 and is generating vector also belongs to beta. So we given some examples that 2, 3 path is generated by 3, 4 and vice versa. 2, 9 path is generated by 9, 2 and vice versa. So the next we see that 2 path, 4 path, 8 path, 10 path and 14 path and 9 path are basically generated by 9, and 3, 15 are generated by 6, and 6, 12 are generated by 3.
Please conclude.
Okay, sir. So actually, to determine this generator of DAB for all D, it's enough to consider the case where D belongs to 2, 3, 6, 9. So this lemma show that if D XY belongs to beta and DXY path is finally generated module whose generating set contains at least 2 elements, and also generated and the generator also belongs to beta. So here we give an example. The proof is very lengthy, so we omit the proof. Then we just give an example how it is happening. And these are the some notation. These notation are very important to understand the work. That C lambda is basically first we take and multi-set lambda alpha 1 alpha 2 alpha m, where alpha belongs to ZX. C lambda is basically C lambda is basically the collection of all CB, and CB is basically the like that V into alpha 1 T alpha V into alpha T all the product, and it's basically means that the multiplication of V and G lambda. V is a row matrix and G lambda is like that. So an order of V is OV is basically means the orthogonal of V. Orthogonal V, that is means the collection of all the points which are whose product with V is 0, and OV lambda is basically the intersection of lambda and order of OV, and MV lambda is the module generated by OV lambda. Now this lambda is given in the paper, parameter and bounds. This lambda given by us, and we say that this is the necessary sufficient condition for a k-dimensional linear code to be minimal over Z ring. We say that if the code C is minimal if and only if every vector V in Zn k minus 0, the relation MB lambda equal order of V lambda is this relation is holds, then we call that linear code that C lambda is a minimal linear code. So now we construct that now we take G beta where we define this where the script beta is defined here. We say that we see that if G beta like that, then G beta generate a two-dimensional minimal linear code over Z18, and and we prove this by using the lemma 6, lemma 7, and the lemma 9, the necessary sufficient condition for minimal linear code. And similarly, if we take over Z12 like this, then we can also say that C beta forms a minimal linear code over Z12.
Chatterjee, please conclude.
This is the references. Thank you, sir. Any questions, sir?
Is there any question from the audience?
Hello.
Yes, ma'am.
Can you explain the application of this model in a real world problem?
Actually, ma'am, the application is here in cryptography in secret sharing scheme and multi-party competition and secure communication. It has an application.
Any physical model can be prepared from this?
Yeah, we can prepare, but I think
How we can input from our data in cryptographic application, as you mentioned in your slide?
actually
How we can input the data from your slides? Please show that slide. This input data can be used for cryptographic application. Please show.
at that moment I have no data. This type of data I don't have, but it happened actually. It can in secret sharing scheme and in they have an application. Actually, ma'am, we are working in algebra, so our work is just analysis. Our work is to find this type of code, and this type of code are used by the cryptographic community.
Okay. You have the use over the ring Z10. So what is the application of ring in your basic part? What part of ring you can use here?
Actually, we construct code over Z p to the power n and Z p1 p2. This type of ring we construct, but in we also want to construct the code over Z p to the power n, q to the power n, or p1 q prime. So it is very hard to tackle. So so what I do actually, we take some smaller ring like Z18 and Z12, and we study over this ring the minimal linear code. Now our future plan is that we want to extend our construction to the ring Z p to the power n, Z q to the power n by this construction of Z18 and Z12.
Okay. It's okay. Thank you.
Thank you, ma'am.
Thank you, Biplab. May I have the next presenter, please?
Thank you,
Prachi Mishra.
Yes, sir.
Share your screen and start your presentation. You have 7 minutes for the presentation and 3 minutes for the question answer. So 10 minutes total. Please start. Thank you.
Okay, sir. Okay, sir. Good afternoon. My name is Prachi Mishra. Hello, I am visible.
Yes, we can listen you and we can
And
see
my
your
screen is visible.
Yes, it is visible. Please start.
Okay, sir. Thank you. My name is Prachi Misra. I am PhD scholar at AKS University, Riba. Today, I am going to present my research paper titled Generalized Star Projective Curvature Tensor of Kenmatsu Manifold. In this paper, I use Mentica and Sao, who described jet symmetric tensor in 2012. Then I generalized that symmetric tensor and gives my star generalized projective tensor. Here are some keywords of my research paper like Kenmatsu manifolds, star Ricci tensor, star jet tensor. Firstly, Kenmatsu define Kenmatsu manifold. Then I use some more others researcher like Pitis Jun. They gives many identities of Kenmatsu manifold and jet symmetric tensor. A new tensor Z defined by in equation 1.1 ZX comma Y equal S X comma Y plus psi GX comma Y, where S is Ricci tensor and Z is Z tensor, which is defined by Sao and Mentica. I generalize that equation and gives equation 1.3, which is star X comma Y equal S X comma Y plus 2n minus 1 G X comma Y plus eta X X Y eta Y. This is star generalized tensor, star generalized Ricci tensor. Then again I use this tensor and gives star generalized symmetric tensor. Pochrial described this equation 1.5. I use this projective function and gives covariant derivative and divergence of that curvature tensor. Here are some preliminaries of my research paper. If there is any MN manifold which is called Kenmatsu manifold, then these preliminaries are being satisfied. Generalized star projective curvature tensor. If any MN is manifold, star projective curvature tensor is identical to generalized star projective curvature tensor, then M tilde U X comma V X Y equal M star U V X comma V, which means these are symmetric to each other. Here, star projective curvature tensor of Kenmatsu manifold MN is skew symmetric to first and second last two pairs of variables and underchange under the interchange of these two pairs. In theorem 3.3, a generalized star projective curvature tensor of Kenmatsu manifold satisfy Bianchi identity, which is I noted in 3.14 equation. Semi-symmetric Kenmatsu manifold. Here 4.1 is described semi-symmetric Kenmatsu manifold. Kenmatsu manifold is called semi-symmetric Kenmatsu manifold if it satisfies equation 4.1. Here, if that doesn't satisfy my equation 4.1, then this is not semi-symmetric Kenmatsu manifold. Ricci semi-symmetric Kenmatsu manifold. 5.1 equation is a Ricci symmetric Kenmatsu manifold. Here gives 6.1, 6.2, 6.3 and 6.4 definition. This certify phi symmetric Kenmatsu manifold. Then if it satisfies phi symmetric Kenmatsu manifold, then it's become eta Einstein manifold. Eta Einstein manifold I define as 1.13, which is yes V comma W A G V comma W plus B eta V eta W. Here yes is Ricci tensor, G is a metric, and eta V eta W is a curvature. I use these references and work in my research paper where K. Arslan, UC Day, and K. Ano work I represent in my work. Thank you.
Thank you so much, Prachi, for the insightful presentation. Any questions from the audience? Okay, I think we have one question.
Yes, sir.
Prachi,
Yes,
one
ma'am.
question from my side. You have taken your presentation from manifold and discuss about the curvature. So, can you define the range of the curvature and which position of the curvature your model at what position? Please explain.
Sir, firstly I use M projective curvature tensor, which is 0,4 type. Then I construct this Ricky tensor and it becomes 0,2 jet tensor. Then I generalized a new Z star curvature tensor.
This value of the curvature, which type of give the effect in your paper condition, in your conclusion of part of the paper?
Yes, ma'am. My Pokharial describe M projective for only Sasakian manifold. Then I generalize my work in this my paper, and it's follow for all types Kenmatsu manifolds, Sasakian manifolds, and quasi-para Sasakian manifolds in my work.
Okay, it's okay.
Hello.
Yes, sir.
Can you tell me any physical significance of tensor?
Hello.
Any physical significance of tensor? Hello.
Yes, sir. Yes, sir. I understand your question. Yes,
Can
sir.
you tell me any physical significance of tensor theory, your tensor manifold?
Yes, sir. I have very important physical signification, like it's how force acts on different direction of a surface, like fluid Einstein manifolds.
What do you know about manifold?
Manifold is locally looks like Euclidean space, but can have more complicated global structure. Manifold like Aryan, the structure we have like Aryan, where locally looks like flat space, may be curved or complex.
Can you give an example of a manifold?
Yes, sir. Line R1, a straight line is sir. I will explain by example like R1, where a straight line
I'm
is
just
one.
asking a practical example which you see like in everyday life. Manifold. Earth surface is a manifold, right? Earth is a manifold.
Yes, sir. The surface is the
Yes,
sphere
the surface
is
looks
a
flat, but it is spherical on large scale.
Yes, sir. It's two-dimensional manifold.
So Earth is an example of a manifold. Thank you. Any other question? Okay. Thank you so much, Prachi. Now we'll
Yes.
move to the next presenter.
Okay, thank you, sir.
Yeah, Mr. Anil Shukla. You are very welcome, Prachi. Mr. Anil Shukla, are you there? Anil Shukla? Okay. Mr. Mukesh Tiwari?
I'm audible, sir?
Okay, yeah, Mr. Mukesh Tiwari.
Sir,
Yes.
Anil Shukla, sir.
Oh, Mr. Anil Shukla?
Yes, sir. I'm audible, sir?
But
I'm audible, sir?
yes, can you please tell your name?
Sir, Anil Shukla, sir.
But why your screen? Let me see. Okay. Yeah, please share the screen and start your presentation. You got 7 minutes for the presentation and 3 minutes for the question answers. Thank you.
Yes, sir. Yes, sir. Respected. Is it visible? I'm visible, sir. My screen is visible.
But why your name is name here is Mukesh Tiwari?
Sir, we are together, sir. We are
Oh,
together.
you are presenting together, both of you?
Yes, sir.
So is it like one presentation or two?
No, sir. I present and next Mukesh Tiwari.
Okay. Okay, yeah, sure. Please share your screen and start your presentation.
Yes, sir. Just
On the thumbnail, I could see one name. Okay, thank you.
Okay, sir. Just a moment, sir. Is it visible? It is visible, sir. It is visible, sir. My screen. Share. Share क्यों नहीं हो रही?
I cannot see your screen. Please share
Yeah.
your screen and start your presentation.
Yes, sir. Yes, sir.
There is an option at the bottom right here. If you are, yes.
Where option?
In the bottom.
In the bottom.
Yeah.
In the bottom.
Share screen. Okay.
Yes. And the bottom share screen. Share screen, yes, sir. Link to the internet conference.
Yeah.
Select a tab to share entire screen. शेयर का ऑप्शन नहीं आ रहा ये आ गया शेयर एंटायर स्क्रीन ना कौन शेयर दिखा रहे ये नीचे शेयर में गए
Please share the screen and start your presentation.
Sir, we are trying, sir. Just trying.
Are you on phone or on laptop?
Laptop.
On laptop, sir.
Yeah, so नीचे एक option होगा share screen का. So please.
Share, sir, entire screen or window or Chrome tab. What should we share?
Entire screen.
Entire screen. We are selecting entire screen, but share option is not active. इसकी फोटो डाल के सर को भेजो. इस फोटो डाल दो इसी ग्रुप में. Entire screen share. ये डाल फोटो. Just show. Issue presenting system preferences. Okay.
कौन नहीं लिखा है?
Minimize pin to screen. Remove this type. Show my face windows. Entire screen.
क्या बोल रहे हैं?
क्यों नहीं आ रहा? आई नहीं एंटायर स्क्रीन आई नहीं रही. इट इज नॉट कमिंग.
दादू सर कनेक्ट नहीं हो रहा सर. कनेक्ट क्यों नहीं हो रहा?
To share audio.
Anil and Mukesh, I think there is some technical difficulty.
Yes,
so
sir.
we're going to move to the next presenter and you can join later, okay?
After that. Okay, sir.
When you can share the screen, okay?
Okay,
Thank
okay.
you. Okay, so can I move to the next presenter, please? Who wants to present next? Mamta Dubey?
Yes, sir.
Yeah, Mamta Dubey. Okay, can you please? Okay.
Yes, sir. I'm sharing my presentation.
Yeah, so you got 7 minutes for the presentation and 3 minutes for the question answer. So please start your presentation.
Okay.
And Tushar Bhaskar, you are going to be the next after this. Mamta, please start your presentation.
Yes, sir. May I audible, sir?
Yes, you are audible. Please.
And my presentation is there, sir?
No, we cannot see your presentation. Please start your presentation.
My topic is generalized contour which.
Mamta, we cannot see the screen. Please share the screen.
Okay, sir. सर सेम प्रॉब्लम हो रहा है मेरे साथ में. मैंने स्क्रीन खुला हुआ लेकिन शेयर नहीं हो पा रहा है.
There is a screen share option at the bottom.
Yeah.
right here. Can you see?
Yes, sir.
Yeah, so you just have to click on that and you'll start sharing the screen.
Okay.
Yes, we can see it now. Yeah, so please start your presentation. Yeah, please maximize it. Thank you.
So today my topic is generalized controversial Jazz-Miracle type operators. These are the content, abstract, introduction, objective, auxiliary results, Voron-Voskers type theorem, conclusion, and the references. Here this abstract. In this paper, we introduce certain controversial modification of Jazz-Miracle type operators defined on the unbounded in interval 0 to infinity. We investigate their approximation properties by deriving explicit moments, estimates, and central moments inequality. Using these results, we establish pointwise convergence theorems and obtain quantitative estimates for the rate of convergence. Furthermore, our Voron-Vosker type theorem is true, and we describe the asymptotic behavior of the proposed operator. My mathematical technique happy to take you like this, and the three was now the introduction. Positive linear operators play a fundamental role in approximation theory due to their wide applicability in numerical analysis and functional approximation. Among the classical operators, the well-known Jazz-Miracle operators is defined by this equation: Snfx e to the power minus enx summation k to 0 infinity nx power k upon factorial k f of k by n, where x in the interval 0 infinity and where n is in natural number. The approximation behavior of the operator this for bounded function has been extensively investigated in the literature. Later, several generalization and modification of the Jazz-Miracle operator were introduced in order to improve their approximation properties and to enlarge the class of admissible functions. In particular, a parametric generalization was proposed in the form of this type of where P belongs to N0 is a fixed parameter. Such operators provide additional flexibility motivated by the artificial function framework. A modified version of the Jazz-Miracle operator involving hyperbolic cosine was introduced as
Mamta, can you please speak a bit louder? We cannot hear you. Yes.
Okay, sir. This cosine function is defined by this Snfx as equals to 1 upon cos hyperbolus nx summation k to 0 to infinity nx to the power 2k upon factorial 2k f of 2k by n, where x belongs to 0 to infinity, which attract attention due to its improved approximation being behavior for certain classes of functions. We see in the paper 3. In the present paper, we inspired by Controvich modification tactic, we introduce and study a new family of operators, namely the Controvich modification of hyperbolic Jazz-Miracle operator defined by this SNP fx is equals to 1 upon cos hyperbolic n plus px summation k 0 to infinity n plus px whole to the power q 2k upon factorial 2k integration 0 to 1 f of 2k plus k by n dt, where x belongs to 0 to infinity. Integrable function often gives better approximation properties. The Jazz-Miracle operators are particularly useful for the approximation of functions defined on the unbounded interval 0 to infinity. And in recent years, several Controvich, Satna, and other generalized version of Jazz-Miracle type operators have been investigated, leading to significant developments in the study of pointwise
Ms. Mamta, please conclude in 2 minutes.
Conversation. Wait, now here we introduce this new type of generalized Controvich Jazz-Miracle operators. Let CB 0 infinity denote the space of all real valued continuous and bounded function on 0 to infinity, and out with the norm this. And then in the year 2008, these Dio and at all are studied Voronska type results for Burstein type operators. Now the purpose of this study is to give Voronska type theorems for Suzer as well as Frias and Rampuska type modification of Jazz-Miracle operators. The objective of my work is the main objective is the present work study the approximation properties of the operators. In particular, we establish moment estimates and central moment inequalities, which are then applied to obtain pointwise convergence results. Moreover, Voronozka type theorems are true for the proposed operators, extending and complementing earlier results for modified Boston and Zalman-Bacon operators available. Here, the auxiliary results for the contour Zalman-Bacon operators. These are my operator modification of hyperbolic Zalman-Bacon operators, which gives moments. These moments for the value of t is 1, then as snk tx for t square for 3 t cube and t force. Next, the lemma, the inequalities hold. These are the central moments which gives in the equations these forms of the equations. Next, the auxiliary inequalities for SNKP with the contour modification of these are this is the
Mamta, can you conclude in 2 minutes, please?
Okay, sir. Okay. This is the Voronozka type theorem, sir, for order 2 functions, which gives my operator for my operator. In my operator, we use the Taylor expansion, and we applying the my operator test, and we find the value. And the conclusion is, in this paper, we introduce the controversial type modification of hyperbolic Zalman-Bacon type operator, and subsequently we obtain moments of these operators, establish auxiliary equalities, which are then applied to obtain pointwise convergence result, prove the Voronozka type theorems, and studied the rate of convergence in appropriate function spaces. And these are the references. Thank you.
Thank you,
Any
Mamta.
questions?
Thank you, Mamta, for the insightful presentation. Anybody in the audience got questions? Okay, so can you please tell me any physical application of this kind of study?
We give to growth function, sir.
Growth function?
We use this operator for growth functions. सर मैंने इसमें इंक्लूड नहीं किया है मेरे पेपर में, मैं इसको आगे करने वाली हूँ, मैं इसमें इंक्लूड अभी नहीं कर पाई, इस पे काम चल रहा है मेरा.
Okay, so it is an operator for growth function. That's what you are telling.
Yes.
Okay. Okay. Thank you so much, Mamta.
Thank you so much, sir.
Now I would like to move to Tushar Bhaskar. Mr. Tushar?
Yes, sir. Am I audible?
Yes, you are audible. Please share your screen and start your presentation.
Sure.
And you got 10 minutes, 7 minutes for the... And after...
So is my screen visible?
Yeah, your screen is visible. After Tushar, it is going to be Anil Shukla and Mukesh Tiwari. Okay,
Okay, sir. Thank you, sir. Thank you, sir.
Yeah, after Tushar Bhaskar. Please start, Tushar.
Okay, sir. So good afternoon, respected chairperson and fellow researchers. My name is Tushar Bhaskar from Karnataka University, Dharwad, and today I'm presenting my work on title Numerical Treatment of Coupled Nonlinear Boundary Value Problems. So this is the outline of my presentation, so which is abstract, introduction, analysis, method of solutions, theorems, numerical results, conclusions.
Mukesh, can you please turn off your camera? Mukesh Tiwari, can you please turn off your camera? Yes, please, Tushar. Sorry, continue.
Yes. So in the abstract, our work proposes an efficient numerical method for solving coupled nonlinear boundary value problems that arise in science and technologies. So our method combines quasi-linearization with finite difference discretization, producing a tri-diagonal system solved using the Thomas algorithms. So these numerical examples demonstrate high accuracy, fast convergence, and easy implementation of the proposed approach. So coming to the introduction section, here, since the analytical solutions are often difficult to compute, efficient numerical techniques are required. So in this work, we propose a simple and reliable that approaches combining quasi-linearization with the finite difference scheme. So the quasi-linearization technique converts the nonlinear problem into a sequence of linear problems using first-order Taylor expansion. Then these equations are discretized using the finite difference method, and they can be solved efficiently with the Thomas algorithms. So the performance of the proposed method is validated through the benchmark problems from the literature. So coming to the analysis section, So this section introduces the mathematical formulation of the nonlinear coupled boundary value problems, and we define the lower and upper solutions which are used in the analysis. So here, this theorem establishes the convergence of the Gaussian method, ensuring that the generated sequence converges monotonically to the unique solutions of the coupled boundary value problems. So here, this corollary shows that the quasi-linearization method converges quadratically, providing faster and more efficient convergence to the exact solution. So here, we can see here we apply the quasi-linearization scheme where the nonlinear system is first linearized using the first order Taylor expansion around the current approximation. So here in this lemma, we can see here the quasi-linearization process is based on first order Taylor expansion, and the derivatives are discretized using second order central finite difference approximations. So for the consistency and convergence of our discrete scheme, this result shows that the finite difference discretization used in this method is consistent and the converges to the exact solutions under the suitable conditions. Next, moving to the method of solution, here we present the numerical procedure used to solve the coupled problems, and the nonlinear system is first linearized using quasi-linearization and then discretized using finite difference method. Then the resulting block tridiagonal algebraic system is solved using the Thomas algorithm. So this is nothing but the quasi-linearization procedure. So to handle the nonlinear terms, we apply quasi-linearization technique. So then we transform the non-linear coupled into linear coupled boundary value problem at each iteration. So the process is repeated until the solution converges. So after linearization, the differential equations are discretized using a second order finite difference scheme. The interval is divided into uniform grid points and derivatives are approximated using the finite difference formulas. So what do you mean by discretization means? It converts the differential equations into a system of algebraic equation for the uniform grid points. So coming to the formation of the tridiagonal system. Here, the finite difference discretization leads to a block tridiagonal system because each equation involves only the neighboring grid points. So the unknown variables at each node form 2 cross 2 block matrices in the coefficient structure. So then this block tridiagonal system is solved using the Thomas algorithm. So coming to the Thomas algorithm, here as you can see the resulting block tridiagonal algebraic system is solved using the Thomas algorithm. This method performs first forward elimination, then followed by the backward substitution for computation. So since it significantly reduces computational cost while maintaining numerical stabilities. So this is nothing but the iterative computational procedure. So here the procedure is implemented in an iterative framework after the initial approximation. So at each iteration, the system is linearized, discretized using finite differences, and then we can solve using Thomas algorithm. So this is nothing but the error norms. The accuracy of the numerical solution is evaluated using the L infinity and L2 error norms. So the entire algorithm is implemented in MATLAB solver and tested on benchmark problems. So coming to the numerical results and discussion section, here a benchmark nonlinear coupled boundary value problem is considered with the known exact solution. As you can see here, the nonlinear term is treated using quasi-linearization, and we have obtained a linear system at each iteration. And the nonlinear term in this example is first linearized using quasi-linearization. Then, based on first order Taylor expansion is computed. The resulting linear differential equations are then discretized using the second order finite difference scheme, as you can see here. Then this discretization produces a block tridiagonal algebraic system, which is solved efficiently using the Thomas algorithm. So then the interval is divided into uniform grid points and the derivatives are approximated using second order central finite difference formulas. So after substituting this approximation into the linearized equation, then we have the converted differential system into the we will substitute that converted differential system into the discrete algebraic equations. So these equations form the Bloch tri-diagonal system, which we will solve using the Thomas algorithm. Here, after applying the finite difference approximation, the equations are multiplied by h square and rearranged into algebraic form. So the coefficient matrix defines the Thomas algorithm. As you can see here, we have performed one quasi-linear iteration on the coarse grid n is equals to 4. We can see here we have converted the differential equations into a algebraic system which has a Bloch tri-diagonal system. So these are the algebraic system. Then coming to here, after the first iteration, the discretization produces a coupled linear algebraic system for the each interior nodes. So here we can
Tushar,
see
please conclude in 2 minutes.
Yes, sir. Yes. We can see here the infinity norm of successive iteration demonstrating rapid convergence of our proposed method. As you can see, our iteration converge in just 4 minutes, 4 iterations, and the error reduced drastically. So here is the comparison table where we compare the numerical solutions and the Thomas method with the exact solutions. So the numerical values closely match the exact solution across all grid points. Here is the maximum error results. The errors obtained are very small, indicating excellent agreement with the numerical and exact solutions. So then second table tells us confirms the high accuracy of the proposed method since the error norms are very less. Here in this figure, we can show that the numerical curve closely overlaps with the exact solution throughout the computational domain, that is from 0 to 1 for u of x as well as v of x. And we can see here for absolute error distribution, here the error remains extremely small with magnitude around approximately 10 raised to minus 6. So this confirms the accuracy and stability of the proposed numerical method. And same goes for second equation. Here also the absolute error is very small across the computational domain, that is from 0 to 1. Then here we have considered another problem to propose the robustness, and we have applied the same algorithm like first linearization, finite difference, then Thomas algorithm. So here we can see the iteration converged in 5 iterations. So error is very less, and our solution is errors are very less compared to the exact solution in this table, and the error norms are also very less. So coming to the conclusion part, so we proposed a numerical scheme combining of quasi-linearization, finite difference, and Thomas algorithm. So the method produced very accurate approximations of the analytical solutions, and the convergence was achieved in only a few iterations. So overall, the proposed method provides a stable and accurate numerical framework. It efficiently solves nonlinear boundary value problems with high accuracy. Therefore, it can be considered a reliable approach for many problems in applied mathematics and scientific computing. So these are the references I referred for my presentation. Thank you for your attention.
Any questions from the audience? Any questions? Okay, Tushar, so can you please tell the accuracy of your framework, like you said, for the solution of nonlinear boundary conditions? So what's the percentage? Because you had a graph. Can you please go to the graph?
Okay, sir.
There was a graph where you compared the theoretical versus experimental values, or versus the framework values. So can you please go to that graph? So I want to see.
This one, sir?
No, it was after this. Where you did the comparison. Because there were two graphs, I saw it in a slide.
Yes, sir.
Yes,
In
yes,
here we can
yes,
see.
this one using the proposed method and the exact solution. So what's the error percentage?
Sir, here we can see the maximum error of 10 raised to minus 5, sir. And we can see the quadratic convergence, sir.
Okay, so you
Here
have,
it is clearly mentioned, sir.
so quadratic convergence, right?
Yes, sir. Yes, sir.
Okay, okay, sure. Thank you so much, Tushar. Thank you for the wonderful presentation.
Thank you, sir. Thank you, sir.
Now I would like to move to the next presenter,
Yes, sir.
Anil Shukla.
Ji, sir. Ji, sir.
Yes, please start the presentation. After this, Mukesh Tiwari.
Ji,
After
sir.
that,
Ji, sir.
okay.
I'm audible, sir? Screen show, sir?
Meeting, sharing your screen. Is it visible, sir?
It is visible, sir?
Yes, we can. I can see the screen. Please start your presentation.
Okay, sir. Okay, sir. Just a minute. Good afternoon, sir. Respected Sudha ma'am, Ekta ma'am, Ghanshyam sir, and all dignitaries. I'm Anil Shukla. Today I present my paper in shape parameter based rational spline construction for extrapolation stability. The extrapolation challenges. Polynomial spline provides smooth interpolation within data intervals but exhibit auxiliary divergence when extended beyond not domain due to unbounded polynomial growth. Rational spline overcome this limitation through denominator modulation, inbuilding effective curvature control and tensor adjustment via embedded shape parameters. I am using a literature context in front of your screen. My mathematical framework into three parts. First one is knot partition, continuity requirement, and interval length. In knot partition, define intervals with normalized variable mapping to interval 0 to 1, shown in some mathematical here for delta values in here and theta values here 0 to 1, and continuity requirement for the especially for extrapolation C0, C1 and C2. C0 ensured function continuity, C1 ensured first derivative continuity, and most important thing is C2 ensured second derivative continuity. That's why I'm using for the extrapolation rational spline. Interpolation length. Normalized parameter facilitate uniform basis function formulation. I'm using rational Hermit spline construction, sir. Here is formula for this. Ri theta equals to ni theta upon di theta. That is a rational spline. Theta belongs to 0 and 1. Here ni theta is a numerical component. Its formula is here. And di theta is denominator function. Formula is here in my research paper. Continuity analysis, I am using theorem, C1 continuity. The rational spline defined by equation in C1 continuous over the interval in front of you. C0 function continuity, first derivative continuity C1. Theorem number 2, where the rational spline remain bounded outside the node domain. Asymptotic behavior, numerator growth cubically and denominators grows quadratically. Rational spline grow linearly. Generally, sir, numerical validation result mostly used in engineering stress, exponential decay, and beam deflection. Most important thing is that here, sir, we are using for cubic polynomial as compared to spline, rational spline, sir. Most reason is in engineering stress applied in material testing, rational spline give best result as compared to cubic spline shown in figure, in latter figure. Exponential decay, this is used to approach as asymptote such as radioactive decay and inventory depletion shown in also in figure. Sir, here are figure compare between the cubic polynomial and rational polynomial. rational is more, give a good smooth curve as compared to cubic. That's why my whole work depend on the rational polynomial, and we are using some extrapolation. In interpolation, sir, we are using in interpolation in interpolation we reading a domain and reading a path between 2 points. For extrapolation, we are using a point for using in a for example forecasting and other beam deflection extension behavior. Rational spline extrapolation predict future data trends. It gives best result as compared to cubic spline shown in figure, sir. Sir, conclusion and future directions. Key advantage: extrapolation stability when bounded growth, oscillation suppression through tension control, shape parameter flexibility, improved forecast reliability, applied in CAD, stress analysis, and biomedical modeling. Sir, future research, my work, adaptive shape parameter selection based on curvature, bivariate and surface interpolation extension, integration with machine learning framework, higher order rational construction. Thank you, sir.
Thank you very much. And is there any question from the audience? Okay, so there is no question. So thank you very much to Dr. Mukesh Tiwari and Anil Shukla. So
Sure, sir.
now we request Professor Gajendra Singh to make the presentation.
Sir, Mukesh Tiwari.
Sir, can I
Mukesh
present
Tiwari.
my presentation also? I have another presentation.
Excuse me, sir. This is for Nancy.
Sorry,
presentation.
please you can wait. Yes, Anil Shukla and Mukesh Tiwari. Both of
Anil
you.
Shukla has done. Now my turn, sir. We are presenting different
Okay,
papers.
Mukesh
Anil
Tiwari,
Shukla.
so start.
Okay, okay, sir. Just a minute, sir.
Mr. Mukesh Tiwari, please.
Just a minute, sir. It will take only 5 seconds, sir. Just a minute, sir. Sir, is it visible, sir? Hello? Hello?
Yes, it is visible.
Okay, sir. Sir, very good afternoon. This is Mukesh Tiwari, the research scholar from the prestigious AKS University. And my guide's name is Dr. Ghanshyam Sen, sir. I'm doing my gratitude to you and all dignitaries members. Here I'm presenting the research paper, and the topic of the paper is cost optimization of a fuzzy MM1 Q model under environmental variability using alpha cut approach. Why fuzzy queuing theory? Real world challenge, arrival and service rate fluctuate due to environmental variability as weather, traffic, machine performance, human behavior, etc. Classical MM1 modes assume precise parameter that rarely exist in practices. Fuzzy solution represent uncertain rates as triangular fuzzy number. Alpha cut method transform fuzziness into computational interval, enabling realistic cost optimization under uncertainty. Mathematical foundation for classical MM1. MM1 means, this is Sir Kendall's notation. M means Markovian, which shows arrival pattern, and second M shows the departure pattern. In classical way, it is a Poisson and exponential, and one shows the number of server. Here we are in this research paper, I am showing that in queuing system, in our queuing system, here we have only one server. Poisson arrival, exponential service, stability condition. Stability condition means the value of traffic intensity, that is rho, which is lambda by mu, it should be less than 1. Performance measures, what we are going to measure here in expected length, that is L, which is rho over 1 minus rho, that is lambda over mu minus lambda, and waiting time, that is W, which is equal to 1 over mu minus lambda. Triangular fuzzy numbers, here we are going to change the normal parameters, lambda 1, lambda 2, lambda 3, or A1, A2, A3 in fuzzy form. Here I have taken the example as the set A, which member A1, A2, A3. Here the condition is A3 should be max from A1 and A2. A2 is most probable value, A1 is the minimum value, A3 is the highest value. The calculation of triangular fuzzy numbers and the membership values is given here. After that, when we will again change the fuzzy value in normal crisp value by using alpha cut transformation. And the formula for changing the value in crisp form to fuzzy numbers is mentioned here. Here the parameter, when I'm going to make a fuzzy phi to all variables that lambda and mu. So lambda bar is the set of lambda 1, lambda 2, lambda 3. Here I am taking 3 values of arrival, that is lambda 1, lambda 2, lambda 3. And the service is shown by mu bar, mu 1, mu 2, mu 3. And the stability condition is the highest value of lambda, that is lambda 3, should be the minimum value of mu, that is mu 1. As we can say, the supremum of lambda, that is lambda 3, should be minimum of infimum of mu. Here is the measures which I just shown you in crisp values in the basis of fuzzification. Traffic density, that is rho alpha, mean system length, that is L alpha, and mean waiting time, that is W alpha. Cost optimization framework. Our main aim is to develop a model by which we can easily minimize the cost where the cost is applying in during service period or waiting period. So here I have taken 2 modes basically to minimize the cost. The cost which is applying or is applied during the service or during the waiting period. This is the basic formula to minimize the cost, total cost. The concept which I have used, the stability, preservation, the monotonic shrinkage, and the crisp convergence. Here is one example. By this example, I just try to illustrate all things which I just have shown in my previous slide. And after this, the example in graphically form, this is the thing which is my main work. Means when we take the range in alpha cut, then it is very visible. It is very easy to visible. The values are getting to one fixed point. The value is going to a very one point, that is the values from upper side and lower side, it is getting converged to one point here. And this value is the highest value of crisp value 1. Starting from 0 means when we start, then we have the difference from 0 to 2. And when we move, alpha values move near to 1, then it converts to the one fixed value. Conclusion and the future direction. Theoretical closed form interval performance measures with rigorous existence and convergence theorem. Practice values, robust decision support framework or service capacity planning under uncertainty. Future research, multi-server system, as I just mentioned, MM1 infinite FCFS, that is MM1 means only one server I am using. The future scope here, we can also apply this thing for multi-server system. Priority queues, trapezoidal, here I am using triangularization fuzzy numbers, but trapezoidal fuzzy number can also be applicable. Thank you, sir.
Any question from the audience?
Hello.
Hello.
Yeah.
Sir, any physical significance of fuzzy set?
Sir, everywhere it is now using. In health sector, in traffic signal sector, or in service sector, where queues are there, where server are there, we can use this model.
Can you explain in traffic signal?
Yeah, sir, sure. When we design a signal pole, then right now we have the mechanical, or can we say manual condition. We when we move to signal thing, so we have one pole where 15 second are mentioned, but they are not still using this system. This system can easily be applied when we calculate the density of traffic. Density of traffic means if one side too much traffic is there, then there should be one system by using this model. The side where the traffic is too much, the signal should be changed automatically after watching or after sensing the density of arrivals. The signal should be changed in green.
Okay, sir.
It can be used, sir.
Okay.
How can be used in defense system?
Where, sir?
In defense sector.
Defense sector. Defense sector, sir, if we consider is the whole station as a MM1 infinite FS or MMS, that is multi-service station. If coming is random and queue is random and service is multi-level service, then we can use it, sir, very easily.
Okay. Thank you.
Okay. Thank you, sir. Thank you.
Thank you very much, Mr. Mukesh Tiwari.
Thank you, sir.
Now I'd like to request Professor Gajendra to start the presentation. Professor Singh, can you please start to share the screen? Professor Gajendra Singh, can you please?
International Conference of Physical Sciences that was organized by the AKS University, Faculty of Basic Sciences, and all team of IAPSC and all team of AKS University. Thank you very much. My talk is basically patented modeling for sustainable healthcare delivery system. I just attended 1 or 2 minutes the talk of previous speaker. He talked about the queuing theory. So this is the part I will use here. I will present not for all part here, but related to that topic, I will present here my talk based on the sustainability, how we can use the mathematical modeling and network-based approach in sustainable healthcare delivery system. That I will try to show here. Before that, I will explain here what is patinate and what is the how it is different from the network and what are the application in diverse area for to explain the sustainability in different area. As we know, this is the patinate, some kind of outlines you can see on the screen here, and because this is a time for artificial intelligence, for that we must know some basic understanding of the machine learning. That means how to train the machine as per our requirement and because sustainability, we are talking about here sustainability. Sustainability is something about we are not disturbing the future generation life or their goal or their dream. We are using the existing or developing the new techniques that is very easy without disturbing the environment also. Machine learning is one. If we know some mathematical idea and some computational we are putting, if we love to computationally or computation and developing algorithm, then it is the modeling and simulation can be done just using this patinate approach. Patinate also, it is also one kind of machine learning basically. So I'm not going to explain the machine learning here. So now I'm coming to the what is the patinate. Patinate is nothing. It is a basically discrete driven system where we have some kind of sets and we have the connectivity between the sets. And in fact, it is a generalization of the graph theory. Or you can say, or we can say here, it is a directed bipartite graph. That means in directed bipartite graph, we have two sets of vertices. One we can split into one subset, second we can split into the second subset, such that there is no connection within the subset. And if there is a connection, that has to be one subset to another subset. So it is a directed bipartite graph basically. And if we add one more condition, that condition called here marking condition, that I will explain here next slide in terms of the definition, that it is different from the graph theory or network-based approach. And a lot of variations are there in the patinate theory that was developed by the different kind of researchers and some kind of students also and researchers and academicians, engineers, based on their requirement, they have developed the different techniques and tools using some basic concept of the mathematical area. So this why patinate? Because we know the very complex system, it cannot be studied by our naked eyes, but we need to study or we need to take the initiative where we have to start the study of the complex system. That is why we need to study the patinate theory or patinate concept. Reason is that with the help of patinate, we can generate all possible number of states. If we have all possible number of states, then we can find the starting point where we need to start at least. So here, some other application you can see on the screen. And this is the pictorial representation of the patinate. That means it is I told here, it is a directed bipartite graph where one set is boxes here. One set is boxes with transition. Okay, transition means whenever we are doing modeling of a real life problem, whatever activity, whatever actions in the modeling, if we have, that can be denoted by the actions means transitions or boxes. And any stable things, any fixed things that can be taken as a place node or circles. And the dot, you can see in the black dot inside the circle, that is called the token or sometimes it is called marking. Marking means it represents the availability or some kind of resources on particular place node. And transition is the activity and the actions. And the arrow means arrow connect the place node to transition and transition to place, and no place we cannot connect directly place to place. That means there is no connection because it is a directed bipartite graph. We can connect the place to place node by a transition. Similarly, transition can be connected by a place node. This is the definitions. If you look at the condition number 6, that is the initial marking. It is a function from place node to the and any stand for the to the natural number including 0, that is the whole number. And condition 5 here, that means for every place there exists a transition. Similarly, for every transition there exists a place. I minus I plus with condition number 4, that is a negative and positive incident function. That means for a beginners, they can understand like this. If there is an arc from place to transition, that means circle to boxes, then we can denote by the I minus, or that is the element of the I minus. And if we have the element of the type transition to place, that will be the element of the I plus. That is the definition of the matrix form definition. I'm using the Jensen definition. So now this is some kind of illustration in terms of the marking. P1 has 3 tokens, P2 2 tokens, and P3 3. That can be expressed in terms of the n component vector. Mu0 is equal to 3, 0, 1. That means 3 P1 place can hold 3 number of persons, 3 resources at a time. P2, initially it does not have anything, it is vacant or empty. P3 is 1. So now this is very important condition, that with the help of this we will use this condition, this firing rule in the modeling is in diverse area for sustainability point of view, because for using this there is no need of the mathematical rigorous kind of mathematical background. Anyone whoever so has a background, because right now I'm working this area last 15 to 20 years, that means I'm not able to find the area where this concept not applicable. It can be used majorly based part is in social science, sciences, biology, and life science. Almost everywhere it can be used this very easily. Anyone can use. A transition, if we have the patinate, that is 5 tuples, a transition, because this is an action or activity, is said to be enabled. Enabled means some condition is satisfied. That is the condition. If you see, look at the screen, I minus PT means number of arcs from place to transition is less than equal to number of token that particular place. Mu P is number of token or number of doors in the particular place, which is the input of that transition. If this is hold, then the updated state or the new state of the system, that is called the mu dash here, it can be obtained by I minus PT means place to transition, I plus means the transition to place number of arcs. The updated state we can get here. For the illustration point of view, I have taken a very small example. Very small means we have taken the 2 places and 2 transitions. Now I want to show here the power of the patinate. We have very small networks. If we write the code and if we change the marking, and if we write the code for that particular structure or topology, then we can generate the entire possible number of states. Now, we see in the next 2 to 3 slides how the dynamic change and how we can obtain the new or next state of the system after finding of the update and annealing of the transitions. If you see here, P1 has a 1 to 2 tokens here. P1 transition can fire here, because the enabling condition is satisfied. Reason is that P1 to T1 is there is the 1 arc here, and the number of token in the input place of the transition is P1. It has 2 tokens. That means 1 less than equal to 2. That condition is satisfied. If this condition is satisfied, that means transition is enabled. If transition is enabled, any enabled transition can fire. Fire means we can generate a new state. How we can generate a new state? That is the updated state mu P. Mu P means initial token before the firing is 2. Arc from place to transition is 1. If you can see in the picture, and arc from transition to place is also 1. That means 2 minus 1 plus 1, that is equal to 2. So you can see here, without wasting your time, you can see here by using this firing sequence here, we are able to achieve all possible number of states. If you see here, after firing of T1, just immediately firing, the before state of the system is 2 and 0. After firing of T1, the state has been changed. Now it changes to 2 to 1. The state has been changed. That means 2, 0. Again T1 if it is fire, enabled, and it can fire 2. So in this way, whenever T2 also fire, you can see the screen, we are able to generate 6 states. That means if you know the very small network, or that we have here 6 states, after that no firing, deadlock occur. We can use this concept wherever some liveness is there, whenever some absence of overflow is there, whenever some deadlock occur, we can use in all those situations, because we deal with something in our real life situation as well. And if we change the marking as well, so not necessarily sometimes the states can be the exponential state. So in that situation, it is very difficult to model, but we can model with the help of patinate easily. Reason is that whenever we have exponential state, we can restrict the number of tokens. Also, we can make the infinite growth to the finite growth. There is some kind of algorithm also exists in the literature. So here question is that, suppose this is the initial state 2 and 0, this is a final state 0 and 3. Okay, so I can ask the question ourselves. We can ask the question about the reason is that, or question like this, is what are the optimal sequence of firing to get this the optimal or mathematical linear programming also, it can be converted also. So in that way we can find the solution, because although several techniques are available in the operational research, but this is another technique which is also unique. It can be used in some other way. And because reason is that whenever we have the firing rule and every condition, we can have the automatic firing the condition. So which sequence of firing we should follow so that we can disarm danger. That can save up the time, money, and manpower also. That is a way we can write the sequence mu0 mu1 like this. So now I'm going to use before that can be expressed also. That means all state can also express in terms of the reachability. That means all what is the marking of that pertinent after firing of some kind of transition. Same thing can be expressed in this way. Now I'm going to explain modeling, how we can use in the modeling. Here, that is a sequencer. Whenever we have some kind of process in the modeling, we can use this in the sequencer or series form. For example, if you look at this, these are series executions. That means E2 is the transition, can fire whenever even already occurred. Like this, that you can see the movement of the token. P1 that we had one token by firing rule that I explained also before that. You can see the movement. So that means sequential can be executed. Similarly, whenever we have the situation which is the conflict situation, that can be easily handled with the help of pertinent. Like this, you can see the movement of the token. Also, at a time we can do more than one task at a time, all tasks at a time. That even that kind of modeling in that situation we can use this concurrency concept in pertinent. Okay, in switching also, circuit design also, a lot of applications like this concurrency. Similarly, synchronization, we can use this concept in the synchronization. This is a mutual exclusive event that we can use. One more condition also, that when if we restrict the number of token, suppose k number, that pertinent is called k bounded. That means if we want to study the absence of overflow, this is a very small example. It has initially 3, 1 and 3, 0, 1 token. This is a reachability tree. We can construct the reachability tree. No, there is no token in entire dynamics. There is no overflow. That means no more than 3 tokens are in the dynamics. I will use this in modeling. For example, suppose we want to model a traffic system. This is okay. We have this is the modeling for the single traffic light. If your red light, yellow, and green, and every light color can be taken as a place node, and the start, that is the action, can be taken as the transition, and the token is at any kind of place that represent that initially the red light is going on. So whenever this start of green is there, that means transition enabled. You can see the movement of the token. That means red light means changes to the green light, similarly green to yellow in this way. Similar manner, we can model the multiple traffic lights. The same concept. Just trigger of the some kind of firing of the transitions. Summer's liveness. Suppose you want to model some live system, we can model like this. This is some interpretation while modeling. Some kind of again interpretation. Some other applications also, we can also model the chemical systems of an equation. Suppose we have 3 systems of the chemical equation. Okay, so because equations are the transition, we have taken the 3 transitions in that model, and places are the any kind of atom, and the molecules are these are the place node, and the dot inside the place represents here the availability, not the actual amount. That actual amount can also be modeled. That is some kind of variation are also there in the pertinent theory. We can use continuous, hybrid, and stochastic pertinent. So whenever carbon and oxygen combine each other, you can see the movement of the token. It moves from CO2 to CO2. Which is release the CO2, carbon dioxide gas. Okay, so that is here the synchronization. Similarly, token movement. So in this way, we can model the n number of equations also. So sometimes whenever we have a number of equations, it is not easy to study. And one way of the dynamics we can study in this way, and we can also map all kind of dynamic in terms of the reachability tree that I already shown before that. So I'm just wanted to show one more example here for the biodiversity. Suppose we want to check there whether the system is balanced or not. Suppose value of the biodiversity for the humanity. Then very simple example I have taken here. I converted in the pertinent modeling. Suppose some kind of regions, anthropogenic regions are there. We have some causes, and causes means with the plant, and plant to n number of plants, n number of legs, and some any animals are available. And suppose cause 1 is there, So you can see the token will flow, some consumed from the input place and deposited to the output place using the firing rule. Suppose like this. So then plants are here, and again provided plants can provide some kind of food. The token, you can see the movement. Our purpose is that is it possible to get all the tokens here at the last place: food, oxygen, medicine, water. Because if we have everything with us, that means our system and biodiversity system is balanced for the humanity. I have shown very small number of places here, but suppose we have some data with us, we can also model in this way. So other properties also available in the literature, or we have to work in this area at that very deep level. You can see the movement. So here I want to show here the token movements at the last. So let us see. I'm just moving ahead here. I look at see here. You can see the old token. That means initially just we had the token. You can see at the initial stage the token in this place is 5 tokens here. After firing the transition, whenever you model or execute or firing the transition in a particular sequence, you will get here all token. That means all those things are available. Available means we have stage. So for that, a lot of things we need to do. How we can achieve that? Another question: what kind of precautions or what kind of preparation we should do? What kind of policy implementation should be there for the government or other members of the country, particular country or the planet? The one kind of illustration, how it can be fitted, how it can be used in diverse area, not only one area. Similarly, we can model our logical puzzles here. Puzzles are just giving the idea, and I will show very, very quickly here. We have some kind of wolf, goat, and cabbage. There's a puzzle, very, very famous puzzle. Initially, they have at the left side, the puzzle was that we need to cross all 3 without endangering anyone. Is it that is possible or not? So in this way, this is a graphical representation initially at the left side, because we cannot leave unattended like this. If we leave goat and wolf unattended, that means wolf can eat the goat. So we never want that such situation in this puzzle. So we can model it. Just I'm showing how we can model it. So that means this is model, kind of pertinent model. If you see here, that means we are able to this situation. That means all the places, all the tokens on the right side are available. That means we can, this study reachable or achievable. That means we can say this kind of things are also solvable. That means we can use this modeling in the sustainability point. Also manpower also, because we are just playing with the numbers and some kind of arrangement and the optimal sequence of function is a very good question. And one more thing, these marking, because it can be converted in terms of the tree, can be mapped as a homomorphic image of the complete Boolean lattice. That if you allow that, I can also show some demonstration with the help of pertinent. That coding we have done in our laboratory. I will show also in very 30 seconds whenever I finish this presentation here. Data modeling, we can also use this kind of concept. We can use here. So here,
can you please conclude in 5 minutes?
Here, one more. Yes, sir. Any question? Sir?
Questions yet, sir.
Should I continue?
Yes, sir. Please conclude in 5 minutes.
Right. Okay. So now our question is that how it can be used in health sector? Why use pertinent in health? Complex due to the multiple interactive departments, limited resources we have in healthcare system, high variability in a patient demand also. In that case, pertinent can allow researchers to allow to analyze basically patient flow. What is the flow of the patient? If you're talking about the healthcare system in the medical sciences, resource utilization, waiting times also, and system bottlenecks. Suppose you want to study emergency response efficiency kya hai? So how it can be modeled, or you can say sustainable healthcare means that is designing system that can balance economic sustainability, environmental sustainability, social sustainability, and how we modeling with the help of PetNet, patient arrival, waiting room, diagnosis, suppose you are talking about or you are analyzing, treatment or discharge can be taken in the place now. And what can be the transition? Maybe the registration process, maybe the doctor consultation, maybe the medical test, maybe the treatment decision. This can be taken in the transition. And token can be taken as patient moving through the system, one point to another point. Point of view, other variation I have not discussed here. Other variation is time PetNet. We can assign the time on the transitions, then it can be simulated. And stochastic process we can also PetNet we can also use color PetNet and the fuzzy PetNet also, because if you use the variation or various types of PetNet, in that situation, what is the benefit basically of the modeling? That it can help the hospitals reduce the patient waiting time. If we model such kind of, if we use this pattern in such kind of situations, we can optimize the staff scheduling. Okay, and we can improve the resource allocations. We can predict the system overloading. Suppose, okay, we can enhance the emergency preparedness. Suppose in case of some emergency situations there, in that also we can reduce the time also. A lot of things we can do here. So for illustration point of view, I'm sharing my screen again for 30 seconds. I will show you a live demonstration with the help of some kind of software. You can see here. Let me share my screen again here. For example, entire screen. Let me show here. Please confirm me whether my screen is visible or not again. Yes. Is it? Yeah, it is visible here, I think. So let us take this is some kind of software I'm using here. Okay, that is, and we have added our coding in that software that we developed some in our lab, Massainta lab at JNU. So let me complete this one. I'm constructing some kind of PetNet model here by using our coding and this tool. A lot of tools are available in the literature. So you can see here, this is the things here. I'm just putting a dot here. Some analysis, simulation, or statistical way we can also use here. So let me run this program. So you can see the total possible number state in terms of kind of lattices or n-dimensional things here. That means the concept can be useful in the study of the crystal structure. That means we can map the all possible states in terms of lattices also or n-dimensional Boolean lattice sometimes if we restrict the marking 0 and 1 only. So let us here the very interesting thing is that if we make the very little change in the token, that is why it is very useful. Let us suppose if I'm making here only one change in the one token or maybe sometimes 3 tokens here, so you can see the change in the states, how drastically it is increased. That is not possible whenever we have the exponential growth. But in this way, because we are pointing the transition or the actions, so we can study several things here. So you can see the lot of states here. Just I am making the change in the very one or two change in the marking system. You can see, you can study the internal state of the mesh topology. This can be also useful to reduce the dimension, higher dimension, lower dimension in big data also, because every vertices we are mapping and every vertices you can see the marking here. If I point here 2, 3, 1 at that particular point, so we can also store here because it has n component vectors. N component vectors further can be taken. One component can be taken x1 to xn value, second component can take x1 to xr. That means matrix representation also. So a lot of things we can do here because time is very less. Stop sharing my PPT. If any question, please, I will be very happy to answer my queries. And thank you very much, the organizers, for giving me the opportunity to be the part of this conference, 32 conference of the IAPAC and organized by the Satna in AKS University. And thanks to Professor Shailendraji and all my fellow colleagues and my dear participants. And thanks to all entire fraternity of the IAPS. And thank you very much. If any question, I will be happy to answer the questions.
Sir, I have a question.
Yes, sir.
Sir, can we use this model for space science modulation, just like as a CME modulation?
Space science you are asking, sir?
Yeah, sir, CME modulation.
Yeah, in space science, we try to model some long back, but that model was not completed. But it can be used because DRDO is using, and in China they are using. They are also using in missile technology. It can be used because a lot of variations are there. I have whatever I presented. That is very ordinary things I presented for the beginners, but because a lot of variations are there, fuzzy pattern also there, stochastic pattern also there, continuous pattern also available in the literature, and continuous pattern also there. Lot of hierarchical pattern also available, Boolean pattern also available, cross Boolean pattern also available. Lot of variations also they have defined. Reason is that because different requirement, different time zone, and different expertise of the particular scholars, they have defined a different definition, and the nature is discrete. And it is more useful as compared to graph theory, because due to that marking condition, that marking and state, it is very difficult to study if you use only the graph theory. But here, just swirling of the successing, we can. For example, suppose you want to study some kind of minimum time or optimize the time on the money, you assign the transition. So what is a small series or scheduling also? Because that concept can be just former speaker before me, he was talking about the queuing theory. That means MM1 and MM2 model also can be changed in this way. This can be used in reliability also. Yes, it can be used in space technology. But I'm not saying what exactly you will get, but you can use it. And if you integrate some other technology or some other areas, then it will give you very good output basically. Because we use this concept in data mining also, and our student got selected last year in somewhere in company Rafe, and she's getting right now about the 30 lakh package in, and that technician was very rare. As a mathematician, she got the job, and we also published the article by using the analog operational research. It can be used.
One small question, sir.
Yes.
Can your research be used for any complex simulation?
Can you please say again?
Can this research be used for any complex simulations?
Yes, it can be used because the starting of the patinate coming from the chemical sciences basically. Whenever Colonel Petty model, when he was a 13-year-old chemical compound, it can be used in bioinformatics and the computational biology. Because we are working also, we have applied this concept in tuberculosis also. It can be used, sir. And we can also integrate, but we should have expertise in machine learning and data science, basically.
Thank you, sir. Thank you so much.
G. My apologies, sir, because I was on duty now. Today is the B certificate examination. So that's why, sir. I was in uniform, and thank you very much, Sajai. Yes.
Dr. Vinod Tyagi, can you please share the screen? Dr. Vinod Tyagi.
Sir, anything? I'm not audible, sir. Your voice.
Thank you so much, sir. Thank
Okay.
you for the wonderful presentation.
Should I leave, sir, now?
Yes, sir. Please. Yes, sir. You can.
Okay. Thank you. Thank you very much, sir.
Thank you, sir.
Thank you.
Can I have the next presenter, please, Mr. Vinod Tyagi? Mr. Vinod Tyagi? Are you there?
Vinod Tyagi, sir, are you there?
Vinod Tyagi, sir? I think he is not there.
Okay, then Shubha Parihar, please begin.
Shubha Parihar, please begin your presentation. Please share the screen, and you have 7 minutes for the presentation.
Yes, sir.
Okay. So first of all, respected honorable professors, chairpersons, distinguished keynote speakers, esteemed scientists, participants, and along with it, future research scholars. So good afternoon to all of you at this 32nd International Conference on Science and Technology, Mathematics and UNSDGs 2026, hosted by AKSU Satna. So myself, Shubha Singh Parihar, research scholar, APSU University, Riva. And my topic is to study solar wind plasma disturbances and in relation with geomagnetic storms during solar cycle 24. So let's introduce my work. So as we know that the sun earth system represents one of the most dynamic plasma environment in our solar system. So here solar activity continuously release magnetized plasma and energetic particles into the heliosphere in the form of solar wind streams and coronal mass ejections. So when these disturbances propagate through interplanetary space and interact with the Earth's magnetosphere, they can trigger significant space weather phenomena. Among which geomagnetic storms are particularly important, which leads to enhanced solar wind pressure, fluctuations in magnetic fields, and variations in plasma density, which strongly influence the magnetospheric systems, which is essential for advancing solar terrestrial interaction knowledge and space weather dynamics, which can be quantitatively measured by during DST, distance storm times, indexes and KP indices, which is mainly controlled by magnetic reconnection. Okay, so when the IMF, particularly southward component of interplanetary magnetic field, turns southwards, it becomes oppositively directed towards Earth's magnetic field. Under these to pause, allowing efficient transfer of energy and plasma from solar wind into the magnetosphere. So, as per characterized by solar cycle 24, they are characterized relatively weaker solar activity compared to previous solar cycles. So despite this, several significant coronal mass ejections driven geomagnetic storm events were recorded during solar cycle 24. So after studying these events provide valuable insights, uh, this is the interplanetary magnetic field. Uh, yes, this is our experimental data. So after studying these events provide valuable insights into how solar wind plasma disturbances influence magnetospheric dynamics under lower solar activity. So scientifically, my research topic to study solar wind plasma disturbances in relation with geomagnetic storms during solar cycle 24 is extremely important for space weather forecasting first. Then because of most of geomagnetic storms are moderate in solar cycle 24, but fewer are severe too. So severe geomagnetic storms can significantly affect modern technological systems, including satellite operations, radio and communication systems, then GPS navigation, power transmission networks, etc. So therefore, improving our understanding of solar wind magnetosphere coupling mechanisms is essential for mitigating potential risk associated with space weather events. So for this work, may I move on to data analysis? Okay. So such analysis also contributes to improving our understanding of space weather variability across different.
Please
Yes, sure. Across different solar cycles. So for this work, data of different coronal mass ejections are taken from SOHO, large angle spectrometric coronal graph, SOHO LASCO, and extreme UV imaging satellite telescope, SOHO EIT data. And to determine disturbances in geomagnetic fields and solar wind plasma parameters, hourly data of DST index and solar wind plasma have been used. And taken from OmniWeb data, the data of X-ray solar flares and other solar data, solar geophysical data report, US Department of Commerce, NOAA, a monthly issue, and solar STP data will be used. So as we conclude, sir, solar wind plasma disturbances not only play fundamental role in controlling dynamics of geomagnetic storms within Earth's magnetosphere, but also their analysis with solar wind parameters and IMF variations during solar cycle 24, which provides important reasons into the mechanism responsible for geomagnetic storms formation. And continued research very crucial for improving space weather prediction and solar terrestrial interactions in this field for future research. So once again, with this, I would like to conclude my presentation. I sincerely again thanks to AKSU Satna, their conference organizers, respected chairpersons, and distinguished international future scholars
Thank you for the insightful presentation, Shubha.
for their kind attention. I would be grateful to receive your valuable questions, comments, and suggestions. Thank you very much, sir.
Yes, we got a few questions for you from the audience.
Yes, sir.
In your slide, you shows the correlations is only only 0.13.
Yes, sir.
Then how could you say that it shows a good correlation? Pressure.
Which graph, sir?
Pressure graph.
Pressure.
Yeah, this one.
This one.
You shows now.
Yes.
And your correlation coefficient, the value of R is equal to 0.13 between these two events. Which events?
R is equals to 0.13. Okay. So which events means which date, sir?
Which events?
Which events?
The correlation shows between what? Between what?
So correlations is associated with speed of associated CMEs and geomagnetic storms magnitudes.
It should be, I think so, it should be 0.5, 0.50, above 0.50. You should have to correct your data.
For which parameter, sir? With respect to speed?
Hello. Hello.
Yes, ma'am. Yes, sir.
आपने लिखा है एक्सपेरिमेंटल डाटा, तो किस लेबोरेटरी से लिया है, लेबोरेटरी या किसी वेबसाइट से?
सर वेबसाइट हमने बताया ना सर, सबके लिए अलग अलग बताया ना.
तो एक्सपेरिमेंटल डाटा इट मींस कलेक्ट इन लाइब्रेरी अरे lab.
Yes, collecting and published already these data, sir. Published in International Journal of Current Science Research and Review, sir, and dated 3rd March 2024. Then after that, I present here, sir.
Basically, it is not a experimental data, okay? This is the website data.
Then experimentally, after taking website, I prove, na, sir?
No. Only website data.
But as I already published, sir, not issue came. Yes, sir.
आपने नोवा का यूज किया हुआ है यहाँ पर.
Here for CMEs के लिए सर सोहो लास्को यूज किया है और सोहो EIT डाटा यूज किया है और जियोमैग्नेटिक फील्ड्स के लिए हमने आवरली डाटा DST इंडेक्स लिया है और सोलर विंड प्लाज्मा को लेके एक्सपेरिमेंट किया है और ओमनी वेब डाटा को भी लिया हुआ है.
आपने मेथोडोलॉजी में लिखा हुआ है you are used NOAA.
Yes.
उससे आपने कौन सा डाटा लिया है?
सर हमने उसका सोलर फ्लेयर्स एक्सरे मतलब डाटा ऑफ एक्सरे सोलर फ्लेयर्स एंड अदर सोलर डाटास जो हैं वो हमने सोलर जियोफिजिकल डाटा रिपोर्ट यूएस से लिया है और डिपार्टमेंट ऑफ कॉमर्स एंड एनओएए मंथली इशू से लिया है.
Thank you so much, Shubha.
Thanks a lot, sir.
Yes.
Okay, Dr. Vinod Tyagi, are you there?
Dr. Vinod Tyagi.
Dr. Vinod Tyagi.
I don't think he's there, so we'll move to the next presenter.
नहीं विनोद त्यागी सर हैं.
Okay.
Dr. Vinod Tyagi.
Can you hear me? He's speaking, but not audible. Can you call him? Or message him that you are not audible.
Okay, I think there is some. सर ये नहीं सर यहाँ कुछ शो नहीं हो रहा है. अदरवाइज अगर आप जैसे ही स्क्रीन शेयर करेंगे ना यहाँ अपीयर हो जाएगा. हाँ ठीक. Suraj Gola, are you there? Suraj Gola.
Yes, sir.
Yes, sir. Please present.
I hope my screen is visible.
Yes, your screen is visible. Please start.
So, good afternoon, honorable chairpersons and all the participants present here. I am Suraj Gola from Dronacharya College of Engineering, currently pursuing my BTech in Computer Science and Engineering course. I have written this research paper on the guidance under the guidance of Vaishali ma'am, Dr. Vaishali ma'am. The topic of my research paper is AI guided smart glass coating from food waste. So basically, it is engineering a super hydrophilic self-cleaning interfaces using citrus biopolymers and using random forest regression model and evolutionary algorithms. Before we begin, let us examine two threats which we usually we have experience in our day-to-day life. One of them is fogging. We can imagine a scenario. We are driving a car. And notice in some time we have noticed that our windshield gets deposited with water droplets and fog, which is not only frustrating but also a hazardous problem which needs urgent critical attention. And the second threat is soiling of solar panel. This results in drastic reduction of power conversion efficiency by up to 50% in arid and high pollution environments. In solution to this, currently we are using the chemical which is present in our environment is based on petroleum extraction and has chemicals of PFAS chemicals, which stands for polyfluoroalkyl substances. This is a toxic chemical and is not good for environment. In the replacement of this, we can use bio-based polymers. One of them is pectin, which is the lead of our research. It is a natural polymer which can be extracted from orange peel or any citrus food waste present in the currently. Talking about the physics of clarity, the traditional chemicals which we are using acts as a creates a hydrophobic layer on the glass and reduces and increases the refractive index of the glass. This also results in increase in water contact angle to up more than 150 degrees. While using biopolymers like pectin reduces the water contact angle to less than 5%, and it creates a thin layer of it also has a hydrophilic property which results in creating a thin layer of when it gets in contact with water, it creates a thin layer of water, also acting like a protecting layer. This layer has very low refractive index, resulting in better visibility, and can be used in many use cases like solar panel and windshield. Talking about the biomaterial and breakthrough, almost half of the food waste generated by juice industries peels can be used to extract pectin. And also, pectin has a functional group like OH and COOH groups, which is present in high density and acts and actively attracts water through the hydrogen bonding, also driving a shielding effect. Also, we have discussed that it has less than 5-degree water contact angle for better visibility. Talking about extraction methodologies, there are multiple methods which we can use to extract pectin. Some of them are conventional use of conventional acid like HCl, H2SO4, or use of organic acid like citric acid, or use of ultrasound assisted extraction and water. And the most optimal pathway which is considered till date is use of microwave assisted extraction and the use of water and citric acid. This typically yields 25 to 38%, which is approximately similar to all the existing methodologies present, and has significant less time to less than 10 minutes, and very low impact on environment as it uses less amount of energy. So talking about the traditional research and development bottleneck, the traditional method requires trial and error, which also limits in scalability. Also, one factor is considered at a time, which also increases the research and development time period. Using in the solution of this can be the use of modern technologies like ML models like random forest regression, which
please jaldi khatam kariye.
Okay, sir. Random forest regression model, which requires 3 parameters: pH, temperature, and concentration of pectin and other molecules. This will result in this will predicts the thickness and transmittance and the thickness and transmittance. Another model which we can use is genetic algorithm. This acts like a brain, generating random virtual formulation and using these virtual formulations to get the predicted result, and the best predicted result gets evaluated and displayed. The better approach can be the hybrid architecture, where we use both the random forest regression model and the genetic algorithm and create a workflow of it. While traditional R&D method takes months of time to get into a result and take multiple attempts, this hybrid architecture help in reducing almost 30% of the test cases which we need to perform in the labs, by already eliminating the some of the sample results. Also, this acts as a virtual laboratory by performing virtual random random tasks, we can say. Talking about the life cycle and economic impacts, we already discussed that we are using waste product generated by juice factory. This also help in efficiently using all the resources present in our environment. Also, this material is completely biodegradable and has no impact on our environment. This also using these process produces significantly less amount of carbon footprints comparing to the synthetic PET and toxic fluorocarbons. Also, we are using the AI optimization, which help in getting the formulation and development in very less amount of time. Talking about the future and conclusion, we can integrate the Lenin nanoparticles, which helps in absorbing the solar radiation, which helps in actively evaporating moisture even in freezing conditions. We can also integrate the use of natural bioactive agents like lemon oils, which will act as a self-disinfecting and can be used in public places. This we can also integrate the use of dynamic coordinate bond using Ag+ and Ca2+, which will help in repairing the micro scratches present in the glass surfaces. Talking about the conclusion part, the research demonstrates that eco-friendly and anti-fog and self-cleaning glass coating can be developed using food waste and derived biomaterials combined with artificial intelligence techniques. Citrus food waste, which contains pectin, can be converted into functional biopolymers coating, which is capable of forming super hydrophilic surfaces. These surfaces allow water to spread as a thin film rather than forming droplets, which prevents fogging and enables natural self-cleaning effect. Thank you so much for providing me. Thank you so much for giving me this opportunity to present in an international conference. The stage is now open for the question and suggestions. Thank you so much.
Mr. Suraj Gola,
Yes, sir.
have you used any data set to model on the random forest algorithm?
No, sir. Right now, I haven't built any ML model and used any data sets. Although my research is currently now focusing is on which models which we can use and from where we can get the data sets. Like a better approach, I've already discussed the hybrid architecture where we're using the both random forest and genetic algorithm.
You showed several parameters like pH, temperature, and such things. So I can suggest you that that kind of data sets you can find it online and easily use those data set to model your this algorithm.
Yeah, these like there are publicly available data sets online, and these parameters can be considered to build a random forest regression based model.
Yeah. Okay.
Thank you so much, sir.
Thank you, Suraj, for the nice presentation. Thank you so much for the nice presentation. Suraj, can you hear me? Hello? I think. So now,
Hello, sir.
Yes, Suraj. So, have you done any simulations with your model as of now?
As of now, sir, no, I haven't did any simulation. No,
So
sir.
you are in the literature review phase right now.
Yes, sir.
Okay, so in your like presentation, in your slides, do you have the list of references?
Not in the presentation, but I have listed all the references in my research paper.
Okay, so please like include also references when you present, especially a literature review. Okay.
Okay, sir.
Okay. Thank you so much. Thank you.
I'll take as a note. As a note. Thank you so much.
Thank you. And now we'll move to the next presenter, Dr. Vinod Tyagi.
Sir, am I audible?
Yes, sir. You're audible.
सर मैं अपनी स्क्रीन को शेयर नहीं कर पा रहा हूँ, मैं ऐसे ही प्रेजेंट करता हूँ.
सर मैं आपको इंट्रोड्यूस करा दूं briefly. Dr. Vinod Kumar Tyagi is from Government PG College, Jalesa, Reta, and the topic of his today's talk is comparative photoluminescence study of nano and bulk ZnWO4 EU3 plus phosphors. Sir, over to you, please.
Okay. Thank you very much, sir. So my topic is comparative photoluminescence study of nano and bulk zinc tungstate doped by European phosphors. Now, abstract. This study investigates the size-dependent photoluminescence behavior of zinc tungstate doped by European phosphors synthesized in nano and bulk forms. The comparative analysis focuses on emission intensity, brightness, and lifetime decay characteristics. A series of structural, morphological, and spectroscopic techniques were employed to correlate the crystal structure and particle size with the optical properties. The result reveals enhanced peel efficiency and color purity and nanophosphors, making them promising candidate for solid-state lighting applications. Zinc tungsten is a versatile luminescent material known for its excellent chemical and thermal stability, making it suitable for optical and electronic applications. When doped with rare earth ions like europium, zinc tungsten exhibits intense red emissions originating from 5th energy level to 4th energy level, transition from europium, which is highly desirable for solid-state lighting and display technologies. Bulk phosphors synthesized through conventional solid-state reactions usually possess a highly crystallinity but suffer from limited control over morphology and surface defects, leading to moderate luminescent efficiency. In contrast, in nanostructural phosphors produced via hydrothermal routes, also soldier routes offer fine control over particle size, surface area, and structural uniformity, which enhances their photoluminescence properties through reduced non-radiative losses and quantum confinement effects. Thus, a comparative analysis of nano and bulk zinc tungsten doped by European phosphors provides crucial insights into the relationship between structural features and their corresponding optical performances. Experimental methodology synthesis. The bulk zinc tungsten phosphor was synthesized using the solid-state reaction method, which is a conventional or cost-effective approach widely adopted in the preparation of oxide-based luminescence. Here we used zinc oxide, tungstate oxide, and yttrium oxide, were accurately beaten and thoroughly mixed using agitator mortar and pestle to ensure homogeneity. The initial grinding process facilitates intimate contact between the reactions, which is crucial for promoting solid-state diffusions during heat treatment. The calcination temperatures is 900 degrees Celsius for 4 to 6 hours under atmospheric conditions. The nano zinc tungstate phosphorus was synthesized using the hydrothermal method, a low temperature wet chemical techniques that involves precise control over particle size, morphology, and crystallinity. This method is particularly advantageous for preparing nanostructural phosphors with enhanced surface area and improved photoluminescence properties. In this method, we take zinc nitrate and sodium tungstate and europium nitrate as the precursors. These precursor solutions were mixed under continuous stirring to ensure uniform distribution of ions. The pH of the solution was adjusted in an to incline range using the base such as sodium hydroxide and ammonia also. To prevent agglomeration and promote uniform nucleation, a surface such as polyethylene glycol was added to the reaction mixture. The resulting solution was transferred into a Teflon lined stainless steel autoclave and heated to 180 degrees Celsius for 12 hours, allowing the formation of a nanocrystal of zinc tungstate doped by uranium particles under high pressure. These are the characterization techniques. XRD purpose is phase analysis and crystalline size. FSM surface morphology and grain size. Fourier transform functional groups. UV visible band gap estimations. Photoluminescence spectroscopy, emission instance in the spectrum, and lifetime decay radioactive combination behavior. These are the XRD patterns of 2% europium doped with bulk and nanophosphorus. The figure first shows the powder XRD patterns of journey europium phosphorus synthesized in both bulk and nanophosphorus forms with different europium doping concentrations. The black pattern corresponds to the bulk phosphorus, 2% europium doped, which exhibit sharp intense diffraction peaks, indicating well-defined externality and larger crystal size. The blue pattern represents the nanophosphorus with 2% europium doping, where the peaks are completely broadened and of lower intensity, reflecting the reduced crystalline size and higher surface to volume ratio at the nanoscale. This is phase emission analysis. Field emission scanning electron microscope images of 2% europium activated zinc tungstate phosphorus in two different morphology: A, bulk phosphorus, B, nanophosphorus. The bulk phosphorus exhibiting large, irregularly shaped particles with smooth surface and an average particle size in the micrometer range. These particles show dense aggregation and faceted morphology typical of solid-state synthesized bulk materials. In contrast, figure 2b reveals the nanophosphorus composed of uniformly distributed spherical nanoparticles with average size around 100 nanometer.
Dr. Vinod, please conclude in 5 minutes.
Okay, sir.
Thank you.
This is FTR analysis. FTR expected 2% europium zinc tungsten bulk and nanophosphorus in the wave number range from 500 to 4000 wave number. Both spectra exhibit characteristic vibrational bands corresponding to zinc oxide, tungstate oxide, and europium oxide. Related modes as well as stretching vibration of hydroxyl and carbonate groups. The bulk phosphorus generally shows lower transmittance and more intense absorption features, while the nanophosphorus displays smoother curves with slightly higher transmittance, indicating better dispersion and surface effects due to reduced particle size. This is UV visible spectroscopy. Bulk and nano zinc tungsten phosphorus, which provide insight into their optical absorption behavior and bandgap characteristics. Both samples shows a steep absorption edge, indicating strong photon absorption in the ultraviolet region. However, noticeable blue shift is observed in the nano sample with its absorption edge occurring at a shorter wavelength, nearly 295 nanometer compared to the bulk sample nearly 330 nanometer. This shift signifies an increase in the optical band gap, typically attributed to the quantum confinement effect resulting from reduced particle size in the nanoscale sample. This is photoluminescent emission spectroscopy. Emission spectra of bulk and nano zinc tungsten phosphorus excited at 395 nanometer. Both samples exhibit a prominent emission peaks around 612 nanometer, which correspond to the 5D0 to 7F2 transition of europium ions characteristic of red emissions. However, the nanophosphorus displays significantly higher peel intensity than its bulk counterpart, indicating enhanced radiative recombination efficiency. This is emission spectra. Emission spectra of zinc tungsten doped with 2% europium ions. Comparing the bulk and nano samples, both spectra exhibit characteristic emission peaks of europium correspond to the electron transition from the excited state 5D0 to the ground multiplied J is equal to 1 to the 4. The most intense emission is observed at around 612 nanometer, which correspond to the hypersensitive 5D0 to 7F2 transition, indicating a strong electric dipole contribution that is sensitive to the local crystal field environment. Concluding remarks. The comparative investigation of bulk and nano zinc tungsten doped with europium phosphorus demonstrates that nanoscale modification profoundly enhances optical performances. Structural analysis confirm the monoclinic phase of zinc tungsten in both forms, with nanophosphorus showing broadened different peaks indicating the smaller crystalline size. Morphological studies reveals spherical nanoparticles with a uniform distribution, contrasting with a large irregular grains in the bulk sample. Optical characteristics shows a clear blue shift in the absorption edge and an increased band gap with the nanophosphorus attributed to quantum confinement effects. The photoluminescence spectra displays intense and red emission around 612 nanometer, with the nanophosphorus exhibiting higher pale intensity. These are the references. Thank you, sir.
Sir,
Yes, sir.
Thank you for the presentation. I have a question.
Yes, sir.
Can you please comment on the cost effectiveness of these nanocrystals and their environmental sustainability aspects?
Yes, sir. ये जो नैनो स्केल है, नैनो स्केल पे जो बनाते हैं, तो वो सोल्जर मेथड है या हाइड्रोथर्मल मेथड है, ये बहुत इजी लैब में आराम से प्रिपेयर किया जा सकता है और इसलिए कॉस्ट इफेक्टिव है।
सर, जो आप यूरोपियम से डोपिंग कर रहे हैं, तो यूरोपियम के लिए कौन सा सॉल्ट यूज करते हैं और क्या एक्सपेंसिव नहीं होगा सॉल्ट?
नहीं, यूरोपियम तो मतलब एक्सपेंसिव है, लेकिन बाकी जिंक नाइट्रेट है और सोडियम टंगस्टेट है, ये कॉस्ट इफेक्टिव नहीं है। यूरोपियम बहुत 2%, 1%, तो ये कॉस्ट इफेक्टिव ही है।
Okay, sir. So, is there any question?
Yes. Thank you, Dr. Vinod Tyagi. Thank you for the wonderful presentation. I want to know about the comparison between the light emitted by the nanoparticles and the microparticles. Like if you did any analysis on that, like nano and bulk material essentially. So, what is the difference between the spectrum of like nanoparticles and bulk particles? Thank you.
नैनो पार्टिकल सर ये मतलब प्रोसेस में है, इनकी जो लैब टेक्निक्स हैं बनाने की मेथड ऑफ प्रिपरेशन, उसमें सॉलिड स्टेट रिएक्शन में हम बल्क फॉस्फोरस यूज बनाते हैं और जो सोल्जर मेथड भी है इसका सॉलिड स्टेट रिएक्शन और हाइड्रोथर्मल मेथड है, इससे हम नैनो स्केल पे बनाते हैं।
मैं सर ये जानना चाह रहा हूँ कि आप जैसे कंपेयर कर रहे हैं ना कि इवन द टॉपिक लाइक नैनो मटेरियल एंड बल्क मटेरियल में फोटोल्यूमिनेसेंस, राइट?
जी
तो उसमें जो वो लाइट एमिट करता है, तो मतलब लाइक डिफरेंस होगा ना नैनो मटेरियल्स एंड बल्क मटेरियल्स में, तो वो क्या
हाँ,
डिफरेंस
तो ये
स्पेक्ट्रम, लाइक वेवलेंथ में, कलर में कुछ डिफरेंस है, डेंसिटी में कुछ, इंटेंसिटी में डिफरेंस है, ये मैं
इंटेंसिटी में डिफरेंस आता है, बिकॉज नैनो स्केल पे जो बहुत सारा सरफेस एरिया हमें मिल जाता है डिफ्रैक्शन के लिए, है ना, तो बहुत सारा सरफेस एरिया मिल जाता है, सरफेस एरिया लार्ज हो जाता है, और जो सरफेस डिफेक्ट्स होते हैं वो लोअर हो जाते हैं नैनो स्केल में, तो इसलिए हमें इंटेंसिटी लार्ज स्केल पे मिल जाती है।
तो इसमें लाइक हम इंटरफियरेंस की भी डेफिनेटली स्टडी कर सकते हैं, कंस्ट्रक्टिव इंटरफियरेंस, जब हमें ब्राइट लाइक इंटेंसिटी होती है तो वो कंस्ट्रक्टिव इंटरफियरेंस की वजह से होती है।
हाँ, इंटरफेरेंस डिफ्रैक्शन यूज करते हैं सर इसमें, डिफ्रैक्शन और कंस्ट्रक्टिव इंटरफियरेंस, यस कंस्ट्रक्टिव इंटरफेरेंस हो ही जाता है, तो तभी इंटेंसिटी बढ़ती है।
यस, तो कहीं पर इंटेंसिटी ज्यादा रहेगी, कहीं पर कम रहेगी, क्योंकि अगर डिफ्रैक्शन हो रहा है तो फिर कहीं पर ज्यादा इंटेंसिटी रहेगी, तो बैंड्स बनेंगे, ब्राइट बैंड और डार्क बैंड ऐसे करके।
तो ये मतलब स्पेसिफिक वेवलेंथ है जिसमें मतलब इंटेंसिटी, जैसे मैंने बताया 612 नैनोमीटर पे जो इंटेंसिटी आती है मोर आती है इन कंपैरिजन टू अदर इंटेंसिटी अंदर वेवलेंथ। एक्साइटेड जो लाइट है उस पे अगर 612 नैनोमीटर से एक्साइटेड करते हैं उस मटेरियल को, तो उसमें इंटेंसिटी ज्यादा आती है।
तो ये अराउंड येलो कलर की लाइट एमिट करता है नैनो पार्टिकल।
येलो के लिए अब उसके लिए दूसरा मटेरियल यूज होता है,
क्योंकि येलो की अराउंड 590 नैनोमीटर्स होती है वेवलेंथ।
यस 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 सर, यस।
तो येलो लाइट
ये मैं रेड, ये जो हमने यूरोपियम लिया है ये रेड के लिए है सर, रेड एमिशन।
ओके ओके, तो नैनो येलो एमिट करता है और बल्क मटेरियल वो रेड एमिट करता है।
नहीं, वो दूसरा है, जैसे यूरोपियम हम डोप करेंगे तो रेड है, जैसे टेलियन में तो ब्लू हो जाएगा।
ओके ओके,
सेलेनियम
प्योर नैनो मटेरियल लेंगे तो येलो आएगा, बट डोपिंग के बाद वो रेड आता है।
डोपिंग के बाद रेड हो जाएगा। अलग अलग डोपिंग है, जैसा एक सीरियम पार्टिकल होता है सी करके, है ना, तो उससे हम ब्लू लाइट एमिट करा दे सकते हैं। ये यूरोपियम है तो इससे रेड एमिट करते हैं।
तो
एक टेलियम है, टेलियम डोप्ड करते हैं।
काफी रिसर्च हो सकती है सर, लाइक डोपिंग मटेरियल चेंज कर करके हम पूरा स्पेक्ट्रम।
यस सर, काफी हो सकता है।
थैंक यू सर, थैंक यू सो मच।
थैंक यू वेरी मच सर।
Mr. Saurabh?
Yes, sir, I'm present.
Share the screen, start your presentation. You have 7 minutes, okay?
Yes.
Yeah, please start your presentation. Share your screen. Thank you.
Is my screen visible, sir?
Yeah, yes, it is visible. Please start.
Good afternoon, everyone. The outline of my presentation is as follow the introduction. So I proceed with the introduction. First of all, porous solid. Porous solid can be defined as a solid or collection of bodies which have sufficient open space which allow fluid to flow through them. In general, a solid can be characteristic as in the given the picture below. Means this is the solid which do not have pore space. Means this is purely solid. And in the middle part it is shown the fluid is trapped between the pore space. These are the solid grains and there is a fluid, but we can see that pores are not connected to the neighboring pores. Means this is the unconnected pore space and the cold porous solid but non-permeable. And on the right hand side, this is the connected pores. This is the porous solid which have pores connected and fluid can flow through them. So in the present study I consider the porous solid. Some natural example, wood is an example of the natural porous solid. Similarly, pumic is a volcanic rock which is also a porous solid, and these are the highly porous. Soil is another natural example of porous solid, and human bones are also example of porous solid where pores are filled with marrow. So in general, in the nature, porous solid may saturate with more than one fluid, such as the hydrocarbons where oil and gas are present with water. These solids are formed over millions of years through sediment accumulation and compaction. The pore space within these pores can hold varying amount of water and hydrocarbons depending on the factors such as rock porosity and permeability. So the study of porous solids saturated with two fluids is crucial in fields like petroleum, hydrogeology, understanding two fluid saturation is a fundamental in locating, assessing the hydrocarbons reservoirs. In the present presentation, I consider the two part. In the first part, I am studying the body waves. In the second part, I am studying the love wave, which is a surface wave. The constituent equation for a porous solid, or we can say fracture porous solid saturated with two immiscible fluids, are given in the equation 1, system of equation 1, where tau s, P1, P2, Pf are the corresponding volume average stresses in the different four phases. The equation of motion is given by the system equation 3, where rho s, rho 1, rho 2 are the volume average density, and E1, E2, E3 are the dissipation coefficients. So for body waves, we can use the Helmholtz representation of vectors in terms of scalar potential and vector potential as given in equation 4. Using this in the equation of motion, our system can get decoupled in the two subsystem, which gives the this is system by system 5, which involve the scalar potential, and the system 6, which include the vector potentials. For the plane harmonic waves traveling along a unit vector and the velocity variation, and those solutions are assumed as in equation 7. On substituting in this, we get the system 5 and 6 are now become the 8 and 9. And from equation 9, we can get the relation between psi 2, psi 1, and psi 3 and psi 1, and so on with psi 4 and psi 1. So, and the system 11s, when we expand for the non-trivial solution, this gives us equation in V8, means we get the equation as given in 11, which gives us the 8 roots, out of which 4 roots represent the phase velocity of the upgoing wave and 4 with the downgoing longitudinal waves. And the second system gives us the phase velocity for the S-share wave, means. So we arrange them as a V1, V2, V3, 4 depending upon the real part of this velocity, and the equation 12 gives us the complex velocity as this. Depending upon the real part of this, we name that P1, P2, P3, P4. In Bayer's theory, when there is no fracture, so only one fluid saturate, so though only P1 and P2 waves exist, they are termed as a fast and slow longitudinal waves. These are the formula for calculating the phase velocity and attenuation. And in the second part, we have studied the love wave propagation in this porous solid layer, which includes the fractures and the two immiscible fluids with over a homogeneous elastic upspace. The focus is on understanding the presence of multiple fluid phases influencing the wave dynamics. The appropriate boundary conditions are given, and as the upper layer there is no stress, so as z equal to minus h, stresses will be equal to 0. And in the lower interface, this is the left hand side shows the normal stress of the fracture porous layer, and right hand side of this equation 14 and 15 shows this 14 shows the stresses in the homogeneous elastic half space. On substituting the stresses and displacement in this, we get the system 16 for a non-trivial solution and the existence of the frequency equation for love wave. This determinant is expanded and equal to 0. These are the elastic parameters which are used in the computation, and a MATLAB software is used for this. In the first figure, I have shown the variation in the phase velocity with respect to the frequency of all the 5 waves in a fracture porous solid layer. It can be seen that the fast P and the S wave have a little variation in their velocity with respect to frequency as compared to the slow waves, which is P2, P3, and PF, shows a significant variation with respect to frequency. In the second figure, I have plotted the love wave velocity with wave number. It is observed that as the wave number increases, the phase velocity of the love wave decreases and then become asymptotic for the higher wave numbers. On figure 3, I have shown the effect of volume fraction of fractures permeability on the love wave phase velocity. It can be seen that as the permeability increases, the phase velocity is also increasing. On the figure 4, the effect as the fractures in the medium increases, similarly we can see that as the fracture volume fraction increases, the phase velocity of love wave increases. Based on the numerical study, the following conclusions are drawn. The phase velocity of slow dilatational wave is affected most when the increase in the in the frequency. P2 and P3 are highly attenuated and are up to larger extent. And phase velocity of love wave initially decrease with increasing wave number due to dispersive effect by the fracture porous solid and the double fluid saturations. Fracture significantly affect the phase velocity of love wave, causing it varied with fracture density and fluid flow properties. Increased permeability of pores lead to an increase in the phase velocity of love wave. Here is the expression of the appendix, and in the last there are some references. Thank you.
Is there any question from the audience? Sir, have you published this work somewhere?
Sir, actually, I haven't published the surface wave. I have published the body waves already in the Journal of Mechanics of Solid. And I'm on the surface wave. I am writing this paper and will publish it very soon.
How many articles did you refer to write this paper?
Sir, around 24 to 25 articles.
Okay.
Thank you for the presentation, Saurabh. Okay, so like in a porous solid, what impact it has? Like suppose the solid is like extremely porous. So what impact does it have on the wave velocity and the phase velocity?
Sir, if the porous is highly porous, suddenly there's a shear wave S waves velocity shows a decreasing effect because the strength of material decreases with more pores, and the shear waves have the particle displacement perpendicular to the direction of wave propagation. So S wave have opposite effect, and even if they fractures, the when P wave or fast P longitudinal wave show a decrease, but without fracture, if we consider only one fluid in the pores, then the phase velocity of P wave increases.
Also, like there will be more movement in the skeleton, if I'm correct.
Yeah,
so,
yes,
like
sir.
More
More
movement will have like impact on the phase velocity, and the phase velocity will decrease. Correct?
Yes, sir. For S wave, sure, it decreases for a large extent.
Okay, yeah, brilliant job, Saurabh, and I'm really impressed by your presentation. Thank you so much.
Thank you, sir.
Yeah, so now we move to the next presenter. Vatsala, can you?
Yes, sir.
Okay. So please share your screen and start your presentation. Okay, you have 7 minutes for the presentation and 3 minutes for the question answer. So over to you.
Okay. Good afternoon, all. I'm Vatsala, research scholar working under the guidance of Professor S.C. Shiral Shetty, Department of Mathematics, Karnataka University, Dharwad. Today, I'm going to present my research article, Legendary Wavelet Operational Matrix Solution of Carron Nanofluid-Based Squeeze Film Lubrication with Couple Stress Effect. This is the content: introduction, mathematical formulation, legendary wavelet properties and method, results and discussion, conclusion, and reference. Introduction. In tribological system, ferrofluids offer improved reliability of operations because of their magnetic field control, viscosity, and retention capacity. The presence of magnetic field raises the viscosity, enables the better control of film thickness, leading to improved load carrying capacity and lower mechanical degradation. However, the greater number of these were considered ferrofluids as a Newtonian fluids. This simplification took crude, especially in the case of thin films, where velocity gradients are large. Contemporary lubrication problems often include the additives, microstructure components that leads to the non-classical flow phenomena. Microcontainer models were thus proposed to incorporate the effect of internal rotation and size scale rotation. The major contribution of present study are briefly summarized below. Implementation of shear-dependent chirological in ferrohydrodynamic coupled stress lubrication model, I refer 2014 Mistress paper, formulation of legendary wavelet operational approach of solving nonlinear Reynolds equation, incorporating magnetic and microstructural effect. I refer 2025 Shiraj paper, derivation of theoretical results on the inherent nilpotent block structures and legendary wavelet integration matrix shows the operator preserves the exactness for assembled polynomial classes. This helps to understand the algebraic behavior of the operational formulation. I referred Yusuf Sir and Shiraj Sir papers, comprehensive examination of the joint effect and magnetic parameter, volume fraction, shear dependent viscosity, and couple stress parameter, pressure distribution, load carrying capacity, and approaching time. I refer 2013 Lin paper through the integration of realistic rheological model and higher order spectral numerical approach. The current study offers the powerful and flexible framework for the analysis of advanced smart lubrication system. The approach can be readily extendable to hybrid nanofluids, temperature-dependent viscosity model, and transient model, opening up the new avenues for advanced tribological advance. This is the mathematical formulation. Here, the geometry of the circular squeeze film with the modified non-Newtonian ferrofluid lubrication geometry. Here, equation 12 represents the Caro model, and I implemented to the original paper Einstein formula they have used. So I implemented this Caro model to that original paper, and I formulated this 12.2 equation. This is the boundary condition that remains the same. Then equation 18 is the Reynolds equation. Equation 20 is the non-dimensional parameter. We use non-dimensional parameter to equation 18 to do non-dimensional Reynolds equation, that is equation 21. And this is equation 23 is a non-dimensional load carrying capacity parameter, and equation 24 is the non-dimensional load carrying capacity. Similarly, equation 25 is the non-dimensional parameter, and equation 27 is the non-dimensional squeeze film time. This here is the main part comes. Properties of legendary wavelet. Legendary polynomial is defined in equation 28, and in general representation is equation 29. And legendary wavelet definition, which can be represented as equation 30. I refer Shiraj Shetty Sir paper, 2025 paper. And these are the legendary wavelet basis using the operation matrix of integration method. And we can represent like this. Equation 34, 35, 36, or we can represent those operation matrix of integration, one time integration, second time integration, third time integration, up to so on, nth time integration. We will get 34, 35, 36, and to continue so on. I have justified this method using the test problem, which has no exact solution. So I have used MATLAB to calculate ADM method and Rangekuta method. See, here I have solved one problem. I have compared with the legendary wavelet operation matrix of integration and the finite difference method, Rangekuta method, and ADM solutions. I have used a Sirajullah paper to compare this solution. This is legendary wavelet solution I have obtained, which is reliably related to equivalent to Rangekuta solution. And here comes the main results of my paper, results and discussion. The nonlinear Reynolds equation obtained from the ferrohydrodynamic couple stress formulation was solved using legendary wavelet operation matrix method. After incorporating Kerouac's shear dependent viscosity model, the results are compared with classical Einstein viscosity formulation to determine the effect of rheological generalization on lubrication performance. Here it can easily shows, figure 2 easily shows that the comparison of Einstein and Kerouac viscosity. The Kerouac model gives higher value of maximum pressure for all the values of volume fraction and magnetic parameter. Enhancement up to 8% increases with both volume fraction and magnetic parameter. Table 2 represents how the Einstein maximum pressure of the Einstein model and maximum pressure of the Kerouac nano model. And here figure 3 represents the same thing. Here load carrying capacity for film thickness, I mean H is equal to 0.4, and another one here for H is equal to 0.4, the load carrying capacity for both Newtonian case and coupled Einstein and coupled Kerouac. Here for Newtonian Einstein to Kerouac, we can see easily differences of 9.87% of improvement. Same load carrying capacity for couple Einstein and couple Kerouac. Here I can see 8.3 to 8.4% of enhancement. These are the figures. Same year,
for different values of magnetic parameter, the film thickness of H is equal to 0.4 and H is equal to 0.6. Same thing, I mean load carrying capacity for Einstein and Kero model, improvement of 4.24 for different values of H. Next goes to load carrying, time approaching time. When the film thickness increases, the time approaching time decreases here by using this Kero nano particle. We can see by using this Einstein model compared with Kero model, the improvement is minus. I mean, for Einstein model, it requires more time, approaching time, film thickness approaching time is more. For Kero model, which I have used, is minus 6.22.
Excuse me, Vatsala. Excuse me, Vatsala. Please conclude in 2 minutes.
Okay, sir. Okay. Minus 6.2, sorry, minus 5.71 to 6.22, which is very efficient model to use. My conclusion point is the new accept of the current study is used for legendary valued approximatics of integration to solve the nonlinear lubrication equation. Then this is a new spectral wavelet approach, reduces the differential equation into system of equation, which converges most faster, which with improved reliability and reduced computational compared to standard methods. The rate of convergence is also high. We can use any nonlinear one dimensional, two dimensional, any nonlinear Reynolds equation we can solve using this method. These are the references I have referred. Thank you.
Thank you, Vatsala, for the insightful presentation. Any questions from the audience? Okay, so Vatsala, since like you work on non-Newtonian fluids.
Yes, sir.
So have you considered any boundary conditions in your study?
Yes, sir, I have considered.
Can you please briefly tell me what are those?
1 minute, sir. Equation 13, 14, 15 are the boundary conditions I have considered. Actually, I didn't showed all the equations. So equation 13, 14, 15, the basic equations I have considered momentum equation and mass of conservation, all. These are the boundary conditions. 13, 14, 15 are the boundary conditions.
Oh, did you mention just mass of conservation of mass?
Sir, I have not mentioned in this. Sir.
So mass is a boundary condition?
Sir?
Mass is a boundary condition for you?
No, sir. Only viscosity component is the boundary condition here.
Okay, because you mentioned conservation of mass. So only viscosity. So viscosity is the boundary condition, right?
Yes, sir. Only the basic equation I have referred on, that is conservation of mass.
What do you intend to prove by conservation of mass?
Conservation of mass, like actually I don't know properly, sir, but we use for basic like Newtonian fluids, but actually we use only viscosity dependent, velocity dependent equations.
Velocity or viscosity?
So viscosity, sir. And velocity also. Viscosity is for formulation, nanofluid. Here boundary condition totally depends on velocity components, sir.
Like what is like the basic difference between Newtonian and non-Newtonian fluids?
Newtonian fluids obeys Newton's law, sir, which means shear stress is directly proportional to strain. Those fluids which doesn't obey the Newton's law, those are called non-Newtonian fluids.
I think Newtonian fluids are those like which have like fixed velocity throughout the fluid.
Yes, sir. We can justify with that definition also, which has
changes over the like on different points in the fluid. That's what essentially the definition and the difference between Newtonian and non-Newtonian fluids is.
Okay, sir.
Okay. Thank you so much, Vatsala. Thank you for the wonderful presentation.
Thank you, sir. Thank you for the opportunity, sir. Thank you.
Can I have the next presenter, please? Pratima Dubey. Am I audible?
Yes, I am present, sir.
Yes. So please share your screen and start your presentation. You have 7 minutes.
Yes, sir.
Thank you.
Yes, sir. Present. 1 minute, sir. Slide is visible, sir. Hello?
Yes, we can see the slide.
Slide is visible, sir.
Yes.
1 minute, sir. Good evening, all of you. My research article topic Itariki Ambeshalitan Larenzian Beta Kenmatsu manifold admitting Southern band campaign connection. Abstract. The present work investigate Itariki Ambeshalitan on Larenzian Beta Kenmatsu manifold endowed with Southern band campaign connection. We first formulate the geometric framework of the Southern band campaign connection adapted to Larenzian Beta Kenmatsu structure and derive fundamental structure in relation. Within this setting, we establish necessary conditions under which Itariki Ambeshalitan exist and analyze their geometric consequence. Further, we examine curvature characteristics associated with this soliton and obtain classification result under appropriate geometric constraints. The interplay between short and band campaign connection and the intrinsic structure of Lorentzian beta Kenmatsu manifold is studied in detail. In addition, we extend our analysis to submanifold and compare the behavior of Itariki Ambeshalitan with respect to the Lewis beta connection and Southern band campaign connection. Introduction. Lorentzian manifold is a smooth differential manifold equipped with a Lorentzian metric tensor. This metric is symmetric 0 to tensor similar in form the Riemannian metric, but it differ in the sense that it is not positively defined. Such manifolds are of fundamental importance in the mathematical formulation of general relativity, where they are used in represent the geometric structure of spacetime. The well-known Minkowski space is the simplest and most classical example illustrating a Lorentzian manifold. In 1901, the concept of alpha-Sakian and beta-Kenmatsu manifold was initiated by the study of Lorentzian manifold together with the different geometric structure has attracted significant interest among researchers in this direction. Matsumoto introduced the concept of Lorentzian beta-Kenmatsu manifold in 1989. Subsequently, Miyai and Tesaka investigate this structure independently and obtained several important results concerning its geometric properties. Lorentzian beta-Kenmatsu manifold form a distinct class of manifold that combines features of Lorentzian geometry with Kenmatsu type structure. These manifold possesses both a temporal structure determined by the Lorentzian metric and a beta-Kenmatsu structure that can be interplayed as a generalized conformal framework. In fact, the Lorentzian beta-Kenmatsu structure may be regarded as a scaled extension of classical Kenmatsu structure. It is also known that trans-Sakian manifold of type 0, 0, 0 beta and alpha 0 correspond to cosymplectic beta Kenmatsu and alpha Sakian respectively. Furthermore, when a trans-Sakian structure of alpha beta has non-vanishing constant, it reduced to beta Kenmatsu manifold, and in the particular case beta is equals to 1, the structure becomes the standard Kenmatsu manifold. In recent years, Itariki Ambeshalitan have emerged as an important topic in differential geometry. This soliton can be viewed as a generalized geometric structure related to Einstein manifold and arise from a combined of Ricci and Yang flows. They provide useful tool for analyzing the evolution of geometric structure and have application in both geometric analysis and mathematical physics when we consider Lorentzian manifolds. Itariki Ambeshalitan offer a suitable framework for investigating the dynamical and symmetry property of spacetime model. Since they represent stationary solution associated with Ricci and Yang flow, they play a significant role in understanding the long-term behavior of these geometric flows. Moreover, such soliton contribute to classification of manifold and help in studying structural change within geometric model. In recent years, Itariki Ambeshalitan have emerged as an important topic in differential geometry. This soliton can be viewed as generalized geometric structure related to Einstein manifold and arise from a combination Ricci and Yambe flow provide useful tool for analyzing the evaluation of geometric structure and have application both geometric and analysis with the mathematical physics. When we consider Lorentzian manifold, Eta Ricci Yambe Chalitan offer a suitable framework for investigation the dynamical and symmetric properties of a space-time model. Since they represent a stationary solution of associated with Ricci and Yambe flow, they play a significant role in understanding the long-term behavior of these symmetric flows. Moreover, such soliton contribute the classifications of manifold and help in studying structure change within geometric model. In recent years, geometric evaluation equations have become important topic investigation in differential geometry. The Ricci-Yambe this transformation can be interpreted as a scalar linear combination of the Ricci and Yambe flows. The Ricci-Yambe soliton is referred to as proper whenever A is not equals to 0, A is not equals to 1. Let us Ricci and IQ introduced the concept of Eta Ricci-Yambe soliton in 2020. Eta Ricci-Yambe soliton and MC is defined by the data.
Excuse me, Pratima.
Yes, sir.
Please conclude
Yes,
in
sir.
2 minutes.
Yes. These are Lorentzian beta Kenmatsu manifold structures. These are equations of beta Kenmatsu, Lorentzian beta Kenmatsu manifold, and Southern band compound connection. The Southern band compound connection delta star affiliated to the Lewis beta connection by these equations. We can find there some results. The theorems: if Lorentzian beta Kenmatsu manifold am equipped with Southern band compound connection, then the curvature quantity are characterized by these equations, and Ricci tensor characterized by this equation 15, and the scalar curvature are subsequently obtained from the associated contraction relation between M is satisfy the first Bianchi identity given by the equation 16, and Eta Ricci Yambe soliton on Lorentzian beta Kenmatsu manifold admitting Southern band compound connection defined by equation 17. The Southern band compound connection on Lorentzian beta Kenmatsu manifold equipped with Eta Ricci Yambe soliton is invariant if and only if it is satisfy equation 18. And an Eta Ricci Yambe soliton on Lorentzian beta Kenmatsu manifold M admitting Southern band compound connection is Einstein manifold. Next result, an Eta Ricci Yambe soliton on Lorentzian beta Kenmatsu manifold with Southern band compound connection is always shrinking. Curvature property on Lorentzian beta Kenmatsu manifold admitting Southern band compound connection. Concircular curvature with respect to Southern band compound connection is defined by the equation 19. And we obtain the results: a concircular curvature on Lorentzian beta Kenmatsu manifold admit Eta Ricci Yambe soliton equipped with Southern band compound connection is given by equation 20. Next, we define the projective curvature equipped with Southern band compound connection is defined by equation 21. And we obtain the result of projective curvature on Lorentzian beta Kenmatsu manifold with respect to Southern band compound connection admit Eta Ricci Yambe soliton is given by equation 22. And Eta Ricci Yambe soliton on submanifold of Lorentzian beta Kenmatsu manifold admitting Lewis beta connection, we obtain the results in invariant submanifold M of Lorentzian beta Kenmatsu manifold admit Eta Ricci Yambe soliton, then M is Eta Einstein manifold, always shrinking. And the next, we Eta Ricci Yambe soliton on submanifold of Lorentzian beta Kenmatsu manifold admitting Southern band compound connection. We obtain the result. Let M be an invariant submanifold of Lorentzian beta Kenmatsu manifold. M endowed with Lewis beta connection and Southern band compound connection respectively. We induce Lewis beta connection and Southern band compound connection. Then we have M admit Southern band compound connection. The second fundamental from are same Southern band and Lewis beta connections. Eta Ricci Yambe soliton on submanifolds of Lorentzian beta Kenmatsu manifold admitting Southern band compound connection. We get a result if M be submanifold of M Southern band compound connection delta star, then the curvature tensor R star is given by the equation 23, and the Ricci tensor is represented by the equation 24, and the scalar curvature tensor is given by the equation 25. Eta Ricci-Ambe soliton and submanifold of Lorentzian beta Kenmatsu manifold admitting South and Van Campen connection. Define let Eta Ricci-Ambe soliton an invariant submanifold with South and Van Campen connection, which is defined by equation 26. And we obtain the results on invariant submanifold of M bar of Lorentzian beta Kenmatsu manifold. M equipped with South and Van Campen connection admit Eta Ricci-Ambe soliton, then M is Eta Einstein soliton and always shrinking. Conclusion and remarks. In the present work, we have studied Lorentzian beta Kenmatsu manifold with respect to South and Van Campen connection. In presence of Eta Ricci-Ambe soliton, the main objective of these investigate to understand the geometric behavior of the of these investigation is to understand the geometric behavior of the soliton structure and to analyze how the South and Van Campen connection influence the curvature and Ricci properties of Lorentzian beta Kenmatsu manifold. In this framework, the necessary conditions related to the existence of an Eta Ricci-Ambe soliton have been established. It is observed that the presence of such a soliton structure imposes significant restrictions on the geometric properties of the manifold, in particular the curvature relation obtained under the South and Van Campen connection are closely associated with the Ricci tensor and the scalar curvature of manifold. Furthermore, the obtained result indicate that a Lorentzian beta Kenmatsu manifold admitting an Eta Ricci-Ambe soliton may be exhibit the behavior of an Einstein type manifold under certain geometric condition. Moreover, the nature of the soliton shrinking. The South and Van Campen connection provide a useful framework for examining the geometric structure of Lorentzian beta Kenmatsu manifold. Finally, the result obtained in this work naturally lead to the several possible direction for future research. It would be interesting to investigate whether similar result hold for other type of connections on Lorentzian beta Kenmatsu manifold. Moreover, the study of Eta Ricci-Ambe soliton can be extended to other classes of contact metric manifold. Another possible direction is to analyze whether the obtained result remain valid for invariant or in an anti-invariant submanifold of Lorentzian beta Kenmatsu manifold. In addition, the investigation of conformal, concircular or projective curvature structure in presence of Eta Ricci-Ambe soliton may provide further insight into the geometry of these manifold. There are some references in our research articles. These are some references. Thank you, sir.
Okay, is there any question from the audience?
Yes, sir. Yes, sir.
Yeah. Thank you for the wonderful presentation, Pratima. I had like a question like what practical application can be done with this kind of research?
Sir, application.
Application, yes.
Hello, sir. Application they are used to represent the geometric structure of space-time. The well-known Minkowski space is the simplest and most classical example, illustrating on Lorentzian manifold. And Lorentzian geometry plays a crucial role in describing the interaction between the geometry of space-time and distribution of the mass energy within the framework. And sir, we find geometry of solitonic structure in this article.
What you are saying is that this can help us in our understanding the nature of space-time.
Yes, sir.
So this can help us to understand the nature of space-time.
The nature of space-time is
because you said space-time is a manifold, right? That's what you are claiming.
Yes, sir, space-time is 4 dimensions, and we manifold. My manifold Lorentzian beta Kenmatsu manifold is a smooth pseudo-Riemannian manifold. Is equipped with a metric.
So
symmetric and non-degenerate and 4 dimension.
Okay, thank you, Pratima. Thank you so much. Any other questions? Okay.
No.
Thank you. Can I have the next presenter, please?
Okay, Sushma Munchiramani.
Yes, sir.
Yes, please join. Please share your
You have 7 minutes, okay? Please start the presentation and share the screen.
Yes, sir. Good afternoon, everyone. I am Sushma, research scholar pursuing PhD under the guidance of Professor Vedmurthy AB. Today I am going to present my work, Evaluation of Bioactive Secondary Metabolites Isolated from Endophytic Fungi for Targeted Biomedical Interventions. These are the contents.
Please close the side screen, the other screen. The mobile screen, please. Thank you.
Introduction. Endophytes are bacterial or fungal microorganisms that reside in healthy plant tissue and form symbiotic relationship with host plants. They may be inhibit either intercellularly or intracellularly, spending whole or small part of their life cycle in the plant body. Atlantia racemosa is a plant belonging to the Rutiaceae family, is also known as Cattunargum huchnimbe. The decoction of Atlantia racemosa leaves is used to treat bronchitis, asthma, cough, and blood purifier. Methodology. Collection of plant material. The healthy plant leaves were collected in the month of March from Jamboti, Kanapur Taluk, Belgaum district, Karnataka. The leaves were processed in a laboratory within 24 hours of sampling to ensure disease symptoms. Isolation and identification. The isolation of fungi was performed by modified method by Sklues and Boyle in 2005. Fungi were subcultured on a PDA medium under specific conditions, and identification of the endophytes was done on their phenotypic characters like growth pattern, hyphae, texture, colonial characterization, and microscopic observation. Estimation of total flavonoid content. The total flavonoid content was determined by using colorimeter. The absorbance was taken at 450 nanometer. Using standard calibration curve. The results were expressed as quercetin equivalent mg per 100 ml of sample. GCMS. The fungal extract was dissolved in methanol and subjected to GCMS to determine its phytochemical constituents. It combines the feature of both gas chromatography as well as mass spectroscopy. Antioxidant activity. The TPPH test is conducted using the method described by Brand Williams et al. 1995. The ethanol fungal extract was also checked for its antioxidant activity using DPPH assay. Anti-cancer activity. The cytotoxicity assay was performed using an MTT assay and checked for its IC50 value was calculated. Result. Isolation of endophytic fungi. The leaves were collected and surface sterilized with sodium hypochlorite, ethanol, and water. After surface sterilization, the leaves were placed on a PDA plate. After 7 days of incubation, the mycelium starts growing. After mycelium growing, each fungal colonies was subcultured and maintained for pure cultures. These are the microscopic view of endophytic fungi and solvent extraction. Total flavonoid content. Ethanol extract of the fungal culture was subjected to comprehensive phytochemical screening, revealing the presence of flavonoids with a total flavonoid content of Aspergillus flavus 23.32%, Pleosporil species 35.32%, and Endothea species 31.72%. GCMS. Gas chromatography mass spectroscopy analysis of ethanolic fungal extract identified 30 phytocompounds. The major compounds were erbiteron and ergosterol in Aspergillus flavus, hexodeconic acid ethyl ester and oxodeconic acid and ethyl ester in Pleosporil species, and sorbitol and carbomic acid derivatives in Endothea species. Antioxidant activity. The 3 fungal extracts showed moderate antioxidant activity in the DPPH assay with a percentage inhibition values of 58.1% for Aspergillus flavus, 50.66% for Pleosporil species, and 42.23% for Endothea species, which were lower compared to the standard ascorbic acid that showed 81.59% inhibition. In vitro cytotoxicity activity. The fungal extract was subjected to anti-cancer activity against the skin cancer cell line using cisplatin as standard drug for comparison. The percentage viability of the Aspergillus flavus was observed to be 36.93 and Pleosporil was observed to be 20.38 and Endothea species was observed to be 31.30. The standard drug cisplatin at given concentration 50 mg per ml showed a significant effect on the cancer cell line with a lower percentage of cell viability as 8.67. Conclusion. The study demonstrated that endophytic fungi is isolated from Atlantia racemosa are a valuable source for bioactive secondary metabolites with a potential biomedical application as confirmed by GCMS analysis that identified compounds such as fatty acids, phenolics, terpenoids, flavonoids, and hydrocarbons known for their antimicrobial and antioxidant properties. These are the references. Thank you, sir.
Thank you very much for the wonderful presentation. So, on which cell line did you try that anti-cancer activity?
Cancer cell line, sir, A375.
8375. And what was the, what is the basic novelty of this work? Is this fungi has been tested for the first time for anti-cancer activity?
No, sir.
Okay, so how about that antimicrobial activity? On which microbe did you test that?
Aspergillus, S. aureus and bacilli, sir.
Okay, okay. Thank you very much, Sushma. That was a very informative presenter. So if there is a, okay, so there is no more questions from the audience. So we'll go on to the next participant, Mr. Prabhat Singh.
Thank you, sir.
Good evening, sir.
Good afternoon, Prabhat Singh. Please share your.
Okay, sir. So, is my screen visible?
Yes, we can see the screen.
I'm Prabhat Singh, and I will be presenting my paper, Effective Field Theory of Plasmas in Podolsky Corrected Photonic Field. Now, this paper develops a first principle quantum field theoretic framework for plasmas interacting with quantized electromagnetic field. And we have used Podolsky modified electromagnetic theory. That is, we have not used traditional Maxwellian theory. And in this theory, we higher order derivative terms for the field are accommodated to account for higher order effects that are normally not, and it also corrects few other mistakes that were in Maxwellian theory, or maybe we can just say that it is an approximation. Maxwellian theory is an approximation, and it is a more exact theory that we are using. We will discuss that later in the discussion. And the study constructs an effective plasma Hamiltonian by integrating out photonic degrees of freedom, and shows how higher derivative electromagnetic corrections modify plasma dynamics, collective modes, and photon plasma coupling. So the basic motivation for this study is that plasma formulates about 90% of our universe, visible universe, but and it has been studied since its inception by in 1920s or 1900s, early 1900s. Many models have been developed: hydrodynamic plasma models, that is fluid approaches, kinetic plasma models, standard perturbative QED models. But you see, hydrodynamic plasma models are computationally effective, but they fail at high energy density or strong field regimes, because it has been discussed in a paper by Michael Bonitz in 2019, co-authors quantum hydrodynamics. And kinetic plasma models are very accurate, but they are computationally very expensive. Means they take a lot of time and a lot of energy is spent if we want to simulate anything related to that. And standard perturbative QED requires, because no model has been properly developed in that regime, so it requires weak coupling, slow field variation, low field strength approximations, and these approximations can lead to unphysical predictions. It has also been summarized in Michael Bonnett's 2019 paper and 2018 paper as well. It has been discussed in detail. So main objective of our paper is to model plasma in such a manner that it introduces higher order electromagnetic corrections through Podolsky theory, quantize the electromagnetic field interacting with plasma, integrate out photonic degrees of freedom, derive effective Hamiltonian describing plasma-plasma interaction mediated by photons, identifying new collective plasma behavior, if any, and propagation modes. And so we describe a system now. Our system is fully ionized. This is our first requirement, that partially ionized. We have not discussed partially ionized case, in which neutral atoms may also be should also be considered. So this system contains electrons, ions. For simplicity, we have considered hydrogen ion, that is protons. Quantized electromagnetic fields we will be considering, and electrons, since they are low in mass, are dominate the plasma motion, and ions are slow background. So here we can see that this equation describes. Initially, we have started with ionized gas. Since all ionized gas cannot be considered as plasma, there are some conditions that are to be satisfied for ionized gas to be plasma. So we start with this. This is a free electron, the free particle and description, electron interaction description term, electron proton interaction term, proton interaction term, and then electromagnetic carry momentum. We have modified the standard terms that we get in Maxwellian theory, and we get this is Podolsky. Most important term here is A, that is this is Podolsky length parameter. Podolsky length is in itself was first introduced by Bob and Podolsky in their paper in 1942. So in 1942 to 1944, a series of papers were released to discuss this term. So, and Podolsky mass may be also used instead of that, as we have modified.
Hello, Mr. Prabhat.
Yes, sir.
Yes, please conclude in 2 minutes.
Okay, so we will be skipping to conclusion results, most important results and limitation of the theory. In this work, we find that electromagnetic propagation modes, apart from the standard Maxwellian propagation mode, we have standard Maxwell photon mode and Podolsky modified photon mode. We regularize the UV divergences that are inherent in quantum field theory and quantum electrodynamics models that study plasma. Regularization is done when electromagnetic self-energy becomes finite, because Maxwellian theory, this is the greatest problem of the Maxwellian theory, that we consider point charges in itself, and Maxwellian theory describes Maxwell and Coulomb attraction describes their forces in terms of separation between the charges. In the point charge, the separation to its surface and dimensions of the charges are zero. So self-energy becomes infinite. Here in Podolsky theory, it is contained and is treated as finite energy. Electromagnetic self-energy becomes finite, and field energy remains bounded. So regularization of UV divergences takes place. Modified plasma oscillations, because we have modified photon modes, and screening behavior is also modified because of Podolsky length. Anisotropic photon mode directional behavior in that, which we have discussed in the middle of the paper. And topological effects and topological structures may be discussed. Small scale separation and fluctuations have been suppressed in this that cause instability. We predict that plasma is more stable and in high energy regimes than it was initially estimated, and to some extent simulation also shows that possibility of photon condensation has been discussed. This will be our future work, possibility of photon condensation in this type of plasma, high energy plasma. Non-Markovian behavior of plasma have been shown, and it predicts that memory effects in plasma interaction, meaning plasma dynamics depends on previous states, because photon mediation introduces time non-local interactions. So this is our conclusion. And regime of application, it is a robust theory, but it is not applicable everywhere. It is applicable in magnetically confined plasmas, tokamaks, sterilizers. inertial confinement fusions, solid state plasmas, laser plasma interactions. Limitations is that it does not consider non-abelian plasmas, means any particles apart from fermions have been not considered in this theory, means quark-gluon plasma or other type of plasmas are not considered here. Uniform photonic background has been considered, that is non-uniform photonic background, means a density variation of photonic fields, photonic states has been not been considered. We still have not performed simulations, but it verifies some simulation results. This theory verifies some simulation results, the simulation that were already existing, but theory was not there. Podolsky parameter is unknown experimentally, and we estimate it on the basis of the behavior of the plasma. What would be the Podolsky parameter? Thank you. Thank you, sir. Is there any questions, sir?
Yeah, hello, Prabhat. Yes. Okay, so Mr. Prabhat, you mentioned that we find two dispersion modes for electromagnetic waves.
Yes.
And construct an effective dispersion relation, which will, okay.
That is initial first section, first problem. Yes, sir. This you are talking about. So standard mode and Podolsky mode, omega is equal to plus minus k, where c is has been taken to be 1. This is natural unit configuration. And Podolsky mode, omega is equal to plus minus mod k upon root 1 plus a square k square, where a is Podolsky length and k is propagation vector.
K is k the wave number?
Yes, propagation. Yes, sir. So above is wave number.
Okay, so omega is the angular frequency and k is the wave number.
Yes.
Okay, and a is the Podolsky length.
Yes, sir.
Okay, yeah, that's all. That was my question. Thank you so much, Prabhat. Good luck.
Thank you.
Very nice,
Thank you, sir.
very nice presentation, and I'm sure you can do a lot of simulations in these, and
Yes,
this research can go very far. Yes, so please concentrate on that.
Thank you, sir.
Thank you.
Thank you, sir.
Can I have the next presenter, please?
Supriya Tiwari.
Priya Tiwari.
Yes, yes, sir.
Priya
Am I
Tiwari.
audible, sir?
Yes, you are audible. Please share your screen and start your presentation. You have 7 minutes.
Okay, thank you, sir. Is it visible, sir? Is it visible, sir?
Please cancel the phone screen. You see there is a cancel option.
Yes, sir.
Yeah, please cancel the side screen. There is a cancel option at the top. Yes, here. And please start your presentation.
Yes, sir. Good evening, everyone. Myself, Supriya Tiwari. I am a research scholar from Department of Mathematical Sciences, AKS University, Riva, under the guidance of Dr. Geeteshwari Pandey. Today's my research article entitled with Generalized Z-Ricky soliton on epsilon Kanematsu manifold with generalized Z tensor. The abstract of my research article. The aim of the present paper is to studying generalized Z-Ricky soliton on epsilon Kanematsu manifold with generalized Z tensor is to explore their geometric properties under different curvature conditions. First, we prove that a Ricky soliton admitting generalized Z tensor on epsilon Kanematsu manifold consists on expanding Ricky soliton with soliton constant and constant curvature. Moreover, we investigate the existence of Ricky soliton admitting generalized Z tensor of Kodazi type and cyclic parallel generalized Z tensor have been proved under certain conditions. We find the relation between one form A and B on Ricky soliton admitting generalized recurrent generalized Z tensor on Kanematsu manifold. Finally, we study generalized Z Ricky soliton in three-dimensional epsilon Kanematsu manifold, investigating curvature properties to study how generalized Z tensor of Kodazi type, cyclic parallel, generalized Z tensor, and other various curvature conditions affect the structure of epsilon Kanematsu manifold. Analyzing generalized Z Ricky solitons to examine Ricky soliton epsilon Kanmotsu manifold, which involves shrinking and expanding. Introduction. 1980, Richard S. Hamilton introduced the concept of Ricci flow to find canonical metric on a smooth manifold. The Ricci flow is an evolution equation for metric on an Riemannian manifold defined as follows. Equation first. Ricci solitons are special soliton of the Ricci flow. Equation A of the form. The concept of Ricci soliton also introduced by Hamilton and defined it as a generalization of an Einstein metric. Ricci soliton is a natural generalization of an Einstein metric and is defined on a Riemannian manifold. A Ricci soliton is a triple G V lambda with G a Riemannian metric, V a vector field, and lambda a real scalar such that LVG 2s plus 2 lambda G equal to 0, where S is a Ricci tensor and Lie denote the Lie derivative operator along the vector field V. Lambda is the soliton constant and G is the metric. For lambda is less than 0, steady for lambda equal to 0 and expanding for lambda is greater than 0. Recently, UC Day and Sardar and K analyzed the concept of Ricci soliton and studied Ricci-Ambe soliton in Riemannian manifold. On the other hand, the concept of Z tensor was introduced by Mantica and Molinari, and they studied a weakly Z symmetric manifold. Introduced a 0-2 type symmetric tensor is called Z tensor if ZKL is equal to SKL plus zeta Z KL, where zeta is an arbitrary scalar function. P. Pandey introduced the notion of generalized Z tensor. According to Pandey, a 0-2 type symmetric tensor is called generalized Z tensor if equation third satisfies, where zeta and phi are non-zero scalar function and eta is a one form. In 1972, Kanmotsu studied a class of contact Riemannian manifold satisfying some special conditions, and this manifold is known as Kanmotsu manifold. The author in first site have studied Ricci soliton in contact and Lorentzian manifold. The study of manifold with indefinite metric has a great relevance from a standpoint of geometrization of physics and relativity. Kanmotsu manifold arise naturally in the study of Sasakian manifold, which are a special case of contact metric manifold and additional geometric properties. Some curvature condition on Kanmotsu manifold studied by Singh et al. Phi recurrent manifold with generalized conditions studied by Sheikh et al. Takahashi studied Sasakian manifold with associated pseudo-Riemannian metric and are known as epsilon Sasakian manifold. Bejanku and Duggal showed the existence of epsilon almost contact metric structure and provide an example of epsilon Sasakian manifold. Further investigation on this manifold was taken up by X. Yufeng and X. Yoli and Rakesh Kumar et al. The study of manifolds with indefinite metric has a great relevance from the standpoint of geometrization of physics and relativity. Recently, D and Sarkar introduced indefinite metric on Kanmotsu manifold are called epsilon Kanmotsu manifold. Here, they studied conformally at Weyl semi-symmetric phi recurrent epsilon Kanmotsu manifold. Further, there are some preliminaries of my research or article. Let M be an n-dimensional differential manifold endowed with an almost contact structure phi eta xi, where phi is a tensor field of type 1,1, eta is a one form, and xi is a vector field on M satisfying equation 4. A differential manifold with an almost contact structure is called an almost contact manifold. An almost contact metric manifold is an almost contact manifold endowed with a compatible metric G. An almost contact metric manifold is said to be an epsilon almost contact metric manifold if condition 5th and 6th are satisfied. A differential manifold with an almost contact structure is called an almost contact manifold. An almost contact metric manifold is an almost contact manifold endowed with a compatible metric G. An almost contact metric manifold is said to be an epsilon almost contact metric manifold if 7, 8, and 9 are satisfied. There are some confined results of the paper. First, Ricci soliton admitting generalized Z tensor on epsilon Kanmotsu manifold is shrinking with an amount of soliton constant lambda is equal to minus 5 epsilon plus 1 and R equal to 2 plus 6 epsilon. Second, if zeta and psi are constant, then there does not exist a Ricci soliton admitting generalized Z tensor of Kodazi type on epsilon Kanmotsu manifold. And next result is there does not exist Ricci soliton admitting cyclic parallel generalized Z tensor on epsilon Kanmotsu manifold if zeta and phi are constant, zeta and psi are constant. Next result is there does not exist Ricci soliton admitting phi Ricci symmetric generalized Z tensor on epsilon Kanmotsu manifold if zeta and psi are constant. A Ricci soliton admitting generalized Z recurrent on epsilon Kanmotsu manifold. The soliton constant is given by these conditions when if epsilon is equal to 1, then lambda equal to xi plus psi, and if epsilon equal to -1, then lambda equal to 2 plus psi minus zeta. The soliton is shrinking if psi minus zeta is less than -2, steady if psi minus xi, and expanding if psi minus xi equal to -2, where psi and zeta belonging to -infinity to +infinity. And the soliton constant is shrinking, steady, and expanding in these given conditions. Next, in a Ricci soliton admitting generalized recurrent with generalized Z tensor on epsilon Kanmotsu manifold, the one form A and B are related by following equation. K1 plus zeta minus epsilon plus psi is equal to... Yes, sir. These are also conclusion of our research article. Yes, sir. And conclusion. In the present paper, we have studied generalized Z Ricci soliton and epsilon Kanmotsu manifold associated with the generalized Z tensor. The investigation focuses on geometric behavior of the generalized Z tensor and its influence on the structure of Ricci solitons defined on epsilon Kanmotsu manifold. Several important geometric consequences have been obtained. It has been shown that a Ricci soliton admitting a generalized Z tensor on epsilon Kanmotsu manifold is necessarily a shrinking soliton with a soliton constant and possesses constant curvature under the considered conditions. Furthermore, we prove a Ricci soliton admitting a generalized Z tensor of Kodazi type and cyclic parallel generalized Z tensor do not exist on epsilon Kanmotsu manifold under certain geometric constants. These non-existence results highlight strong restrictions on the geometric structure of such manifolds. The results obtained in this work contribute to a deeper understanding of Ricci soliton geometry in the framework of contact metric manifolds, particularly epsilon Kanmotsu manifold. These findings may serve as a formulation for further investigation on generalized tensor. These are some references of my research article. Thank you, sir.
Okay, is there any question from the audience?
Nice presentation.
Thank you so much, sir.
Yeah, Supriya, nice presentation. Okay, so
thank you.
Yeah, so your research focuses on Kanmotsu manifold, correct?
Yes, sir.
So what is the difference between that and Einstein manifold?
Yes, sir.
Difference between Kanmotsu manifold and Einstein manifold?
Yes, sir.
The difference? I'm just curious to know.
Yes, sir. A Kanmotsu manifold is a special type of almost contact metric manifold introduced by some researchers, and there are particular definition and almost contact metric manifold. Kanmotsu manifold has... Yes, sir. And epsilon manifold.
Einstein. I said
Einstein. Oh, so sorry, sir. Einstein manifold. And Einstein manifold is a special type of manifold whose Ricci tensor is proportional to the metric tensor. It satisfies the certain conditions. Describe a manifold with a specific curvature property, special class of Riemannian manifold.
Yeah, and any like practical application of this kind of research, like where you can use in industry or something like that? Any industrial applications of this kind of research?
Yes, sir.
Where?
Use of epsilon Kanematsu manifold to investigate geometric properties such as curvature tensor, Ricci tensor, scalar curvature, and sectional curvature. The research in geometric structure application.
So structural engineering, right?
Yeah.
Okay. Yeah. Thank you, Supriya. Thank you so much.
Thank you so much. Thanks again.
Okay, Shubham Singh.
Shubham Singh, please start your presentation. Please share the screen, and you got 7 minutes.
Shubham Singh.
Shubham?
Sir,
Yes.
Sir, I Ekta Devangan. Can I present?
The Shubham is not there.
No, I think.
Okay, then Ekta Devangan, you can.
Yeah,
start.
Ekta, please share the screen and start your presentation.
Okay, sure.
You got 7 minutes.
Okay. Yes. Sir, is my screen is visible?
Yes.
Is this visible? Hello?
Yes, we can see your screen.
Yeah, start the presentation, please.
Click on show.
Okay. Sorry?
Yes. Now it's okay.
Is this visible?
Yes, please start.
A very good evening, each and everyone present over here. My name is Ekta Devangan, Research Scholar, Department of Mathematics from Sri Shankaracharya Professional University, Bhilai, Chhattisgarh. Today I am here to present our work on the topic fixed point theorem in SF contraction in complete fuzzy metric space. And here are some overview which we will discuss further. The abstract of our work is by using SF contraction and altering distance function to establish a new fixed point theorem in complete fuzzy metric space. These are some keywords. Now I would like to give some introduction. The fixed point theory is a fundamental idea of modern mathematics origin with the work of Poincare in year 1886, and after that the concept of fuzzy set was given by Zade in year 1965. And in year 1975, Kramosil and McCulloch introduced the concept of fuzzy metric space. Then George Viramani modified same concept which is used in present time. The concept of F contraction introduced by Wardowski, then motivated by them, Sojit et al. Gave some new concept like SF contraction in defined in fuzzy metric space. Now in preliminary part, I would like to define some basics as fuzzy set. In fuzzy set, an element can belong to some grading between 0 and 1, and as continuous t-norm. So to be continuous t-norm, the following axiom should be satisfied. That is, the t-norm should be commutative, associative, and continuous, and combining any fuzzy membership value a with 1 using t-norm operation, it remains same. And after this, if abcd be the fuzzy membership and the relation between them is as a less than or equal to c and b less than or equal to d, then it implies that a star b less than or equal to c star d. Now moving to the km fuzzy metric space, according to Kramosin and McCulloch, there is a tripled xm star is said to be fuzzy metric if the following axioms are satisfied, their results modified by the George and Viramani also. And now, according to Wardowski, the concept of F contraction is if we have a metric space and T be a self-mapping, then it is called an F contraction if there exists a positive constant such that these inequality, then F satisfy the following axiom, that is F is strictly increasing if k and b any sequence converges to 0, then function of kn is diverges to negative of infinity, and as k approaches to 0 from the right, then m times of k of f of k tends to 0. F contraction was defined in metric space, similarly SF contraction was defined in fuzzy metric spaces by Sojit et al. And satisfied the same condition as F contraction have. Here some theorems which is results which is given by the Sojit et al. Now moving to the alternate distance function, as alternate distance function psi in 5 was taken, and psi should be non-decreasing and continuous, and similarly phi should be Lebesgue integrable and non-negative. Now move to the main result of our work. If we take a tripled xn star and tb and sf contraction and psi phi as alternate distance function, if there exists a constant alpha lies between 0 and 1 and delta, then these equalities holds, then t has a unique fixed point. To prove this theorem, we have taken some points and functions as we required. Then take a sequence and prove this sequence is Cauchy and complete. After that, prove the uniqueness of the point by taking another common points. This is an example which validate our result, and the part of conclusion is that a new fixed point theorem was established by using SF contraction and alternate distance function, which provide new path for the researcher in the particular field. And the future scope of the work can be to construct a population dynamic model which will show the stable population equilibrium, and another scope can be in the field of economics and market equilibrium model, which will show the relation between supply and demand of the product or any other thing. And these are some references which I have used. And at last, I would like to say that this is my first paper presentation. Thank you, sir.
Okay, Ekta Devanga, thank you very much. In the last few slides, you showed some something about biological models and some other things. So I have a question that, yes, economics and market equilibrium. So is there any way you can connect this research to achievement of any of the UN Sustainable Development Goals?
No, sir. Actually, we have working on it. This is not completed yet.
And what about the novelty of this research work?
Actually, we have used two types of contraction. One just like SF contraction and alternate distance function. This is this will give some more compatible result from others.
Okay, is there anyone?
If we apply, sorry.
Okay, please continue.
If we apply that result which we have given here, then we have more compatible result. We will have a more compatible result.
Okay, is there anyone else from the audience? Yes.
Hello, Ekta. Nice presentation. Can
Yes.
you please go to the first slide?
Yeah, sure, sir.
The one that has the introduction and the title.
Title?
Yes. Yeah. Okay, so your topic is fixed point theorem in SF contraction in completely fuzzy metric spaces. So how do you correlate between fixed point theorem and SF contraction?
Basically, sir, can I speak in Hindi, sir?
Of course, because SF contraction is altering distance, correct?
No, sir. SF contraction ये एक अपना property रखता है, alternate distance एक अपना property रखता है.
But you did not mention
Or contraction.
alternating distance in the topic.
Sorry, sir.
Alternating distance आपने mention नहीं किया title में.
Alternate distance मैंने इसमें mention नहीं किया है, sir.
तो लाइक आपका एम क्या है? मतलब आई वांट टू नो, मतलब मुझे नहीं समझ में आ रहा है, तो आपका क्या एम है? आप क्या मतलब अचीव कर रहे हैं इस टाइप की रिसर्च से? what is
Sir,
your
actually ये जो contraction and altering distance function है already published है या already given है by someone. इन दोनों कॉन्सेप्ट को यूज करके हम एक ऐसा रिजल्ट बनाना चाह रहे हैं जो बाकी सारे रिजल्ट से मोर कंपैटिबल हो, जो स्टेबिलिटी को बहुत अच्छे से प्रेजेंट कर सके. बेसिकली फिक्स पॉइंट थ्योरम किसी मैट्रिक स्पेस में बताने का मतलब ये होता है कि किसी भी सिनेरियो की स्टेबिलिटी किस वे में हो सकती है, कितनी हो सकती है.
तो आपके कोई रिजल्ट्स आए हैं? आपने कुछ इसमें कुछ आपके पास है डेटा?
नहीं सर, अभी नहीं है. मैं इस पे काम कर रही हूँ. मेरा फर्स्ट प्रेजेंटेशन था. अभी मैंने जस्ट स्टार्ट किया रिसर्च.
Okay, so what I would suggest is that you gather some data, you analyze it, you
Yes, sir.
get some results, and then compare your results with the studies done by previous scholars, and then see
Yes.
what is the difference between your results and their results. Okay, and
Yeah, sure, sir.
then,
Sure, sir.
because then you would have to prove that how your results are better than their and more accurate than their results. Okay.
Yeah, sure, sir. Sure, sir. Thank you for the suggestion, sir.
बिकॉज द एम, कोई भी स्टडी का एम यही होता है कि आप प्रीवियस रिसर्च को और जो है अच्छा करें, उसको और जो है रिफाइन करें, एनरिच करें. तो आपके रिजल्ट्स जो है वो ज्यादा एक्यूरेट होने चाहिए कंपेयर टू द प्रीवियस रिसर्चर्स. ओके,
Yes, sir.
वो
Sure,
तो
sir.
अपना
Thank
काम
you, sir.
करके चले गए 50 60 साल 70 साल पहले. तो आपको जो है उनके काम को आगे बढ़ा के और उसको बेटर आपको रिजल्ट्स देने हैं. ओके.
जी सर, sure, sure.
And that it was your first presentation and it was wonderful. You have grasp of the concepts, you know things. So my suggestion would be to do some data processing now and get some results and then compare your results with the previous literature. Okay.
Yes, sir. Thank you so much, sir. Thank you.
Thank you
And
so
sure,
much.
sir. मैं इसमें काम करूँगी, sir.
Sure. Thank you so much. Have a great
Okay, thank you, sir.
Can I have the next presenter, please?
Okay, Nasreen Fatima.
Yes, sir.
Please share the screen and start your presentation. You have 7 minutes.
Good afternoon, everyone. I am Nasreen Fatima, research scholar in the Department of Mathematics, MIT Manipal. First of all, I would like to thank organizers of Team CONIAPS for giving me an opportunity to present my work here. I am working on the title Influence of Surface Irregularities on Electroosmotic Peristaltic Flow of Temperature-Dependent Jeffrey Fluid in an Inclined Channel under the guidance of Dr. Manjunath Gudakote and Dr. Nagraj N. Katagi. This is the flow of my presentation. This is the overview where we have investigated the peristaltic transpose of a viscous incompressible non-Newtonian fluid. We have considered the Jeffrey non-Newtonian fluid model, which is viscoelastic fluid model. And we have incorporated the effect of surface irregularities, slip boundary condition for temperature and concentration, temperature and velocity, and electroosmotic effect. Also, we have considered viscosity and thermal conductivity as a function of temperature, and we have formulated the governing equations, that is continuity momentum equation, using the Navier-Stokes framework. And the approximations we have considered here is long wavelength and low Reynolds number approximation. And by this, we get a coupled nonlinear equation, which are solved using perturbation technique. And we have made use of MATLAB R2025B in solving and obtaining the graphical result and interpreted the result. Starting with the introduction, we have used the concept of peristalsis. Peristalsis is a sequence of muscular contraction and relaxation of muscles, which pushes the physiological fluid forward, which is mainly found in most of the biological scenarios, like passing of food in the esophagus or in intestine, in small intestine, large intestine, urethra, etc. And we have considered the effect of surface roughness, that is or no channel is perfectly, there will be some sort of irregularities on the surface. These are referred to as surface roughness. We have incorporated The equation shown here represents the Jeffrey nu is the viscosity of the fluid, and lambda 1 and lambda 2 are the relaxation time and retardation time respectively. Description of the work: we have formulated the peristaltic flow of non-Newtonian Jeffrey fluid in a non-uniform channel with inclination, and we have incorporated the effect of electrons here. Equation 3.1 represents the geometry of the fluid model, and we can clearly see that A is the half channel width at the end, K prime is a non-uniformity parameter, B1 is the amplitude ratio, B2 is the roughness height, L1 is the wavelength, and lambda 1 bar is the pitch, C is the wave propagation velocity. We have from the above, we have formulated the governing equation according to the problem we have considered. Equation 3.2 represents the continuity equation. Equation 3.3 and 3.4 represents the momentum equation, where LHS represents the inertia force, and the first term in the RHS represents the pressure force. Second and third represents the viscous force, and next term represents the electroosmotic force in X and Y direction, and the force due to inclination in represent in the last term. And the energy equation considered is taken as in equation 3.5, where the left hand side represents the rate of change of thermal energy. Right hand side, the first two term represents the conduction in X and Y direction, and the third, fourth, and fifth represents the viscous dissipation due to normal stress and shear stress in X direction, Y direction, and the sharing in XY. And mu represents the heat generating parameter. And above equation, we have used some of the non-dimensionalized terms in simplifying the equation, and also we have incorporated the assumptions of long wavelength and low Reynolds number. By this, we have we got the simplified equation for continuity equation as in equation 3.7, momentum equation in X and Y direction as in equation 3.8 and 3.9, and the energy equation is given in equation 3.10. We have taken the complete slip boundary velocity and temperature, which is shown in equation 3.11 and 3.12. And after the process of non-dimensionalization of the Jeffrey fluid model equation, we obtain the equation 3.13, and equation 3.14 and 3.15 represents the temperature dependent viscosity and temperature dependent thermal conductivity considered in the model. We have solved these equations using perturbation technique. We have taken alpha 1 and alpha 2, that is temperature dependent viscosity and thermal conductivity parameter, as the perturbation parameters, and using MATLAB we have plotted the graphs, and for validation we have taken the work by Chowdhury et al. We have nullified the effect of variable thermal conductivity, temperature dependent variable viscosity, first and second order slip parameter, roughness height, and inclination angle, and we can clearly see that in the figure our work agrees completely with that of the work by Chowdhury et al. Here are some of the graphs. Here are some of the graphs I have considered. Graph A and B represents the change in velocity when we increase the Helmholtz velocity parameter and the electroosmotic parameter. When we increase the Helmholtz velocity, because of the increase in the electroosmotic force, there is an increase, there is a drive in the velocity, that is why there is an increase in velocity. Also, when we increase the value of kappa, that is electroosmotic parameter, which is inverse of Debye length, the Debye length decreases, that is why there is an increase in velocity. Also, we have compared the result of Newtonian and non-Newtonian, the Jeffrey fluid model, and we can clearly see that Jeffrey fluid model has better performance compared to that of the Newtonian fluid model. And figure C and D represents the variation in velocity for increase in thermal conductivity and variable viscosity parameter. There is a clear increase in the velocity. As we increase the roughness height phi1, that is because of the sharing at the wall, there is a decrease in velocity as the roughness height is increased. Also, when we increase the angle of inclination, there is a increase in velocity. Also, when we improve the slip parameter, that is starting from 0 to 0.01, as we introduce more slip, there is a increase in velocity. Also, the temperature profiles, we can see that A and B represents the variation temperature for Helmholtz velocity and electroosmotic parameter. There is an increase in velocity because of the viscous dissipation that's happening. Also, alpha 1 and alpha 2 also shows the similar behavior because all these will increase the velocity. There is friction between the layers of the fluid that will generate some temperature. As we increase the roughness height, there is a decrease in temperature because at the walls, because there is some sort of recirculation, so there is some sort of escape of temperature at the boundary. So there is a decrease in temperature. And when we increase the angle of inclination alpha, there is an increase in temperature. Also, when we increase the velocity, thermal slip parameter, there is no escape of temperature at the boundary. That is why there is an increase in temperature. These are the streamline graphs. Figure A represents the streamline when the roughness height is 0, that is for the smooth channel, and B for the rough channel. When we increase the roughness height, there is some sort of distortion, and there is no clear lines. And figure here represents the variation in streamlines for increase in thermal variable viscosity parameter. As we increase the various viscosity parameter, we can see that there is the size of the bolus, and there is the number of the bolus also increases. The same is the scenario here in variation in thermal conductivity with respect to temperature. Conclusion: the principal findings of the work are as follows. The non-Newtonian Jeffrey fluid exhibits superior transport characteristics compared to the Newtonian fluid model. Electroosmotic forces, slip effects, and channel inclination collectively enhance momentum transport, improving fluid flow efficiency. Temperature-dependent material properties and elastic factor primarily promote heat transport and increasing thermal efficiency. When surface roughness is excessive or caused by disease-related plague, it can impede fluid flow and heat transfer, reducing the efficiency of microfluidic or biomedical system. Increased surface roughness distorts streamlines, whereas smooth surface allows streamlines flow with minimal recirculation. Higher Jeffrey fluid parameter, along with increased viscosity and thermal conductivity, enhances fluid resistance and heat transfer, leading to a largest bolus size and a greater number of streamlines. These are the references. Thank you. So, any questions, sir?
Okay, is there any question from the audience? Yes, Nasreen Fatima, that was a very wonderful presentation, and your slides were very neat and clean. So,
thank you, sir.
Let us know what is the practical application or of this research work.
It can be used in drug delivery systems, sir. Like targeted drug delivery, electroosmosis can be included.
Okay, so do you have any idea how the targeted drug delivery works?
Practically, we have not included, but I have a rough idea, like, to the skin or something. Electroosmotic can be the positive and negative ions can be like anode can be applied, and there can be motion of fluid. So electroosmosis usually dries the fluid with more force.
Okay, so you are having these data from any simulations or mathematical models?
The mathematical models, sir, base models, and yes, sir. Previous mathematical models, I can say.
Okay, thank you very much, Nasreen, and thanks a lot for presenting here. And now I would like to invite our next participant, Ms. Nancy Shrivastava.
Yes, sir.
Please share your slides.
Nancy, you have 7 minutes for the presentation, okay?
Okay, sir.
Thank
Sir, is my screen visible?
Yes, visible.
Okay. Good evening, everyone. This is Nancy Srivastava, Department of Computer Science and Application, under the supervisor Shweta Singh. The topic is a review of the application of wireless sensor in
And
healthcare.
excuse me, what is your organization's name?
United University,
Okay.
Prayagraj.
Okay, thank you.
A review of the application of wireless sensors in healthcare. This helps in exploring the transformative impact of wireless technology on patient monitoring and healthcare delivery. So the wireless sensor revolution in healthcare, it is a continuous monitoring, enhanced comfort and personalized care with a fundamental to ambient assistant living AL WSNs provide personalized feedback by monitoring users and their environment continuously. Wireless body area under area networks, the heart of the modern healthcare. The typical data monitoring the ECG and the heart rhythm, blood pressure variations, glucose levels, limb movement, and gait. It is a standard optimizes low power, reliable communication around the human body, enabling remote monitoring that improves quality of care and patient independence. What is the real world impact on this system? That is a continuous monitoring and early intervention. We have three areas, that is vital sign tracking, reduce emergency events, and AI integration. So under the vital area sign tracking, wearable devices continuously track the heart rate, respiratory system, oxygen level, temperature, and the reduce emergency events. It helps in the continuous signed monitoring on the general wards, significantly reduces the emergency events and shortens hospital stays. And what is if we include the AI integration, it helps in the enhancement of predictive analytics for early diagnosis and personalized treatment plans and improving the health as well as the improving the patient outcomes. Uh, we have a case study, the heart failures management with wireless sensors. We have the annual cost and the continuous monitoring. So we have compared both the things, that a heart failure cost which exceeds and the continuous monitoring which helps in distinguishing both the things. So it will help in the further uh, study uh, the research purpose. We have the pilot studies demonstrating the promising results in reducing rehospitalization rates, significantly improving the patient quality of life and independence. Next one is the technology landscape. We have the wireless protocols in the sensor types. Under the wireless technologies, we have BLE, we have Zigbee protocols, we have emerging 5G, 6G networks, and under the sensor categories, we have optical sensors for pulse oximetry, acoustic sensors, chemical sensors, and biosensors for various biomarkers. Technology landscape. What are the challenges and solutions in wireless healthcare sensor deployment? So, privacy and security, the medical data encryption and robust access control models and the guarding, patients compliance, data management and infrastructure. So these are the challenges as well as the solutions pertaining to the wireless healthcare sensor deployment. Future trends, AI driven wireless sensor and beyond. What are the future trends we can see in the enhancement? We have AI enhancement, contactless sensing, telemedicines integration, and next gen networks. Visualizing the transformation from hospital beyond to anywhere care. These will help to visualize the patient as well as to visualize all the datas as well as all the taking care field in a proper way. What are the conclusion? Wireless sensor empowering the future of the healthcare. It is a no doubt is a revolutionary steps and a continuous innovation, because we can't say that this is the particular area which will be ending here. It is a continuous process, and moreover advanced version also will come in the future, and essential adoption, because AI is trending all over, so it will helps in the study for the future generations as well. Thank you, everyone.
Thank you, Nancy, for the wonderful presentation.
Thank you.
And it was very insightful and knowledgeable.
Thank you.
Okay, so I have like a few questions.
Yes.
So since your research is focused on wireless sensors, so what like advantage it has in diagnostic of diseases over like traditional traditional ways?
So actually, with the advancement of AI, this research will help to amalgamate both the paperwork as well as the soft copy, so that both the versions will be available for the hospital purpose. Means if anyone want to see the hard copy of the documents, as well as if anyone want to access the soft copy for their purpose, so both the things will be helpful in managing the details of the patient, details of everything which is required for the for the knowledge purpose also, as well as for the data enhancement also.
Okay, so in like a hypothetical scenario, we develop a sensor that can be used to measure the blood pressure. Okay.
Yes, sir. Yes, sir. Yes, sir.
Okay, so like what would be the cost effectiveness of such a technique over like traditional techniques to
So
measure?
actually, we are working on this, but we have just a case study seeing the heart failure management with the wireless sensor. So it is a approximate, but we will working on this so that we can get the exact cost, or we can approach to approximate cost as well. So it will be helpful for the future endeavors also, and we get an idea also how cost effective or how much it will be enhancing or up-leveling the cost also.
Okay, so like do you have plans to develop any such sensors?
So I'm working on this, and I'm in a planning to visit the hospitals also, so that under the guidance of the technicians and hospital management, we can collect more and more data, so that the research can be more useful and more proper while collecting all the data.
Yeah, that would be wonderful. And
Yes,
if
yes.
cost effectiveness can be
Yes,
worked
yes, yes.
out in
Our main motto is it will be reachable to each and everyone and cost effective also.
that would be really a revolution in the field of medical
Yes, yes,
sciences.
yes.
And I wish you good luck and all the best.
Thank you so much, sir.
And I wish you all success.
Thank you, sir. Thank you
so much. Can I have the next presenter, please? Madhukar Kulkarni.
Yes, sir. Good evening, sir.
Good evening. So you have like 7 minutes for your presentation. Please share the screen and start your presentation.
Okay, sir. So, is my screen visible? Hello, sir. Hello, sir. Can I present?
Yes, Mr. Madhukar, your screen is visible. Please start.
Good evening, everyone. I am Madhukar Malhari Kulkarni, research scholar working under the guidance of Professor S. Shiral Shetty, sir, Chairman and Director of PIMSI, Department of Mathematics, Karnataka University, Dharwad. And today, the title of my presentation is Gaggenberg wavelet-based numerical method for the solution of system of ordinary differential equations. This is the outline of my presentation. Now, the abstract. This work presents a detailed study of Gaggenberg wavelet-based numerical method for solving system of linear and nonlinear ODEs. This method in science and engineering is a successful procedure to get numerical solutions of different types of ODEs. The proposed method is applied to different class of ODEs and for getting numerical solutions. Now, the results obtained from the Gaggenberg wavelet method are compared with that obtained from Harvard wavelet-based numerical method and conventional methods like shooting Rugen-Kutta-Felber 4-5 and the results show that our method is readily comparatively accurate and readily implementable. So this is some basic introduction about wavelets. So wavelet means small wave, and wavelet analysis is about analyzing signal and small duration finite energy functions. Wavelets are small localized functions based on time frequency distribution that are used to represent a larger signal. They transform the signal under investigation into another representation, which converts the signal in a more useful form. This such a transformation is called as wavelet transformation, and so on. It has recently it has found tremendous applications in many fields in mathematics, like fluid mechanics, harmonic analysis, numerical analysis, signal analysis, fractal and multifractal analysis, and so on. This is the in general definition of a wavelet. This is example of a continuous wavelet. Here it is defined by two parameters, the scaling parameter and the shifting parameters. And for practical purposes, we discretize these parameters, and we get the following form. And this is some earlier to the wavelet methods. Researchers used finite volume methods, element method, and Runge-Kutta-Feldberg spectral methods, and many more methods. However, since wavelet methods analysis has come, we have found many methods which are comparatively superior to these earlier methods. So this is again some historical background about wavelets. The first mention of word wavelet was in the PhD thesis of Alfred Haar in 1909, and the main pioneer who boosted the research was Ingrid Dabashe. Now, coming to the Gagenberg wavelet, so the Gagenberg wavelets are defined based on the Gagenberg polynomials. This is the definition of Gagenberg polynomials. This is the they are basically there are three parameters. The n is the nth order of that polynomial, the degree of that polynomial. So these two are the bases, 0 and 1, and using the recurrence relation here, we can obtain the higher order polynomials. And of course, by using the Rodriguez formula as mentioned here, we can obtain a same values of polynomials. Now, some of the properties are exhibited by these polynomials are the orthogonality with respect to the L square space, like this, and with respect to the weight function as mentioned here. And using these Gagenberg polynomials, Gagenberg wavelets are constructed. So this is the definition of the Gagenberg wavelet. Again, here also three parameters are there, n, m, and xi. Now again, these n and m are they can be converted into a single index I, and again here this is again the modified version here of the Gagenberg polynomial. The various parameters mean the following. M is the order of the polynomial, and it goes from 1 to so and so. And okay, now this basically means is any square integral function f of psi from the L square space can be expressed as the summation of the Gagenberg wavelets times some unknown coefficients. And for again practical purposes, we can truncate this series by this from 1 to 2 power k minus 1 and so and so. So, and in we can express that series form into matrix form. So like this, and that the matrix order of that matrix would be of n cross n, where n is of this form and I is of can be calculated using this formula. Now, the first operational matrix, the Gagenberg wavelet, when substituted for these values, and for I equal to 8, we get this. So basically, for I equal to 8 means there are 8 basis vectors, 8 basis wavelets orthogonal of the orthogonal family, which form the basis, and we use the collocation points, and for each of the wavelets, 8 collocation points are used. So therefore, we get a 8 by 8 matrix, and so once you get this wavelet matrix, we can integrate it and we get the higher order operation matrix of integration. So this is another particular notation. So basically the method is whenever differential equation is given, we approximate its highest order term by a series, a truncated series, which has a finite number of terms of the basis vector. In case here it is the Gagenberg wavelets times some unknown terms. So what we do is we again integrate them and use the collocation points. So we get all these lower order derivatives, and then once we have these, we use the collocation points and substitute back into the original given differential equations, and thereby we get a series system of n by nonlinear systems in terms of these unknown coefficients. And since so the basically what I have done is we have converted a non-linear or linear system of differential equations into something which we know already, that is a system of algebraic equations, and these can be solved by using the known methods in literature, like the Newton's method, or if they are a system of linear equations, then they can be so easily solved by many more methods. So on solving this, we get the Gagenberg coefficients, and back substituting, we get the solution. So to test this, first consider a simple system of linear BVP as shown here. So again here, the highest order term is the second derivative. We approximate it in terms of the Gagenberg wavelets, and the same for the second one. These are boundary points, and now again we have to integrate either from 0 to x or from 0 to 1 wherever necessary. After some simplification, we get this equation, and some of the unknown parts are there, and so by some clever manipulation we can obtain, again back substituting them into the original differential equations, we get a system of equations. When they are solved using the Newton's method, we get the coefficients as follows. See, they are of the order 10 power minus 17. So they can be basically they are neglected. So the only affecting factor here is the A1 term. Here it is a B1 term. So when so for the particular test problem, the exact solutions are here: x square minus x and x minus x square, and this is the error norms used. Okay, so this table shows first. So since it's basically a relatively simple system of linear equations or differential equations, the Harvey-Wavelet method, the Runge-Kutta-Feldberg method, and the Gagenberg-Wavelet method, all for various values of n, they have produced zero error. So here is the one particular. Okay, so the exact values and the Gagenberg-Wavelet predicted values, they match for 6 decimal places. This is the graph of the same. Here we can observe that the error first keeps on decreasing for first value for y1, and it keeps on increasing. So it has a dip, minima. Here it has a maxima. Second test problem, this is a highly nonlinear BVP, and here again same. You take the second. This is comparatively more complex than the previous one. So again, you take the second highest order derivative in both the unknown variable and dependent variable, and you approximate in terms of the series of Gagenberg wavelets with unknown coefficients here a and bi. Again, we have to integrate with respect to x from 0 to x or 0 to 1 depending upon the necessity. And again, after these manipulations, we get this was the unknown value, and using all these values in back substituting in the given differential equation and using the collocation points, we get a system of 32 by 32 equations. And after solving them, for the unknown coefficients, we get these as the unknown coefficients, and again back substituting we get the solution. For this problem, these two are the exact solutions. Again, this same error norm is used here. Here in previous case there was a clear 0 0 because, but now here we can observe that the Haar wavelet operation method, which is defined based on the Haar wavelet, it has higher error compared to the Runge-Kutta-Felber. But initially for n equal to 8, the Gegenberg wavelet method is clearly in all cases Gegenberg wavelet is superior than the Haar wavelet method. But for lower values of n, it lags behind the Runge-Kutta-Felber. But as the values of n increases, we can clearly see the performance of Gegenberg wavelet. The error keeps on reducing drastically. So for n equal to 28, we have of the order of 10 power minus 10. It is 10 power minus 7. Here, both are almost similar. So the same analysis goes for the second dependent variable. Again, since we have for 10 power minus 10 error is there. So again, 10 power minus 6, we clearly get 0 error. This is the these are the graphs, corresponding graphs, and basically there is almost negligible difference. Okay. So to conclude, we have successfully implemented the Gegenberg wavelet integration operational matrix method to solve a system of ODEs, both linear and nonlinear, and check its validity by comparing it to Haar wavelet integration operational matrix method, the shooting Runge-Kutta-Felber method, and the exact solution of those ODEs. This solution accurately matches the exact answer with some negligible error. However, the accuracy keeps on increasing as we increase the value of n. In comparison, the Runge-Kutta-Felber and Haar wavelet, the operational matrix method defined on basis of Haar wavelet, it generates very minor but non-zero errors for nonlinear ODEs. The operational integration matrices enable the effective and precise conversion of differential equations into algebraic systems, resulting in a stable and highly accurate numerical method technique. Our method assures almost absolute conformity with the analytical solution, making it good candidate for the solution of ODEs whenever higher accuracy is needed. This method can be extended to more complex ODEs and even PDs as well. These are some of the references. Thank you.
Thank you, Mr. Madhukar Kulkarni. And
Yes, sir.
I would also like to express thanks to your supervisor, Professor Shirala Shetty. He, on the first day, did a very, very wonderful presentation. Also,
Yes, sir.
your colleague, Dr. Abhishek Sangoli. All of your group is very wonderful.
Thank you,
And,
sir.
Thanks for the nice presentation. And if there is any question from the audience.
Yes.
Okay,
Mr.
so Dr.
Madhukar,
Bhalwa is
like,
coming.
is there any industrial or scientific application of this research work? Have you looked into that?
Yes, sir. I actually I will apply this for some fluid problems, sir. So now currently I have tested it for some test problems which already have a solution, sir. But I haven't applied it for fluid problems, sir. So once I do that, we'll definitely find many applications, sir.
Okay, sure. Thank you.
Thank you for providing me this opportunity, sir. Thank you, sir.
Okay, so thanks a lot to everyone, and I take this opportunity to express a vote of thanks. Very good afternoon to all of you. And first of all, I would like to express our heartfelt thanks to our professor Mumtaz Ahmed Qureshi, Dr. Chitrasen Gupta, our Dean Faculty of Basic Science, and all the faculty members of the Faculty of Basic Science. And it is my proud privilege to propose the vote of thanks on this special occasion. On behalf of the organizing committee, I express my sincere gratitude to all the honorable delegates who graced this conference with their presence and contributed to making this event meaningful and successful. I would like to express my heartfelt thanks to all the members of the program advisory committee and the invited speakers for their constant guidance, valuable insights, and unwavering support in shaping this conference. I also take this opportunity to convey our deepest appreciation to our esteemed keynote speakers, Dr. Bhupendra Shukla, Dr. Vinod Tyagi, Professor Gajendra Singh, and all the PhD students today, all the UG and PG students, the engineering students also, and for their enlightening and informative lectures. My sincere thanks to all the faculty members and non-teaching staff for their dedication, support, and encouragement throughout the organization of the events. All the international speakers are sincerely thanked from our side. like from Dr. Sham S. Pandey from Japan, Dr. Kumar from Saudi Arabia, Dr. Meheto from South Korea, and Dr. Solomon from China. And finally, I would also like to thank each and every one of you present here for taking the time to be with us and for contributing to the grand success of this conference. Thank you all. Just a second, Dr. Bhaldwaj, our colleague, will also address you.
I want to thank all the keynote speakers, all the research scholars, PhD students, UG and PhD students who participated in this online session of the conference. I also want to thank the organizing committee and our dean, Dr. Sharendra Yadav, my head of department, Dr. CP Singh, for giving me the opportunity to be the anchor for the online session for this conference. And my heartiest congratulations to all those who participated in this conference and made it a success. Thank you so much.
Okay, thanks to Dr. Bhaldwaj as well. And it was a nice experience presenting.
Thanks to Dr. Chauhan also. Same here.
So we would like to say goodbye from here for now. So
Good evening.
We'll meet again. Yeah, Indrani Bose.
Sir, I wait for 1:30 till.
If you are having a PPT, you can present now.
Yes, sir.
Please. Indrani Bose, please share your screen. Dr. Indrani Bose.
Sir, I'm sharing, but not share permission. It's asked for permission, sir.
Or you can send us an email of the PPT if there is any issue.
Okay. Okay, sir.
Yeah, we'll consider it.
Okay, sir. Sir, I got schedule is last time, sir.
Hello.
Hello. Good evening, sir.
Indrani Bose.
Ji, yes, sir.
I am convener of this conference, Dr. Sharma.
Yes, sir.
Here. Actually, you are not able to present your presentation. So I am taking a decision that you should send your PPT through email or WhatsApp number. We will consider that PPT as a presentation, and we will provide you we will ask some questions, and we will provide you certificate on the basis of your answers. Okay?
Yes, sir.
Now you can send your PPT to us, and we will take decision according to answers asked by the question on the behalf of asked by the questions by us. Send to.
Thank you.
Send us. Please send.
Sir, I already said it WhatsApp.
Yes, you said you can send.
उसके बाद ही मुझे शेड्यूल मिला था सर, आज लास्ट टाइम मिला था
No
सुबह.
problem. You should send, and
Yes, sir.
we will take decision according. Yes, we have received. Now please see the PPT and ask the question accordingly. What is the topic?
Sir, a review paper in SBT.
What is the ceramics?
Ceramics is strontium bismuth titanate doped with erbium.
What are the major applications of the ceramics?
SBT, sir, major application in bioimaging, energy storage devices, and LEDs, memory devices, etc. Sir.
And how they prepared? They are prepared.
Sir, many methods of preparing, but we in our lab we prepare in solid state reaction method, high temperature solid state reaction method, sol gel method.
how many temperature is required for the preparation of the ceramic materials?
So, two type of temperature is cancellation temperature is 900 degrees centigrade and sintering temperature is above 1000.
What are major reaction occur during high temperatures?
Sir, if phase transition was maybe phase transition or single phase and as well as multi-phase ceramics are prepared.
Okay. Hello.
Yes, sir.
Now I am providing mic to the.
Yes.
Okay, so in Rani Bose, is
Yes,
there
sir.
any way you can connect the topic of your presentation with the theme of the conference, the sustainability and sustainable development goals?
Yes. Share करूँ sir? Screen
Yes.
share.
Can you please highlight the cost effectiveness or environmental sustainability of the research work?
Sir, my ceramic is non-toxic, so it's and biodegradable. So it's environment friendly. और solid state matrices की scalability भी बहुत अच्छी हो जाती है sir.
Yes, but what is the cost effectiveness? Is it like very expensive compared to the traditional?
No, sir, not so expensive.
Okay, not very expensive.
Yes.
Okay, yeah, thank you. That was the question. Okay, so they are like environment friendly and not
Yes.
very expensive, so they are cost effective. And what's the
Yes.
durability? Are they durable?
Yes, sir. Yeah, durable in normal conditions.
Normal temperature, they are durable. Okay. Okay. Sure. Thank you.
Thank you so much, sir.
So, is there any other question or any other presenter who would like to present? Okay, in that case, I shall close the presentations for today. Thanks a lot. I close the conference. Thanks.
Thank you so much, sir.